We are live with the APEC conference. I'm just going to start it up here while Tim gets ready. And our host, Tim Ventura, will announce the show shortly and announce our first guest. Welcome, everyone in the chat. We got Brian Kelly here. Mercury Interstellar LLC. All APEC invited this summer to Michigan for a build demo on gravity control and anti-gravity, the heart of de-entanglement from gravity-causing spectrums. Awesome. We'll have to get you on and maybe on the open chat later at around, 6 p.m. Eastern time. If you want to jump on the show, just let me know. I can get you a link, Mercury. And good to have you here. Hello, chat. Figgin Shao, Jeremy Goodoy, welcome, everyone. We are live, and I'll hand this over to Tim, and you take it from here.
Awesome, thank you, Jeremy. Okay, so let me do this. I'm going to mute everybody out. Okay, and I'm going to spotlight myself briefly, because Zoom has been acting a little funny lately. So, in 3, 2, 1, welcome to APEC. It's March 12th, and I'm your moderator, Tim Ventura. First, I'd like to thank everyone for joining us on this call, along with everyone watching us on YouTube. In today's session, Ron Evans is going to discuss gravitomagnetism and its role in gravity propulsion. Ricardo Storti will provide analysis on Bob Lazar's UFO tech claims, and Todd Desiato will discuss his experimental research into Biefeld-Brown and lifters. We're also going to have Mark Sokol and Falcon Space provide detailed lab updates, the results of their latest experiments. We're going to finish off the event, as always, with an open discussion and ad hoc presentations by conference attendees. So, our reminders, you can view those conference replays, details, and speaker info on our website at altpropulsion.com. Please save your questions for the Q&A session after each presentation. You could raise your hand in Zoom using Option Y on Mac or Alt Y on Windows. You can also type your questions into chat. We will go through those after each presenter finishes. Again, it's a little easier if you raise your hand in Zoom. That is Option Y on Mac or Alt Y on Windows. Okay, so now I want to introduce you to our first guest. Ron Evans, the former head of BAE Greenglow, will begin with the importance of analogues, understanding gravitomagnetism, what is inertia, free fall, Lazar's claims, the effective mass of a photon, and Einstein's gravitational redshift. Lastly, he will speculate about how a gravity field might be generated electromagnetically. In revealing this theoretical idea, briefly mentioned in his book, he's looking for experimenters in the audience to help test these ideas. So he joins us today to discuss gravitomagnetism and its role in gravity propulsion. Let's welcome Ron to today's event. I will hand things over to him, and I will be doing the slideshow for him. Okay. Ron, can you hear me, sir? And let me ask you to unmute. There we go.
Okay, am I ready to go?
Yes, yes, and welcome, sir. Welcome.
Welcome, and thank you for inviting me. Thank you.
Okay. So, would you like me to share? Would you like me to share your slideshow?
Yes, please.
Okay, let me see if I can do this correctly. You guys do it all the time, but I don't do it that much. So
I can't do it at all. Right. Am I ready to go?
You know what? I may have to. You are, but where's the play button? Maybe somebody could chat me, tell me how to play. Here, you know what? Ron, give me just a second.
Oh, I'm glad it's you and not me. I'd be panicking by now.
Yeah. Let me see. Slideshow. There we go. Play from start. Perfect. Okay, we have 12 slides. Can you guys see me okay? All I can see is the slideshow.
Okay. Am I off?
And you are spotlighted.
Okay.
Yeah, so I will mute myself out.
So the first slide is the cover of my latest book, the drawing, which is very wishful thinking, flying saucer on the moon propelled by gravity. And the drawings are all done for me by somebody called Dave Windett. I used to work with his dad when I worked for BAE Systems. So the book is in 3 parts. The first part talks about the theory of gravity from Newton up to Einstein. The second part of the book deals with the importance of analogues. And as I'm a mathematician, and analogues are so important to me. The third part of the book deals with Faraday's gravity experiments and also extending the gravitational theory by using an electromagnetic analog of gravity. The last couple of slides, we may find that after I've shown them to you, that they become secret. I don't know. I'm getting very frustrated. I don't know whether to tell people what I'm doing or say nothing and it all dies with me. So it's a risk. Next slide, please. So this is the analogues. This is somebody called Francis Bacon. He was a politician and he blotted his copybook. He did something he shouldn't have done, and so he got booted out, and he spent his time talking about science. He did a good job. He wrote his book, which is called, if I can find it somewhere, I don't know, there. Novum Organum Scientiarum. Anybody speak Latin? I'm afraid I don't. But the book was very influential, but only after Bacon had died. 30 years after his death, there was a group of people who had what was called an invisible college. In the United Kingdom at that time, the Civil War had been going on and you kept your head down. You didn't make a lot of noise. And so they had an invisible college. And at the end of the Civil War, when Charles II became king again, they made something called the Royal Society of London, which is now world famous, of course. The idea is that if you have some sort of mathematical model of something, and you then strip all the outside of it off, so you're just left with lots of numbers and equations, and then you look at something else, you find, hang on a minute, it's the same model. I've just changed one thing. One thing might be mass, another thing might be charge, and something else might be heat, and so on. You suddenly find the mathematician has suddenly got an insight into things he never realized were there before. Next slide, please. So these are 2 analogues. The one on the left, electromagnetism, was done by James Clerk Maxwell during the 1860s. He got his ideas from Faraday. Faraday, I think, also worked from analogues, but they were in his mind. He could look at something and think, oh, that's just like this, so I'll try an experiment. So there we are. The dot, if for those mathematicians amongst you, deep was called a divergence for things that spread out, and the curl at the bottom was something that Maxwell introduced. It's if you grab hold of the H as a line and you give it a twist, that's the curl. Maxwell said to himself, all right, I like analogues. I'll have a go at doing it. So he wrote out the equations that he thought might extend Newton's theory. The first one comes straight from the inverse square law, so that's true. The second one, it's true anyway, but we don't know what H is. It's a field, but what is it? No idea. Second one is true, especially if the G is the gravity. If gravity is not changing, then we get a static case, and we'll look at that in a moment. And the last one is very important, but we've never really realized it in operation. Next slide, please. This is a guy called Oliver Heaviside. He taught himself mathematics. He was absolutely brilliant at it. Now, in this slide, that column at the top in grey is moving with velocity v. It's a steady velocity. And around it, according to the analog, there is a field that's in green. Outside the body itself, it's so weak, no one has ever seen it. Inside the body, some people think it's quite large, but we don't know because we can't see inside the body. So Oliver Heaviside said to himself, the same as Maxwell and the same as others, if I look at the analog, what is it telling me? I'll compare it with magnetism. If I've got moving charge, I get a magnetic field outside. And I'm guessing if I have a moving body with mass, I will get a gravitomagnetic field outside. Next slide, please, Tim. Now, this is the important one for me. I'll read it to you at the top. It says, the curl of gravitation, don't forget, if I've got a gravitational line and I grab hold of it and twist it, I get a curl. So there we are. At the bottom, you can see the G at the back there. If I twist around it with the black circle, you can see I'm getting the curl of G. And it says it's equal to the change in gravitomagnetic field. So when the body moves and the velocity changes, we get acceleration. And it says that when you get acceleration, there is a change in gravitomagnetic field, which causes a curl of the gravitational field. Now, mass, that mass there, that grey cylinder of mass, only responds to gravity. So if you think about it, if you sat in the car and you accelerate forwards, you get forced backwards. Have you ever asked yourself, why am I forced backwards when my mass of my body only responds to gravity? Although you haven't realized it, there's a gravitational force pushing you back. It's an induced gravitational force, and it comes from the changing gravitomagnetic field. But we can't see the gravitomagnetic field, but we can feel its effect. Next slide, please. This is a strange one, because if you now drop your mass, I've just told you that it's going to cause a gravitational field. So if the body is dropped in a gravitational field, it will accelerate. And we know that from, my brain's gone. Who's the Italian who first did this? Anyway, if you drop a body, it accelerates with the acceleration due to Earth's gravity field. And from the previous slide, we know that there's an induced gravity field in the opposite direction. So we've now got two gravity fields operating on that body, and one cancels out with the other. So when you drop in a gravity field, you haven't got any inertia because it's been cancelled. So if you've got a spring balance and you try and weigh something while you're falling, you won't see anything. So it won't weigh anything. And this apparently was one of Einstein's happiest thoughts, which led him on to general relativity. You'll find that in my book. It's a long story. Next slide, please. Right, we're going quite fast, Tim. I hope it's okay. We might finish early. So what did Bob Lazar see? In 1998, I'll just look at my notes. I watched a film on the UK TV, and it was called Aliens Among Us. And it was produced by Tim Good. I taped it, so I've still got it, and it fascinates me. I look at it from time to time. I think, oh, amazing. I think the fascinating thing about it was Bob Lazar said that the technology he was working on came from aliens. Now, I used to know someone who worked at Area 51, He was actually British, or perhaps he was an American. I don't know, naturalized American. I don't know. But he said they did have a place where they tested alien technology, but it wasn't extraterrestrial. It was aircraft from foreign countries. So whether Bob Lazar got mixed up there, I don't know. According to this 1998 video that I watched, there was somebody on it called Stanton Friedman. Some of you may have seen the program or seen the American version of it. And Stanton Friedman said, look, this Bob Lazar is pretty smart. He's a clever guy, but he's got no professional qualifications. So you've got to take with a pinch of salt, as we say in the UK. If he tells you that something he saw works like this, it may do or it may not do. But what did he actually see? That's the question we don't really know at the moment. The next book, that was Timothy Good's book, which I've got here. And then there's the other one by, this one I quite like, it's got a bit more information, by Paul Violette, I think his name is. And in Paul's book, it gives you a little bit more information. It's all very limited. So for a long time, I've been looking, what actually did he see? You couldn't talk to academics about it because they would say, have you been taken in? It's all a lot of rubbish. It's nuts. So I didn't talk to anybody about it. I talked to some of my colleagues, but nobody else. And over the years, I sort of thought about it. Did he see it? And when these books came out, I bought them and had a look. But there's nothing there that I could really say, well, I understand it. He talks about an antimatter reactor. Well, I mean, I've looked on the web and I'll try to understand antimatter reactors. It's not a technology that's going to come very soon as far as I can see. When I looked a bit closer, both of them mentioned the idea that gravity could be channeled in a waveguide. And as Paul said, that's rubbish. If you've got gravity, it just goes through all mass. You can't stop it. So it can't be an ordinary gravitational wave if that's what he saw. Well, that bit stayed with me. It cannot be exclusively gravitational. And I've been thinking about it off and on. When I did my latest book, again, I concentrated on the second third, on trying to expand the analogues. And one of the analogues I looked at, of course, was thermodynamics. I did ideal thermodynamics mostly because I didn't want to bring friction in. I have mentioned friction, but without friction, it's a very nice analog. And I was looking at the analogues, and that led me on to something else, which I'm going to mention in a minute. Next slide, please. Oh, I think Tim has gone for a wander. I'll just keep talking about this one for the moment. So that my next slide, let me look to see what it is the idea of wave-particle duality. Now, I'm sure most of you now are familiar with the idea of having a wave and it can be replaced with particles. That's fine. So you can have a nice beam of electromagnetic waves, and you can think of it as a stream of photons moving along. I mean, a photon is just a figment of the imagination. They're useful to scientists because it allows them to put some numbers to it, and then we can draw pictures, and it's helpful. I don't know whether anybody's actually ever seen a photon. I doubt it. But associated with the photon is it's got a frequency, it's got a wavelength. It'll have, let me just look at my notes while Tim is not there. Oh, hello, Tim. Can we have the next slide, please? Yes, so it's frequency, it's got a wavelength, it's got an energy. This is Einstein's E equals mc squared, of course. And from Planck, we got E equals hf. H is Planck's constant. It's tiny, but he didn't know what H was. He didn't believe it to begin with. We now know that H is a fundamental thing in physics, but he didn't know. It's interesting to me that H is an angular momentum, and it relates to the gravitomagnetic field. Now go back one, please, Tim. And so the photon will have an effective mass. If you tell academics a photon's got mass, they'll tell you you're balmy. So I'm having to call it effective mass. So there it is. It equals hf over c squared. If it's got effective mass, you can guess that light or photons, if they go near a very massive body with a big gravitational field, they'll get attracted. So that's on the right, that picture there. A photon from a star will get attracted towards the sun. This was something Einstein first suggested. And another bit that I put on is that a photon has an effective temperature too. Again, from Planck's work on doing black body radiation, you can look at all the curves that they came up with. And there's what I've called Wien's forgotten the name of his Wien's equation. He shows that for the maximum energy of a photon, the wavelength for the maximum energy times the temperature is equal to a constant. So we've got temperature and wavelength. So temperature, wavelength are going to be related. Next slide now, please, Tim. So this is something called Einstein's gravitational redshift. He was a clever man, came up with it back in 1905, I think. It was tested by Pound and Rebka back in 1960. They used gamma rays. Unfortunately, by then Einstein died 5 years earlier. They used something called a Mossbauer effect. It was, I described it in my earlier book, which some of you may have seen, which is that one. So I've described how the Pound and Rebka did the experiment. So they showed it works, but it's for gamma rays. No one's ever seen it for light rays, as far as I know, although with satellites, they are trying to do it, or I think they may have done it with microwaves. The only thing about satellites is it's not a straightforward gravitational redshift because the satellite's moving, so you've got Doppler effect coming into it as well. Anyway, just by assuming the photon has an effective mass, and we're all familiar with the idea of a gravitational field, and you can move things up and you can drop them, and if you lift something up in the gravitational field, it gets more energy, so that when you let go, it drops down again and loses energy and turns into kinetic energy and so on. Just by using the fact that photon has mass, we can work out as it moves up, it changes energy. But we've already seen that the photon has energy hf. So if you move the photon up in the gravitational field, it changes energy, but its energy is hf. So if it's changed energy, can't change h. That's a fundamental physical constant. It means that the frequency's changed. And Einstein came up with this formula, which you can do yourself. It's fairly easy to do. No one ever tells you what's actually going on. If you just extend it a bit more and do the rate of change of frequency, you can work out the force on the photon. Is the change of momentum. And it turns out that what's happening is that the total change of momentum is zero. So there's no force on the photon. What the photon has done in changing frequency is created a gravitational field, just like I showed you for inertia. It's created a gravitational field which cancels with the Earth's field. So that photon beam going up doesn't experience the gravitational field at all, just carries on moving at the speed of light, c. Now, that's okay. If we look at it with the gravitomagnetic view, you can actually see it. There's our photon at the bottom. It's moving up in the gravitational field. Because it's moving up, it's changing its gravitomagnetic field. Outside, you might just be able to see it. It's so weak you can't see it. But inside the photon, we're assuming it's large, and it's changing because it's changing frequency, it's changing effective mass. As it changes, if you go back to my curl G equation at the beginning, you see it creates a gravitational field. That's the one that cancels with the Earth's field. So that photon there is moving up with no force on it. Next slide, please. I put this in because before I talk about the next step, this is something that somebody, when I worked, sent me this book and said, you know, you're interested in UFOs, read this. And the one page that I really like is page 110, if you've got it. I've got it somewhere. Whoops, up here. I quite like it. You may have seen it. What I want to bring out from it is the fact that the three main things that are associated with a UFO coming into land, the third kind, or second kind, rather. So you're not actually, I think it's extraterrestrials is the third kind. So this is the second kind. UFO very near. People say there's an electrical interference effects, car radios sometimes play up. Some people say there's a feeling of heat, and there's also a gravitational effect. I feel lighter. In fact, I think somebody claimed that their car tried to lift up slightly. So those are the three effects. If it actually lands, then there's more. It causes damage to things. Next slide, please. So this is my analog now. These are my last two slides. As I said, once I've shown them to you, you might find that people say, no, we can't tell other people about this. Right, so we start off when we do the analog. Let's assume on my left-hand side now, we've got a waveguide, which is filled with something that allows photons to move through it. So it could be a dielectric if I've got a photon source, which is beaming in microwaves or millimeter waves. What I do with the insert, whatever's in that waveguide, the dielectric, is I create a temperature gradient across it. Don't ask me what temperature gradient. This is a suck it and see experiment. We'll have to look at it again in a moment. But now, right, what I should have said was, can we go back 2 slides, Tim, just for a moment? That one, yes. What I didn't mention was it cancelled out the gravity field, but you've now, those photons going up there are changing frequency. Each photon and its frequency is associated with a temperature. So what we've got going up there is a change of temperature as well. That's not cancelled out. You've got a cold shift. So back to the slide we were on, please. So now when we're going up, we're going to come up with a very similar formula to Einstein, only now we're assuming that the photon, as well as having an effective mass, is also an effective heat source, which changes as it goes up the temperature gradient. So when we change, as it changes there, creates a change of gravitational, a change of frequency. So what it does, as in the previous case, the analog says, oh, as that photon moves up the temperature gradient, it creates a change and in frequency and gravitomagnetic field. And in doing so, it cancels out the thermal field T. So it just carries on moving at the speed of light. Speed of light in that material, of course, not the same as the speed of light in air or in space. But just a minute, we've said it cancels out the thermal field, but in it's exactly the same way, this time it's created a gravitational field as well. This time the gravitational field hasn't been cancelled. So in doing this one, we've created a gravitational field in a waveguide. So this made me think, hang on a minute, Paul Laviolette was saying what Bob Lazar saw was an was a gravitational effect, which he said could be put in a waveguide. But Paul Laviolette said, no, it couldn't, because you couldn't control a gravitational field inside a waveguide. But in this way, you can, because you are creating it within the photons. So the photon density is going to be important. So where you channel the photons is where the gravitational field goes and where the electromagnetic wave goes. So it may be very weak, it might not be, I don't know. We would like to know how to amplify the field. Now, just as an aside, on the right-hand side, I put a picture of Roger Schroer's electromagnetic drive. There's a few people's guesses at how it works. A lot of people don't agree with Roger's quantum theory view. There are other ideas. So I'll put this in as well. What happens, I mean, I used to work on stealth, of course, and one of the things about stealth is the intakes. They show up quite a lot. And one of the ways of stopping them showing up is to make them smaller so the waves can't get in and get reflected back out like cat's eyes on the road. So what happens here, as that wave goes up towards the red end, the waves are getting, well, they can't, you've got to have a complete wavelength as it moves up. If you can't have a wavelength, then the wave doesn't exist. If the wave doesn't exist, the energy's there, got to go somewhere. So the energy goes to the cavity. So by having that conical cavity and shining the microwaves in it, you're going to find that you get a temperature gradient. Now, if the model I've suggested from my analog on the left-hand side is right, this might say, well, in that case, what we are doing is getting exactly the same effect, and we're going to get a thrust on that cavity. So maybe this is another way of having a look at Roger Schroer's drive. Maybe we should try putting a heating collar around one end, see whether changing the temperature gradient makes any difference. Right, on to the last slide. This is a very suck it and see slide. So there you are, that's my drawing. I'm very frustrated. I'm not an experimentalist. I've looked around to people and said, you know, who can do this for me? So any of the people in the audience that think they can do it, I'd be delighted. I can't work with microwaves, but I can work with light. So what I thought was, well, I'll start off with, I'll have a go at doing it myself. I'll get a piece of glass tubing, which I got, and I've got a laser pointer, and I thought, well, I'll point the laser in the glass tubing and try to get it to go down there. By the way, the first person to do something like this was Faraday back in the 40s. He was the one that really started shining light down things like this. And this is where the Faraday effect came from, because with his analog in his mind, he came up with what was called the Faraday effect and the magnetic field around things like that. Anyway, getting back to this experiment, I've shone the laser along the glass tube. Wow, what it was rubbish. I just couldn't get the laser to go in. It just reflected off the front face of the glass tube. If you're a fiber optic experiment, if there are any of you fiber optic experimentalists in the audience, you will say to me, what you need to know is this. You do something and then the light will shine in the tube. I mean, we know it works because of all our telephone systems use fiber optics now. It's all based on light shining through them. So it must work. Maybe we need a bigger laser. I don't know how to do it. So I'm looking to you experimentalists to tell me. So we can start off. I want to create a temperature gradient across it. So you can see the shading that's supposed to be lagging, keeping it so it doesn't emit heat radially. So I can create a temperature gradient. So I'll start off, let's supposing I could make it work for the moment. And I measure the weight, and I then suspend it from a string horizontally. So I have to check everything out, make sure it's balanced. Then I have to shine the laser in. What I don't want to happen is for it to get an effect just from the laser, because I mean, that could be a photon rocket. So I have to be careful. So with the source on, and then I heat one end, again, I don't want it moving. So all that's got to be checked out. Once I'm happy with that, I can then go. I put the source on, I can heat one end, I get it. Does the string move? It's a suck it and see experiment. I don't know. You guys are good experimentalists. Michael Faraday, he would have done it for me. Unfortunately, he's not around. Perhaps one of you can do it for me. Thank you, Tim. That's it. Thank you. Now, do I take questions now, Tim, or?
Yes, absolutely. Sorry about that. I am just, Ron, let me do this. I am going to remove your spotlight. Okay, there we go. And before we do anything, let me put this thing on gallery view. Okay, and everyone, please give Mr. Ron Evans an enormous applause.
And for the audience.
Ron, thank you, sir. Thank you. And my apologies for some of the confusion. I don't do a lot of screen shares. And so, yeah, first thing I was like, okay, how do I do this again? You know, but then the other part, I'm sure everybody who's presented has seen this, is it hides some of the zoom controls, and some of the controls display a little differently, right? So like I couldn't see what time it was, and I couldn't see, you know, like who was in the room. It just kept doing these notifications, this person entered. So I was just like, okay, yeah, I'll make it through.
Right.
But yeah, well, so let's go to Q&A session. I'm going to allow participants to unmute themselves, and we're ahead of schedule. You are ahead of schedule, and that's totally cool. So we can go to discussion now. So again, let's let me go to here. You can raise your hand in Zoom using Option Y on Mac or Alt Y on Windows. If anybody has questions for Ron about this presentation, about his thoughts on Bob Lazar's story, or about BAE Greenglow, or any of the many things that he's presented. Ricardo, welcome, sir.
G'day, Tim. Thanks for letting me come on the show a bit later on. But Ron, I've got a question for you now. And it's relevant to me with respect to Bob Lazar, because I'll be talking about that next, and I'll be focusing on this particular thing quite a bit. The figure of 7.46 hertz that Bob Lazar stated, and was actually back in 1989, so it was over 30 years ago. Where do you think that came from? And is that relevant to what you were talking about previously?
I have no idea. I mean, it's obviously a microwave frequency, so it does make me think that whatever it was Bob Lazar saw, it's to do with microwaves. So I couldn't tell you. I have no idea. I have worked as an analyst on millimeter wave systems, and I also worked for several years on stealth, but I never actually I'm not hands-on to the microwaves.
It was actually 7.46 hertz. That's not a microwave frequency, is it?
It was actually, no, I think it was 7. Was it 7 points? You're right.
7.46 hertz, yeah.
Hertz, yes. I was thinking of gigahertz. Right. It's hertz, is it? Right. I don't remember that. Right. Okay. I didn't know. I should have to look at that myself. Do you want me to quickly look in this book?
Well, look, if that helps you answer the question, yeah.
Well, it won't help me answer the question. It just means I've been mistaken for quite a while, because I was thinking it was 7.6 gigahertz.
No, 7.46. That's it. Yeah.
I can't find it quickly, so I can't answer your question. But you've now put a question into my mind, and I will need to follow it up.
Okay. Well, you might actually be interested in when I get to my piece, because that's actually what I address very closely.
Right. I shall keep looking while you're talking.
I'm done. Yeah, that's it.
Oh, okay. Well, Ricardo, thank you. So before I go to Avi, you know, I had a question for Ron briefly. Ron, in terms of Area 51, and I know probably none of us know the scope. In fact, somebody posted this in chat. None of us know the scope of what may or may not be going on there. I know I know 2 pilots who have flown out of Area 51 in the Air Force. Both of them had all the proper classifications and all that for what they did. And both of them, I mean, obviously no one can talk about exactly what goes on, but both of them strongly insinuated that it was experimental aircraft and drones, right? Stuff that you wouldn't blink an eye at, you know, and neither one of them indicated that there was any kind of alien craft or anything like that there. Now, again, who knows? Maybe they're hiding them in the basement, or God only knows. But that's the scope of my knowledge there. You'd mentioned, I think, during the conference, your colleague had kind of suggested something similar.
Yes, exactly the same.
Okay.
Alien aircraft, not extraterrestrial aircraft. Yes.
You know,
Sorry,
and
can I just?
Oh,
sorry. I just sorry about this. I didn't mean to butt in, but I felt it's important. Bob Lazar actually never claimed to work at Area 51. Specifically, it's an area called S4.
Yeah.
So there is an important distinction, because even Bob Lazar mentioned, I believe in video footage that I've seen, that there were no extraterrestrial activities at Area 51. It occurred at S4.
Mhm.
So it's an important distinction that we need to make clear. Sorry about that.
Yeah. Well, and for my part, again, I know lots of Air Force pilots and several Air Force officers, you know, lots of military folks who believe in UAPs. You know, they all have their own opinions about Lazar. I won't go one way or the other about that. But yeah, as far as Area 51, these gentlemen didn't see anything, I mean, that would surprise anyone. So, but yeah, what you're saying, S4, I've seen that on maps. S4 is geographically located in a different place. And odds are, if you're testing fighter jets, you probably don't have a need to see UFOs, if any exist. So yeah, just my anecdote. I'm not making a yay or nay there, but let me go to Avi next, sir.
Yes, hello.
Hi, and can you turn your camera on, Avi?
It's quite late here.
Oh, okay.
So
Well,
I'm in bed.
Yeah, no, that's okay.
Anyway.
Well, go ahead with your question, sir.
So basically, my question is a few things. I see a few problems basically coming from the thermal thrust that should be initiated by the thermal gradient in your experiment proposal. For example, thermal thrust is a major issue in satellites. Pioneer, for example, has this Pioneer anomaly, if you heard about it. Okay, so you can maybe calculate those kind of things, expectations from Pioneer trajectories. So so this is like the first thing the first problem, for example, would be to isolate the difference between the thermal thrust and the proposal that you have. Second thing, gravitational frequencies are gravitational wavelength are very long. So in order to have a proper interaction between gravitational field, you're probably going to have to use much more long wavelength than light laser. So for example, light source with extremely long wavelength could work better. So those like my 2 points.
Mm-hmm.
Wonderful. And Ron, did you have a response for Avi, or should I go to the next question, sir?
I'd like to thank him, because this is what I want from the experimenters, to give me some ideas. Thank you.
Oh, okay, wonderful. Avi, thank you, sir. Let me go to John Quinn next. John, welcome back, sir.
Thanks so much. Thank you to APEC and all our organizers, and Tim, and especially our speaker right now. Very, very stimulating talk. And I'm really glad that Avi kind of set this up, going back to the gentleman's 7.46 hertz. So long wavelengths. That 7.46 times the speed of light, so it gives the wavelength of a number that's very close to the circumference of the Earth. So this could be a resonance between the Earth's size and the gravitational field around the Earth. And then some other thoughts that occur. You speak of the thermal gravitational kind of alignment, and that's perfectly in accord with entropic theories of gravity as well that are coming on the horizon. Particularly for me, a big one is entanglement entropic gravity. There's a particularly illuminating derivation kind of the Einstein field equation from that viewpoint, that in an attempt to unify the quantum and general relativity theories of the universe. And so along that line of unification, there's a great book, to your point of analogies, on quantum classical analogues. I believe it's by someone called Dragoman. And there have been some successful experiments that have been done in that field. So Lagrange-like points have been found in the quantum electrodynamic field. And this gets right back to the main topic, gravitomagnetism. The duality between the electric and magnetic field has a beautiful mathematical relationship, I'm sure you're aware of harmonic conjugacy. So it could be that what's needed here is a complex analysis, but perhaps on an octonian or just kind of higher dimensional complex number, to speak loosely. There's some interesting results in this regard from people like Cole Fury and her references back in the 70s. I don't see too much though on there's some pretty big problems, people say, kind of the big gravity people. We might be able to keep it real and complex rather than going to any larger fields. I don't know what your guys' thoughts might be on that type of stuff. It's intriguing though. As far as I've looked into it, Cole Fury's theory, I think a lot of people have dropped that name in here. Looks very intriguing. So sorry, just a couple thoughts that occurred. But I really want to thank you and congratulations. It looks like a great book. I got to get a hold of that as soon as I can. And I think there was a professor, Ronald Evans, here at UCSD. Is that in San Diego, where I'm located now? Is that that's probably a coincidence?
Yes.
Yeah, I think that's a coincidence, John. Because Ron he's out in what, you're in London, right? Near
Not
London.
now, near London, yes.
Okay.
Relatively speaking.
Yeah.
In the UK.
Apparently, we're all within 7.46 of a light second.
Very good.
Yeah, if I could ask, and this would be the audience to ask, didn't Tesla have a quote unquote magic resonance frequency that was right around 8 hertz? Wasn't that a Tesla thing? I remember reading something about that.
I think you could be right.
Yeah.
There's a big noise hump if you just turn on a like spectrum analyzer right around 7 hertz. I think they do say it has to do with the ground, being the Earth and its size. But it always seemed to me that it should have the resonance kind of link, the wavelength of the Earth's diameter. So I had to check that calculation, but it looks like it's closer to the Earth's circumference, the wavelength implied by the 7.46 or 8 or so, right around there.
Yeah, that range. Yeah, and again, I don't want to jump in too much because I'm supposed to be moderating. I read a book, this was years ago at the library, and it was a book on lightning resonance frequencies, and they were talking about the Earth as a capacitive circuit, right? And they had an entire section that was taken from Tesla's notes. I think the book was written in the 50s or 60s. And I remember that was a quote unquote magic frequency. It was right around 8 hertz, somewhere in that range. So he said that was the Earth's natural harmonic frequency, for what it's worth.
It's kind of funny because, 8 billion people, we're almost there. 8 hertz, you know, like if you want to, it could be a derivative number at the end, like more people, more energy, it increases, you know, that whole field.
It's 7.8, I believe.
So, okay. Thank you. So let me see. Let me go to Harold next. Harold, sir.
Oh, thank you. Great presentation. I missed part of it because I have problem with my web, but I will review it. But I have a two-part question that you may answer in one shot. The first part is, I have been reading a lot of papers on magneto gravity, you know, and machine basically and other. But every now and then somebody point out, write a paper that says, no, you know, magnetogravity does not exist, you know, that he was wrong, you know, when he wrote it about when he created that part. The second part is, if you let your imagination run wild a little bit, tell me, what does a gravitomagnetic propulsion system would look like for you? What would it accomplish, you know, how, you know, the mechanism, you know? Can you answer that question, you know, because look like both of them are tied to that, to your answer.
Do you want me to try to answer that, Tim?
Please.
Yeah, go for it, sir.
Gravitomagnetism. How would it look like a propulsion system if it were that, you know?
Well, if you looked at my diagram, I showed you when a mass moves, the model, the analog model tells you there's a gravitomagnetic field inside the mass and outside. Outside, it's tiny.
Yes.
Some astrophysicists tell you that huge stars which rotate, the effect of the jets from their poles is due to gravitomagnetism. I've no idea. However, if we come back to my look at that model, and I told you about the curl of gravity term, which is induced by the changing gravitomagnetic field inside the body. And that leads to inertia, or no inertia if you're in free fall. So to answer your second question, if I could actually artificially change the gravitomagnetic field inside the mass, I would create a gravity field on the mass, and the mass would be pushed or thrust.
Okay, so it will be more like the something opposite to gravity, that in the presence of gravity, it will repel gravity itself. Is that what you're saying from that answer?
What I see is a gravity field being created. I mean, the mass has got a gravity field of its own, but it's small. If you create a large gravity field, which is unidirectional within the mass, it'll be unidirectional because of the circular change of gravitomagnetic field. It acts along the core. So it'll be unidirectional and it will give that mass a thrust.
Okay.
That's how I see it in my mind.
Yeah, okay. That would look like in the presence of, let's say, in a body with gravity, when you produce a gravitomagnetic field, because it will be pushing against the other gravity, basically, it will create a propulsion system, you know, basically that will run away, overcome the gravity of the body attracting the body that is producing the gravitomagnetic field. Is that how I summarize your answer? Would that be correct?
I think my answer would work in free space where there is no very little gravity field.
Oh, okay. Okay. All right. So I appreciate it. Thank you. I'm going to review it in your YouTube when Tim plays it because I missed part of your presentation and I regret it. But thank you. It looked like from what I saw, you did a good job. Excellent.
Thank you.
Thank you.
Wonderful. Harold, thank you, sir. Okay, so we've got about 5 minutes until the top of the hour. And again, if you want to ask questions, it's Option Y on Mac or Alt Y on Windows. So Ron, you are ahead of schedule. We have an hour. What we could do is we could go at the top of the hour, we could go to Ricardo Storti, who was going to be presenter number 2, but he is here early. Or alternatively, if you want to talk more about BAE systems and Greenglow and things like that, we could do that as well. It's up to you, sir.
Well, I mean, Greenglow started when I was at what was in those days was called British Aerospace. And I joined the aerodynamics office, and I worked there on the propulsion section. And then in 1979, the publicity department where I worked, Walton in Lancashire, near London, about 350 miles north of London, they got a picture from what was called the Yorkshire UFO Society. And it was a black thing that had been seen flying very low over the North York moors. The UFO Society from Yorkshire didn't know what it was. They sent it to British Aerospace and said, "Is this one of yours?" And we said, "No, don't know what it is." We found out the following year it was an F-117 flying over the North York moors. We found out because the chief aerodynamicist was asked to go down to Farnborough, which used in those days to be the Ministry of Defense Research for Aerodynamics site. And an American Air Force general, I think he was, gave a presentation on the F-117. When the chief aerodynamicist came back, he said, "Right, I want someone to get our act together, but we want a proper stealth program to make sure we can know what's going on." And I was tasked with that job. One of the first things I realized, which I hadn't realized before, was in the late 40s and early 50s, the United Kingdom, some of it based on German technology, was one of the leading countries on stealth. All the airplanes, the Vulcans and things like that, had all been stealthed. So we'd had a lapse of probably 30 years where we hadn't really, at British Aerospace, we hadn't extended it. However, Farnborough had been doing it. They hadn't stopped. So that's really that. From there, I got, because I was working on stealth, another group that was working on future technology thought I knew about microwave systems, and they had a millimeter wave program. The idea was that they could detect Russian tanks, in fact. And so I got moved as a mathematician to go and help them with their analysis. And from there, when that work sort of finished, the boss said to me, "Well, what do you want to do?" And I said, "Well, I'd rather fancy looking at gravity, because as an anti-stealth measure, it could be, make all the stealth work rubbish. All our stealth effort that we're putting into it, if we just come up with a thing that picks up on mass, we can do it." So he said, "All right, go ahead." So that led on to looking at mass and gravity, and then thinking of, well, how do we understand gravity? And then that led on to the Greenglow program.
Okay. Well, so Ron, we're just about at the top of the hour. It looks like we don't have any more questions. So why don't I do this? Riccardo, would you be open to going?
I have a question.
Okay, go ahead, Lulu.
Hi, 2 questions actually. One for space and one for humans. For space, could that possibly, if we use that, like the gravitomagnetic, to clean up the space? Like, if gravity, we beam the same gravity to attract junk, things like that, to clean it up. So this is for space. And then for what you were talking about, like in history and, all the different experiments that you guys, led back then, and you don't have a feedback. Are human genetics somehow were experimented on detecting, like ESP, an extrasensory perception. I don't know how exactly how to explain it, but just knowing without, using your 5 senses. And then when checking, it validates itself. So were there like experiments for humans to detect these objects? Like they just kind of feel that there's an object there. And then, just these kind of questions. And, I know you said some of these things you don't want to talk about because, it could lead to things, but like existing on a different field than what everybody else is existing, because you're raising the frequency, the shift. So if you create these, atomic structures on a higher redshift, higher level, and their existence is always like that, wouldn't that change the knowledge it would relativity theory? Because
Oh, okay.
You know what I mean?
Lulu, you're breaking up a little bit, but I think we have your questions. So Ron, what she was asking, I think there were 2 parts. One of them was, could you use gravitomagnetism to help clean up space junk? That was number 1. And then number 2 was I think she was talking about something similar to remote viewing, detecting these objects without necessarily using radar. That would go to kind of your stealth stuff. Do you have any thoughts on that, sir?
I think it's too early for me to say. On the first part of the question, can you use it to clean up space? I'm intrigued in my own mind what is going to be said about Bob Lazar bending these gravity fields. If it's possible to bend in a microwave guide, I'm always interested in end effects. There's always end effects. Does the field come outside? Is there a tractor beam? If there's a tractor beam, then yes, in the long-term future, we might be able to use it to clean up space. The second part of the question, I don't know. I need to think about it.
Okay. Well, thank you, sir. Well, again, why don't we do this then? I think again, we are at the top of the hour. Ron, I want to thank you so much for your presentation. I think what we should probably do now is go to Mr. Ricardo Storti. But before we do that, I want to put this. Oh, Jeremy has a question. Okay. Go ahead, sir.
Well, I just wanted to, before we moved on from that one point about like some of that remote viewing stuff, and I'd want to pay attention, tell people to go and check out that BBC segment that was done on you, Ronald Evans, where you went into that place where they at British Defense, and where they have that hypersensitive, quantum system, right? Where the slightest perturbation. So if you were to create a warp field or a gravity field, this thing would be able to detect that sort of stuff. And I'm wondering if they've done any experiments with, why don't they take the whole entire barracks out and see if they can mentally try to alter the state of this thing to get it to go one state or the other, and see if they can train soldiers to affect these quantum fields using mental states. I think that would be a valid experiment.
Talking about that higher different frequency. You're talking about higher different frequency. You're talking about quantum in a quantum field state.
Well, it's the same thing that they did at SRI with Ingo Swann. He was able to affect this hypersensitive magnetometer at like a couple floors beneath, using brainwaves apparently. So I just thought it would be an interesting experiment to try, and worth mentioning that they have this equipment at British Aerospace, and probably they could build such similar systems at laboratories around the world, so.
Yeah.
But it's a quantum target for training is basically what I'm, the idea is.
Well, Ron, did you have any thoughts on Jeremy's suggestion?
The work was done at the Ministry of Defence's Photon Down, which is the research centre. British Aerospace didn't have any input to it. It's just an idea that we had. Just with an ordinary gravitational system, you can detect a battleship at 3 miles. What we wanted to do was detect an aeroplane with a similar system. and we didn't know how to do it. And they mentioned this quantum gravity gradiometer, which is getting more sensitive year by year.
Yeah, that's super interesting. That research into that, because there's a lot of different applications. Not just in that, but I also think for validating some of this remote viewing stuff and some of the claims that I've read before, but never seen. I've never done any or engaged in any personal experiments into that sort of thing. But I think it would be it would certainly be worth the effort. But
Wonderful.
to see if there's any connection between this consciousness thing that seems to be a prevailing topic and argument in a lot of these mainstream discussions of the physics behind UFOs and stuff lately. So, but anyways, yeah, excellent talk and thanks for coming on again.
Thank you, Jeremy. Okay, so now we're starting to get questions. Let me go to Thomas then next, sir.
Can you hear me?
Yeah, and
Okay.
welcome back.
Thanks. I was just going to say basically what Jeremy's talking about, the concentration of a group of people affecting something. That probably a good resource to start from would be to look into the PAIR program at Princeton University and the people who opened Celeron.com, which they have mined devices and basically there's no physical connection between the people and the device, yet they're able to concentrate and switch them on and off according to a lot of the data they've gathered. And they've actually gone further, showing probably a greater degree of understanding of that phenomenon by applying it to building devices that can detect buildups so that it can predict when someone's going to have a seizure too, which I have a friend who actually had one with him that had very severe seizures due to I guess it was a reaction to given so much of a drug that it should have killed him to help him get stop smoking over insurance policies and stuff like that. And he had them when he was younger, outgrew them, and then this brought it back, and they were able to basically really lay down a timeline of when all of these seizures were happening, and the ones that he was conscious for matched perfectly. So he's assuming that the ones that it detected and while it was monitoring while he was asleep were also accurate too. So being able to basically switch flip the script to basically use that device not just for basically a person to be able to concentrate and control something, but to be able to use it to detect something that's going on in the human brain. It seems like there'd be a wealth of information from those those university professors that were working on that, and all of their protege that were also working on that same project, gathering immense amount of data on that. So and PAIR is I guess acronym is the word for it, like NASA, Princeton Engineering Anomaly Research. So if it makes it easier to find, because I know when you look for PAIR on Google, it throws a million other things at you that have nothing to do with Princeton, even if you include the Princeton University part to it for some weird reason. And I know years ago you used to get exact results back then. So, and maybe compare notes too between that and the documents that were put out for a Stargate project, like the technical remote viewing manual and stuff like that. If you're going to look down that route, they seem to all come together on that, even though they're all completely different and disparate individuals that have nothing to do with each other. So, just throwing it out there. If anybody needs links, I have the very rare and difficult to find software available on a Google Drive. If anyone wants to try to take advantage of it too, where basically you use your mind to control images on a screen, called Shape Changer. So something that the PAIR Institute put together while they were researching this and investigating and whatnot. So
Yeah. Thomas, thank you. And if I could interject, I actually did a story on that, and I interviewed Dr. Forgetting his name, I'm spacing out, but one of the principal researchers from the Noetic Society on it, and they did get results with it. That was what he'd indicated. So
I was going to say the other thing to look into is the fact of, since they had this success with this, they were building devices. Look into the mechanics and the physics of those devices, possibly for further insight too. Because I mean, most of their successful devices they were able to control with they were exhibiting control from the mind, and identical devices sitting right next to each other halfway around the world, able to basically affect one without affecting the other. were mostly built around a device that was detecting the massive amount of thermal energy variance that occurs from Brownian motion, injecting thermal energy into a component. So, there may be an awful lot of like a treasure trove of information that has been kind of dug up with all this research, but now they don't know what to do with it, because they had their mind on one thing, and you may be able to apply that to something else. I mean, I'm finding that with a lot of what I'm doing for developing replicator level, capabilities for 3D printers, is that I find when I get an idea of how to do something and I start doing a little digging online, I find that other people, for another completely different reason, have done an awful lot of research and development, and there's a lot of equipment already available that's just not being used for three-dimensional deposition on a level where you could print out an LED, from raw and scratch on a countertop, stuff like that. So just bringing the pieces together, it might be, we may have all the, in other words, what I'm saying is we may have nearly all of the components you need. You just got to figure out what they're being used for, and bring them all together, and then you've got a off-the-shelf solution for whatever it is you're trying to build, that once you prove the function, then you can maybe get the the parts you need more custom tailored to your means of production too.
Yeah.
So,
Well, so let's bring this back to Ron. Ron, what are your thoughts on that?
Oh, I'm just trying to, like you, I can't remember somebody's name. We had somebody from Cambridge, the superconductors switchman. What was his name? Professor?
Brian Josephson.
Exactly. Thank you very much. Well done. While we were there with Greenglow, we had him come and talk to us. And he was very much talking about consciousness. I'm not sure whether he's still alive. Is he? I have no idea.
Yeah,
he is,
he's on Jack Sarfati's list. So
right.
Yeah. So yes, he's quite active.
We never followed up any of his ideas, but it was interesting that he was. I mean, we had lots of interesting people on Greenglow come along and talk to us about different subjects.
Oh, okay. Let me go to Morgan next, who has been patiently waiting. Sir?
Hold on. I just want to inject one real quick last thing.
Oh, okay.
There's a lot of misinterpreting and misdirection of information that just, I think is, it's not intentional, but I see like with the double slit experiment, just as a real quick example, they're assuming that observation is causing the change between the double slit experiment, when in reality, if you look at what they're doing, they were using electromagnetic equipment that puts out an EMF field, meaning there's a vibration that basically forces all of the EM fields within the atoms in the slits to then synchronize instead of being completely randomized. So it's not the observation in that instance necessarily that causes the switch, but rather you altering physical properties of the experiment with the equipment you're using to observe, and kind of filter all of those, bad assumptions possibly out as best as possible before moving forward to dig through all the existing information too. So I just wanted to make sure what I had already laid out there as far as digging out that other information didn't end up, accidentally bringing a bunch of bad information into it too that people aren't aware of, and therefore it ends up tainting your whoever happens to be trying to do this, their end results. So I can go ahead and mute out and get out so he can talk now.
Yeah. Well, Thomas, thank you. Yeah, and we should probably come back and touch on the double slit thing. Actually, I've read some interesting new models there recently, but yeah, let's go to Morgan first, though. Morgan, sir.
Okay. Yeah. Hello, everyone. Again. So, Ron, I was just thinking about this experiment you were proposing with this laser inside some tube or whatever, with heating on both ends. The first thing that came to mind were these fiber optics, and a lot of times what I've seen it with people use is actually the laser light itself is used as a source of heat. Okay, so you might not need a light source as well as like some sort of heating source, but the laser light itself could be a source of heat as well. And then that right there just alone came to made me think of these experiments from Martin Tajmar on these. He has these fiber optic loops to test essentially a variant of the M drive. I was trying right now to go and look through his webpage to see if I could find the actual publications, but essentially a benchmark test like what you were describing may have been done with these experiments from Tajmar, and I'll see if I can find some links from those. But but sound very similar to what he's been doing. And so at least it's an active area of research right now. So I'll see if I can find his links. But yeah, no, it's cool idea though. But yeah.
Wonderful. Thank you. Thank you. And Ron, did you have any thoughts on that, or?
No, I talked. Well, I talked. I've not met Roger, but I email him and talk to him on the phone from time to time. I don't know where he's up to at the moment. Hopefully, still successful.
Okay. Well, let me go back to Harold, sir.
Yes, Ron. One more question. I just remember your experiment. I saw part of that you're proposing. But in Gravity Probe B, they collected a lot of data, and they proved that there is a gravitomagnetic force, the force being produced by the star, I think it was Alpha Centauri, and they proved how many arcs per year it would deflect the gyroscope, producing a force. Would the data in Gravity Probe B serves also as a way to verify your experiment that you have proposed, or that it will validate your ideas? Would that be some data? Would that be useful to you?
It could be. I mentioned Gravity Probe B in this book that I wrote before, and it talks also about, there were experiments done in New Zealand using the world's biggest ring laser gyro, which was trying to find the gravitomagnetic field of the Earth. It's too small to detect. This is the problem. Outside the body, the field is too small. This is why Gravity Probe B was using the size of the Earth as well, and they were trying to look for an effect across space. And it took them, I don't know how, I think over 18 months to collect the data and manipulate it to get an answer. We're talking about a field which is tiny, but in my view, if we could control it, it makes a big difference.
Oh, okay. That's about an interesting. I hope they find. All right, thank you.
Thank you as well, Harold. I was actually doing some looking while Harold was asking his question about. So what I found was double slit experiment validating simulation theory, and I couldn't find the paper that I wrote about it, but I did read an interesting one, and it was a different take on the double slit experiment. What they were saying was, if any of you guys are computer guys, you know that they conserve processing in game engines, and one of the ways is by processing things differently that the eye isn't going to see, and so there was a really interesting paper that looked at the double slit experiment, and they said we are living in a simulation, and if you were writing software, this is how you would write it, and this is the double slit experiment kind of validates that. But so again, we can come back to that later. Okay, so who has more questions for Mr. Evans?
I do.
Go ahead, Alex.
Okay, Ron. Listen, a long time ago, Tesla built a spacecraft, two-man spacecraft, warp drive, with 8 warp cores and a stator that spun around and gave an electromagnetic field. Okay, he did that in 1899. He did it in Colorado Springs at the time, and the little bit later, about 1938, the Nazis took his work and started making Bell crafts on it, anti-gravitational craft, which I think Tesla also built 2 doorways. Well, like 2 doorways. Yeah, one doorway you can walk in, and the other doorway you come out a half mile down the road. So, I think it's under Einstein's boson, point A to point B. Do you know what I'm saying?
I know what you're saying, but I don't understand it. It's beyond me.
Okay.
It's beyond me.
Okay, because when I was at Area 51, when I was running Area 51 back in the day, I asked the head guy, it was James Roberts, who was a colonel. I said, would you show me all Tesla's information and all his experiments? And he took me into Los Alamos in a vault, and he showed me all this stuff. And I thought it was interesting, and he was explaining to me about all the different experiments he had. You know, he had 700 patents with working patents.
Wow.
Okay. Well, thank you, Alex. Thank you.
Hmm.
Okay. So let me see. We're at 1:20 now, Pacific time. Do we have more questions for Ron? Okay, well, why don't we do this then? We're not at the top of the hour, but why don't we put it on gallery view? And I think Ricardo is still with us. Ricardo, did you want to start your presentation now?
Yeah, look, I'm happy to.
Okay, well, let me do that. So before anything else, let's all give, and again, a giant applause for Ron Evans. Ron, thank you, sir. Thank you again for coming back and presenting on that.
Thank you.
Okay, so let me see. Oops. Let me put this thing back on speaker view. So before anything else, I'm going to mute everybody out. Okay, and I want to introduce you all to, and of course I don't have his info here. Here, let me do this. Fortunately, I have that all up on the website. Okay, so now Ricardo Storti will be doing an analysis of Bob Lazar's propulsion system claims. He has written a paper on this on ResearchGate, so I'm going to paste the link to today's presentation in. There is more online there, and I'm going to paste this into chat right now, but he'll be doing a presentation as well. Basically, he's going to go through the assertions that Bob Lazar made regarding EM propulsion that he claims to observe at Area 51's S4, right? So it's not Area 51 proper. Right. And he's testing them against the EGM construct, I believe. So, correct. So let's go to Ricardo. Sir, let me hand it right over to you, and thank you very much for presenting for us.
Okay, look, good. I'll say good morning to everybody from my point of view. It's Sunday morning here in Melbourne, Australia. So good morning to everybody, and thanks for having me on the show, Tim. I appreciate it. I'm going to try and screen share now. So let me just see how this goes. Okay. Yeah, share. All right. So you guys are seeing a couple of circles there?
Yeah, perfect. Yep, it looks great.
Okay, great. All right, great. So I'll just pop up the presentation and just move stuff around so that I can see it myself. Here we go. All right, that's good enough. All right. So what I'm going to do here is scrutinize three very specific scientific claims that Bob Lazar has actually made. I'm not going to deal with any theoretical descriptions of how this stuff's supposed to work or anything like that at all. I'm focusing specifically on the scientific claims that he's made. I'm not going to talk about his story. I'm certainly aware of opponents like Stanton Friedman, who I'd actually had some conversations with prior to his passing. So I'm not going to get into that. I'm focusing purely on the scientific claims that he's made. Now, he's made three scientific claims that I'm aware of. You could probably break at least one of these down into a couple more, but the three that I've listed here is the gravity A wave pulsed at a frequency of 7.46 hertz. That's the first claim. Second claim was that the apparatus in the spacecraft, in the sports model as he described it, operated in the microwave frequency range. And the third claim is that the antimatter power supply required a very specific manufacturing process. what I've got listed there are a couple of recommended minimum viewing articles. I would suggest to people that if you haven't actually seen it, try and have a look at those two there. So the first one is a movie or a film that was put together by Gene Huff and Bob Lazar in 1991. So a couple of years after after everything became public in 1989. And that was that's really a pretty good one. I liked it. It's converted from videotape, so the actual size of the viewing window on screen is pretty small, but it's worth enduring it. The second one was done by Jeremy Kenyon Lockyer Corbell, and you're probably aware of this video, and I've actually included in there down the bottom a couple of specific time indexes that you can refer to. Once again, I think that's good viewing, and in particular, the second video there, the most recent one, shot in 2018, deals with some information that wasn't revealed in 1989 in terms of how a cone of moscovium, or element 115, is actually sliced up. So I'd suggest people have a look at those. I'll move on to the next slide. So there's some graphics from the Bob Lazar webpage of how the apparatus actually worked, and you'll see up here there's a gravity amplifier that housed the element 115 or moscovium. And again, there are pictures available of how that was actually put together. Ken Wright has probably the best description, visual description that I've seen so far. So you can visit a page by a guy called Ken Wright. He met with Bob Lazar in 2000, I think it was, and must have spent quite some time with him. And sort of put together the page that he's got now, and told some of the more technical aspects of the Bob Lazar story. And look, I also make no claim whether Bob Lazar really worked at S4, as we've talked about. It's not Area 51, S4. Look, I don't go into that. As far as I'm concerned, the only real proof that exists, it's not even physical proof, the only real proof that exists is the proof that you can verify for yourself. So if you see someone on TV or YouTube that's got something flying around or whatever, you can't trust that. You can't believe that. It could all be doctored, could all be fake. So the only real proof is the proof that you can verify for yourself. It's not some government document that Stanton Friedman, for example, would rely on so heavily. The very first thing that Stanton Friedman, well, one of the very first things that Stanton Friedman said to me when I had contact with him was, do I have documented proof? And my reply to Stanton was, look, the only real proof is the stuff that you can actually prove for yourself. So that's really important in the presentation that you're going to see, or that you're seeing now, because it's all about proving stuff for yourself. So again, with claim 1, 2, and 3, the next obvious question is why, for example, is gravity A wave pulsed at frequency of 7.46 Hertz? Why are the gravity amplifiers working in the microwave frequency range as so claimed? And why is the antimatter power supply, why does it require a specific manufacturing process? And that's what we're gonna deal with. On to the next slide. Okay, so here I've got a diagram of the physics architecture behind the answers that you'll see coming up. At the bottom here, I've got a pyramid. Bottom layer is general relativity. The next layer is polarizable vacuum, or the PV model of gravity by Puthoff. On top of that, we've got 0-point field. model example, the Casimir effect. Along the side here, you've got it's a method. It's not a theory. It's a method called electrogravitomagnetic. So now that's something that myself and Todd have developed over many years. That leads to up here we've got particle physics. There's a whole bunch of particle physics stuff that Todd and I have derived, some of which, actually much of which has been experimentally verified or experimentally implied. For example, we have exact solutions for the radius of the proton, the neutron, etc. That's all been published, and you can look it up. Exact solutions for those, which have been experimentally verified to many significant figures. On the side here is where claim 1 begins, but I'll come back to that in a moment. Just moving on. Particle 2. You can see that claim 2 comes from the particle physics works that we've done, and claim 3 flows onto that. Over here, a critical component of that is the Moscovium. Here, particle physics leads on to cosmology again. In the cosmology space, everything that I've done in that space, Todd hasn't had a great deal to do with that, is experimentally verified. So throughout all of the work that myself and Todd have done, almost everything leads to an experimentally verified result. So we don't just whack up equations and say that's it, that's the solution. No. We actually take it to the next step, produce the numbers, and actually check those numbers against what's actually seen in the real world. Then from cosmology, it eventually passes through cosmological inflation and ends up in basically Todd Desiato's warp drive concepts. And the reason I've listed that here, and Todd can speak to this at much greater length later on, but the reason I've put that in here is because the work that I've done, my cosmology work, and again, that's all available online, is that I demonstrate that within the first 10 to the minus 23 seconds of the universe, the velocity of light during that inflationary period actually expanded to about 10 to 38 orders of magnitude above above the value of C. Again, that's all documented. You can have a look at that, but I just wanted to move through that. Going on to the next slide. Okay, claim 1. Now, the gravity A wave pulsed at a frequency of 7.46 Hertz. Why? Okay, now, when you actually, okay, I'll just come back to this slide. Here you'll see to the side here, I've got claim 1 and I've got Fourier quantization. So what I've been able to do, what Todd and I have been able to do is demonstrate just using straightforward mathematics, no experimental, no physical theories are required, nothing at all. You can actually decompose the number 1 into a quantized Fourier spectrum. Now, when you do, what you end up with is that greater than 99.9% of G is cancelled in the first 415 harmonics. So that leads to at the bottom of the garden that's actually doing it. But what I'm presenting is the mathematical evidence to support that claim. And that's exactly what we get. We get 11.44 gigahertz. It's right in the microwave frequency range. We get that frequency acting, extending its influence, an inch beyond the nucleus. So again, that to me is, look, it could be coincidence, but to me, it's a remarkable coincidence at the very least. Claim 3. Now, claim 3, some of this actually appeared for the first time in 2018. So what Bob Lazar did say in 1989, which has not changed, was this wedge element here, the cone, etc. That has not changed, especially this wedge element. What has changed in the 2018 video, Bob mentioned that the cone had to be sliced up into these dashed lines that you can see. And he, by his own confession, said there was no rhyme and reason for it. He couldn't understand why it was the case or anything like that. So that intrigued me, and I investigated, and this is what I came up with. So in 2000, when Ken Wright put together his site, and I'd encourage everybody to go have a look at that. This diagram on the bottom right hand side is actually a direct image from the Ken Wright's site. We've got 12 discs here assembled into a cylinder. That cylinder is then machined into a right circular cone, and then from that cone, slices are taken and wedges are formed, and that's step 4 here, and that's the central wedge there. Now, what I've been able to determine is that on the right hand side here, he had 12 discs, and Ken Wright, neither Ken Wright nor Bob Lazar say or even mention that there are 12 discs. At the most, Bob Lazar says in 2018 there were many discs. So that number 12 from the Ken Wright site is very, it's dubious. It can't be trusted. It's there for illustrational purposes only. Well, what I actually did was using I showed you here before, using the fundamental wavelength here. When you take a quarter of that, you end up with 6.55 millimeters. So that means a quarter wavelength. So it occurred to me that for these discs to transport them, etc., a quarter wavelength would be the optimal size, because at a quarter wavelength, the effect on the face of the disc is effectively switched off, or at the very least minimized. So I ran the numbers again. This is all available with the link that Tim should have given you. If not, you can reach out to me. I've calculated that there are in fact 16 discs, and again, using that quarter wavelength, I was able to actually calculate what all these slices were, the number of slices, the angles that they had to be, etc., all based around that quarter wavelength idea. Because Bob Lazar says that there was no rhyme or reason as to why it's sliced this way. He couldn't even specify the angles, certainly in the 2018 video. But if you look at it, you see when he draws it, that's exactly what he comes up with, pretty much, is what I've got there. Anyway, I've run all the numbers on that, done all the calculations, and that's what it turns out to be. And it turns out that 2/3 of the actual Moscovian material is milled away from this cylinder. So that right circular cone is about it's about 1/3, or exactly 1/3 of everything that's in that cylinder. So that means, I think, basically from 3 cylinders, you'll get 5 cones or something like that. Now down here, you'll see the primary wedge, number 1, is the thickest. But here, just to help everybody understand how this works, is these dashed lines represent the slices. So, for example, so slice 2, I've got the number 1, 2, 3, 4, 5, etc. So slice 2 here would actually mate with slice 2 prime. So you'd slice up the cone into these sections, and you would mate slice 2 with slice 2 prime. You'd bond them together, and that would then become that final wedge would then become a new piece of material to run the antimatter propulsion system. So if you look at the Bob Lazar videos, you'll see pretty much the design that he claims was being used, and he talks about element 115 transmuting to 116 and thermionic conversion, etc. Blah blah blah. So you guys can sort of investigate that for yourself. But if you are looking to get specific and very precise dimensions, etc., then again I refer you to the work that I've done and the link that Tim's sent through. And one thing I should also point out is that the design, these wedges really try and, if possible, look for single atoms of moscovium to amplify the signal. So where possible, you want to end up with these fine points, or it might be slightly rounded. There may be a bit of practicality involved, but basically that's it. You're looking for a single atom, some kind of solution for a single atom that gives you the clearest and easiest signal to actually extract and amplify. Okay, moving on. So in summary, what we've shown is this, that Bob Lazar's first claim of 7.46 has been validated, at least to my satisfaction. Likewise with his second claim, Bob does not provide numbers around his second claim. He only states that the apparatus operates in the microwave frequency range, and claim 3 we've also validated in my view, because we've come up with a full and complete description of the manufacturing process and why it needs to be the way it is. Here's the link that Tim should have passed on. There is also, and I should emphasise this, on that page with that link, you'll also see a tab, and it's called, I don't know, I forgot the name of it. It's called the link tab. Click on that. There's a spreadsheet calculator that you can actually download. So it does a whole lot of stuff. It also calculates a whole lot of I think cosmology stuff from memory as well. I included that there. The spreadsheet is the tabs are protected, but the spreadsheet is not locked. So you can unprotect those tabs and do whatever you like to any of the cells, look at the formulas, play around, do whatever you like. But I just wanted to point that out. So when you open it up, it'll show that each sheet is protected, but you can simply unprotect those and do whatever you like to it. And finally, information regarding the EGM methodology used to justify the Lazar's claims. Look, if you're all a bit, skeptical about theories and new people and different ideas, etc., look, as I mentioned before, Todd and I found exact solutions for the mass and size of fundamental particles. Many have either been experimentally verified or implied by the standard model of particle physics. I've also made new particle predictions, new predictions for the Casimir effect, exact solutions for the cosmological and astronomical Hubble constants, and we can explain the tension between those, all from the one equation. Point 3 there, a complete history of the cosmos, including resolution of the Hubble tension dilemma. I just mentioned that. Now, I expect that the James Webb Telescope is going to validate our most recent cosmological prediction, and that's that the universe is in fact 14.57 gigayears of age, not 13.8. So it's the Hubble age, right? And you can read about that if you're interested in that kind of thing in Hindawi there. There's a paper that's published on that. So the point of this last slide is that is to sort of trying to communicate to people. Well, look, if you have doubts about the numbers that we've come up with regards to Bob Lazar, what I'm communicating is the mathematical model, the method behind those Lazar numbers is the same method that's also behind this particle physics and cosmology stuff that we've done, much of which has been actually experimentally verified. So that should give you a little bit of confidence. So look, that's essentially it. I'm not sure if I've raced through that or had enough time, but yeah, look, happy to take questions.
Wonderful, wonderful. Well, sir, let me do this, Ricardo. Okay, you stopped your screen share, and
yeah.
What I want to do is I want to put this thing on gallery view. So everyone, starting out, let's give Ricardo a giant applause. Sir, thank you for the presentation. Wonderful drill down on Bob Lazar's claims. So let's go to Q&A session. Let's go to Jeremy Reese, who already has his hand up. And Jeremy, I'm not sure if your YouTube feed is on or not. I just tried to message you about that.
Yeah. Hello, can you hear me? I can't unmute. Host is not allowing participate.
Oops, sorry about that.
There we go. All right.
Yeah.
I had a problem. I'm watching my son, and he must have hit the computer screen and shut the StreamYard down. For the most key part of that, it was like started off. It was like, oh, we're going to talk about Bob Lazar, and then 10 minutes of blank screen, and then and then it was on the summary page when I got it back up. So everybody missed like watching live. I lost like 100 people watching it, and yeah, I'm sorry about that, but I will repost that when you get it up. I'll have to get the link, and I'll have to repost that presentation from Riccardo because of the technical difficulty and the glitch. And I do apologize. It was totally not like intentional in any way, and I'm sorry that happened. But I wanted to have a couple questions about the presentation because I was watching it and I was paying attention, even though it wasn't on for everyone else. I just want to point out that my first question is there was a gravity A wave and a gravity B wave. And did you mean gravity? You said gravity A wave in both cases, and did you mean gravity B wave on one of those, or that was my question?
So look, I'm not sure where perhaps I might have miscommunicated, but I'll try and clear that up. A gravity A wave is emanating from the Moscovium atom itself. The gravity B wave is emanating from, in our case, the Earth. So that's the difference between gravity A and gravity B. These are Bob Lazar's words, not mine.
And I had never heard that actual 7.24 hertz or whatever figure before. Did that come from Bob Lazar, or?
Yeah, that came from Bob Lazar actually back in 1989, so over 30 years ago. And it's the most easily and most trivially verifiable number just by using Fourier series.
That's the Schumann resonance, right?
No.
It's not close to that. It would look like a similar
Well,
number.
it's close to it. It's close to it, but it's not it. I mean, as I understand the Schumann resonance, that's not it. It's close to it, but it's not it.
I'm trying to think. Like another person said, "Oh, it wasn't Bob Lazar's claim. He hijacked it from somewhere else." And did you do any research into the literature to find if anybody, if he could have got these claims from somewhere else and simply been repeating them, or did these claims originate with Bob Lazar?
They originated from Bob Lazar, to the best of my knowledge. I have not seen them anywhere else. In fact, the 1991 video by Gene Huffman and Bob Lazar quoted it then, I think, from memory. So I've certainly not seen it anywhere else. And look, I mean, in some sense, even if it did come from somewhere else, okay, it's relevant, but it still doesn't take it away. It doesn't take too much away from the gravitational story that's involved with that first claim. But yeah, to the best of my knowledge, he said it.
Wonderful. Jeremy, was that everything? Or?
Yeah, I'm gonna have to go look at the source for that and go track that one down, because I wasn't aware that he gave that kind of an exact figure anywhere. So I want to go and find that.
Okay.
But, yeah,
I
thank
have
you.
to give a shameless self plug to let people know that it's still streaming on YouTube uninterrupted on my Crypto Alchemist channel. But me and Jeremy will be figuring out in the future better where these streams will just go to multiple channels with 0 interruptions.
Yeah,
Okay.
Bernard, give me a link. I'll post it so if people want to immediately go watch it right now. They can go to your channel and go rewind 10 minutes and check that out.
Awesome. Thank you. Okay, so let me go to Mark next. Mark, sir?
Yeah, I got a question for him. I'm trying to figure out from this Bob Lazar model here, maybe you can help me understand. He's using a gravity wave, or the UFOs or the ETs are using a gravity wave. How do you get from this gravity wave to anti-gravity or gravity shielding and propulsion? How does the craft move using this system that Bob Lazar explains?
Yeah, well, apparently, and I'm just repeating what Bob Lazar has described, but apparently there are 3 gravity amplifiers on board this craft. So, and they're spaced 120 degrees apart. If you can imagine a plan view, 120 degrees apart. Now, in the middle, there's the actual power source, and that's where the Moscovium wedges, right? Assuming that stable Moscovium actually exists, a stable isotope exists, that's where the Moscovium wedges go into an apparatus in the center. So, and around that you've got 3 amplifiers at 120 degrees spaced apart. On the next layer beneath that power generation layer, the next layer underneath the spacecraft, you've actually got 3 conduits that are able to move in different directions, have all kinds of orientation. So at the surface of the Earth, if it was a hover situation, apparently according to Lazar, it can sit there using one single amplifier. If you're just hovering there. However, if you are wanting to go somewhere with it, say somewhere out in space, those conduits or those horns can rotate, can focus on, all 3 of them can focus on a point in space, and basically, according to Lazar, generate your downhill. And in his 1991, and you basically just keep falling downhill. And in his 1991 video, he actually does, he shows it as actually, well, warping space, I will say. It warps space. So, and you basically shorten the distance between 2 points, is the way that he describes it. So that's what he claims, the way it actually works.
So he creates a gravity field underneath the ship.
Yes, correct. And projects it.
Gravity is
Projects
attraction.
it.
So how does creating a gravitational field underneath the ship make the ship float upwards or propel it?
By the gravity A wave that he claims is produced by the Moscovium is then phase shifted 180 degrees. So when it's aimed at the Earth's gravity B wave, it's cancelled out. It's reduced by not greater than 99.9% is what I calculate. So yeah, so that's how he claims it works.
Okay, thanks.
Awesome. And thank you, Mark. Let me see why. Sorry. There we go. Okay. Zoom wasn't showing. Oh, because it has the hands up first. Okay. Let me go to Sean Logan. Sean?
Go for it, Sean.
Yeah. And Sean, you're going to have to unmute yourself. There we go. I'll do ask to unmute. And I've got that unchecked, so you guys can unmute yourselves, but please only do so to ask questions.
You gave a frequency of 11.44 gigahertz coming out of the nucleus of an atom. Is that is that frequency an electromagnetic wave, or was that a wave of strong force or something else? And if it was electromagnetic, what's that?
Well, no, good question, right? Good question. And look, all I can say, well, the answer is I don't know, right? What I do know is the frequency. So it's around that. The question is the effect that's coming out of this Moscovium atom. The question is it purely EM or is it something else? Lazar claims it to be something else. Lazar claims it to be gravity. So gravity to me is gravitational acceleration. So he's claiming that gravitational acceleration is projected like an EM wave, and it can be manipulated like an EM wave. These are his claims. So that's the only way I can answer the question.
But it's a different kind of substance that's vibrating. It's not. You're saying the mathematics is similar to E&M, but it's physically.
Yeah, correct. Exactly. That's exactly right. So the mathematics behind what I've done makes no distinction whether it's EM or something else. It's just a wave, right? Bob Lazar claims that that wave is something else, but behaves like EM. It can be amplified like EM. So yeah, that's the only way I can answer the question.
Okay.
Look, I mean, I don't think anybody really knows.
All right.
Awesome. Okay.
Isn't the element dictates the wave, like the frequency? That's how we categorize elements. Like it's in that frequency range. So we put it in that kind of, it's the frequency of the element that dictates what element it is, right?
No, it's actually the number of protons in the nucleus. So, hydrogen has one proton, on 115 is 115 protons. So that's what makes it.
And the hydrogen frequency line is.
Sorry,
but
it would of that particle.
Yeah, I mean, Lulu, it would have to answer your question. It would have, based on the element, it would have its own resonant frequency, and then you get
and its own ups and downs, and that's what they're measuring. The 400 and let's say 12, frequencies, and the equation is, as you stated before, like you divide that by a half, and then it would equal to know that this is element 115.
Yeah. So let me go to Jared next, though. I think yeah, there's definitely something to what you're saying about frequencies. Let me jump to Jared real quick, sir.
Hey, yeah, thanks. I had a question. I was following the Jeremy's feed right as it cut out. Good stuff. So I apologize if you already went over it. But on the gravity A wave, you said that Lazar originally got it at 7.46 hertz, and then you guys calculated it at 7.43. Close, but not very many, decimal points after that. How did you go about calculating it, and what was any reason for being close but not quite?
Yeah, so, okay, so the way to calculate is just using a Fourier series. So if you take the number 1, you can actually break it down into a spectrum of Fourier harmonics. When you add the first 415 harmonics together, what you end up with is 0.99107 or something like this. What that means is that the first 415 harmonics of the number 1 adds up to 0.99, so greater than 99.9% of the value of the number 1, right? So that's it's what I call the unit harmonic operator. Now you can multiply that unit harmonic operator by the magnitude of any gravitational field, right? So that's how you relate. So that's how the figure of 7.43 hertz is obtained. Now, why it's not exactly 7.46 as Lazar stated, could be for a variety of practical engineering reasons. Yeah, I don't know.
Cool, thank you.
Yeah. Okay, let me go to, and thank you, Jared. Let me go to Mark next. Mark, welcome back, sir. Mark has been here for a while.
Yes.
Today, been lurking.
Thank you very much for the presentation. About Bob Lazar, there's a distinction that needs to be made. He is telling us how he was told these objects work. He's not saying that this is how it works. He's saying that this is how I was told it works. So even if you take him at his word that he's 100% honest, he's not telling you that this is how it works. He's telling you that this is how he was told it works. So he might have seen something real and been fed a BS explanation as to how it works, because that's the secret. And that's the best way to keep these things secret, is to, spread disinformation. One key fact that is indisputable that proves that something is off in the explanation is element 115 transmuting to element 116, which is antimatter. You can't have an atom suddenly become antimatter. You need antiprotons, antineutrons, or anti-electrons on the outside, which we call positrons, in order to make antimatter. So making a larger mass of matter doesn't make it antimatter. That's one of the key things. Also, the microwave the waveguides that he saw, and he commented that they actually look like microwave waveguides, would be explained by several other experiments that we're looking at, such as the Alzaphon experiment that uses microwave waveguides for inertial mass cancellation. Have you considered that possibility?
Look, no is the short answer, because this was about just purely trying to validate his claims against what I know. So this is about discovering evidence for yourself. I mentioned early in the presentation that the only real evidence for anything is that which you can verify for yourself. Doesn't matter if you see it in videos, government documents, it means nothing. It's only what you can verify for yourself. So everything that I've put forward, anybody can verify for themselves, because it's straightforward mathematics.
Okay, what about element 115 magically turning into antimatter?
That's not what actually happens. So Bob Lazar doesn't claim that element 115 turns into antimatter. What he claims is it transmutes to 116, and in the process, antimatter particles are produced, collected, and then I think I'm going from memory here, the antimatter particles are channeled to some gas then the antimatter particles annihilate, and then there's a thermionic conversion.
Exactly, 100% thermal electric converter. But the element 116 is the antimatter. You're adding a proton to 115, making it 116, and element 116 is antimatter, which then
the element 116 is
Well, if I could add some confusion to this as well, I'd like to confuse things even more. I had read, and I could be completely mistaken, that element 115, right, which was super briefly synthesized in a lab, a few years ago. There may be different versions of that, because what Lazar was talking about as 115 may have been an isotope of a different element.
Yeah,
is that?
No, he said 115 was that the stable form is an isotope of 115, the 115 element. So what was produced, and hence the name moscovium, is simply one isotope that's known to be unstable or not very long-lived. And just on the point of 116 being antimatter, I'm not sure I understand what that means, because 116, it has 116 protons and however many neutrons.
Yeah, what I recall reading, and again, I could be completely mistaken, to go to Mark, was the antimatter was supposedly given off when it decays. I remember, yeah, he had and it was a 2 or 3 step process, right? It's 115 to 116, and then it was 116 to like 114 or something like that, and then back to.
I didn't hear about 114. I heard
maybe not, but
we should listen to it again. But my recollection was that it was 116 became antimatter, which then converted with the gas in a 100% thermoelectric conversion process.
116 it decays. It's at so if you look at the reactor, he has a proton beam shooting into the tip. It does a beta decay, which it emits. And it emits a matter, a proton and an electron, right, or an antiproton in there. It does an antimatter decay, which I'm sorry I'm flustered, but it's not that the whole target turns into element. Goes all the way up to 116. You're at the very tip of it that you're playing in the reactor.
Yeah, that's right.
And you're shooting a single proton into it. It goes up. It's unstable. It bounces up. Bob Greenyer found a really good useful website.
Well, it decays to what?
So it's up at element 116 briefly, and then that extra energy decays into matter and so an electron and a positron.
Does it go back to element 115?
The target, the triangle target stays, the majority of it stays at element 115. Nuclear reactions are site specific. So you have to think that there's
the atom that got hit went to 116. Does it go back to 15?
As it decays, it emits the proton that was put into it, shot into the tip of it, it decays into a matter antimatter reaction. So it's a specific type of decay. We can look up on Wikipedia. But
so you're saying that the proton that you're hitting it with became an antiproton?
As it decays, there's beta decay. There's you have alpha, beta, and gamma decay, and then
so in that case, the fuel is never used up, because the fuel is coming from the particle accelerator, not from the element 115, and that's not
right. Possibly.
That's not what he said. He said that the fuel will last a long time, but it does get used up.
Well, who knows? Maybe it erodes. Yeah, maybe it erodes because you're hitting it with a proton beam, right? So,
well, if it erodes, it'll still be there in the chamber somewhere. It'll just break apart, become a powder.
And then Paul Potter also in this book, he goes into the stacking of it, of the fuel element. So that's another resource. So I think that the stacking of that material has been out in his canon, in Lazar's canon for a while. So I don't know if that's exactly new info, but it's.
One interesting thing is on the periodic table, right above moscovium is bismuth, which is the strongest diamagnetic material. Maybe there's something going there.
Well, Mark, let me bring this back to Riccardo, because this is his Q&A session, sir. So Riccardo, what are your thoughts on this?
Look, to be honest, I don't have any thoughts in this space. I focus simply and purely on the claims, those 3 specific scientific claims by Lazar. It seems to me that I think Aidan is certainly on to something. I mean, what Aidan talked about is consistent with my understanding. I don't have a very deep understanding in that space. I haven't focused on it because it's outside my purview. So, and it's very much an open area, open question. There's not a lot of detail around it, and it's complicated by the fact that we haven't been able to reproduce the stable form of that element on Earth. So there are just too many questions about it, I think, to have any degree of certainty. I'm only certain about what I did.
Wonderful. Okay, so let me go to Harold next then. Harold, sir?
Yes, a very interesting aspect what you presented. My question is, what Mark said and Adam Schaefer said, you know, bringing that to what you said, Bob Lazar, the description that is given, you know, makes me think, you know, that there might be a resemblance that when all that energy of 115 is being used, the antimatter given off, that somehow there is an evolution in the process in which it acts as if it were a propellant, and that the energy released from that effect act as a propellant, that creates a super force that create a very large proportion force. Is there any probability that that is basically what happened in what Bob Lazar described, or what other researchers have investigated, trying to understand how it's happening?
Okay, so Bob Lazar was pretty specific in saying that it is not, there's no Newtonian type reaction occurring. So there's no propellant being emitted out of this. It is I'll call it electromagnetic, but I only call that I'm only using that as a description. So no, I don't think that it acts as a propellant in any way. Yeah, that's not my understanding.
I'm making an analogy. You know how propellant produces a force. I know it's not Newtonian, but it's the process itself act as if it were propellant and create a force. I mean, there's no ejection, but there's in the matter antimatter creation, there's an energy release, and the energy release itself, that because the energy, you know, to conserve momentum, something has to give in. You know, you have to put in energy, but the energy itself, you know, just like a propellant create a force, the energy itself in the process create a tremendous, you know, a high proportion force. You know, is that more like I'm making an analogy, a similarity. I'm not saying that it is a propellant, but somehow an operation of that nature. Would that be what he's describing? You know, something like that.
Yeah, look, no, I wouldn't. I certainly don't consider it to be a force. If anything, I would probably describe it as bending space-time locally the other way in order for it to just float, right? Bob Lazar does describe the entire craft as being a waveguide. Now, Todd Desiato can pick up on this point if he wants to in greater detail a bit later on. But as Todd has certainly demonstrated to me, and I think probably to other people in the forum as well, the entire craft does in fact need to be a waveguide, because all of space-time in that waveguide needs to be, I'll use the description as bent backwards. So no, there's no force per se that is projected. No, I wouldn't describe it like that, to be honest, at least to my understanding.
Hey, thank you. Thank you. Great presentation. Thank you.
Thank you as well, Harold. Okay, let me go to Gordon next, sir. Oh, Gordon, you're muted. There we go.
Yep. Okay, yeah. Thanks for the presentation. Absolutely superb. Hadn't heard some of that stuff before. I first came across Lazar via BBC, actually, on a program that was on BBC Radio here in UK, way back at the late 80s, where some of the claims were made. And then it resurfaced then with the guy that was on that radio show in this book, Alien Liaison, written by Timothy Good, who was a well-known UFO researcher. But Good actually met Lazar along with John Lear. And one of the things that I think, was it Mark, I think, was talking about earlier, was this reaction of element 115 to become 116. And it's actually in a little section in this book on page 157. He actually describes what happens. And it says, his words, on bombardment with protons, it kicks up to element 116, then releases antimatter, and that's reactive with matter, which is then called an annihilation reaction. And it appears they have something like 100% efficient thermocouple of sorts that produces power and some sort of gravitational standing wave that propagates up through the waveguide that you talked about. And they then use that excessive power to do whatever they need. And that was his description of what was going on with it there.
And that's certainly consistent with my understanding. You know, that's certainly consistent with my understanding as well. But again, I don't delve into that that antimatter aspect. I've just focused specifically on the three scientific claims that Bob's made. And as far as I can tell, those three claims are accurate. Yeah, they're bang on. And the thing is, why I believe what I've done is important is because one can verify for themselves. So I've put the all the work out there, and Tim, I think, has already sent the links. But certainly the 7.46 hertz claim, it's just straightforward first year engineering, you know, Fourier harmonics, and it requires no theory at all. You don't need anybody's theory for it. And in fact, if anybody has a theory connected to it, well and good, but it's superfluous. You don't need it. It can be explained totally mathematically. You know, which I think is a remarkable coincidence, because if Bob Lazar knew anything about this, he would have given that as the answer in 1989. I mean, you can't just pluck a number 7.46 out of the air and then calculate for yourself 7.43. You know, it's just, anyway. So yeah. And look, a point that I think Mark made before, which is relevant, I think it's an important point, is that much of this information that Bob Lazar has passed on was given to him in briefing rooms, right? And much of it, or some of it, not much of it, some of it may in fact have been misinformation. In order, you know, as a security measure and stuff like that. And I believe in the 1991 video that Gene Huff and Bob Lazar did together, so only 2 years after he came out with his story, I remember watching it live on TV back in 1989, and just to show you my age. If you watch that 1991 video, I think it's about 39 minutes long or something like that. Towards the end, I think he calls it section 2 or something, towards the end of the video, the last few minutes, He talks about aliens and how many times they've possibly interacted, or controlled the destiny of our species. I think all of that is just utter rubbish. I think that is the misinformation, right? But certainly the technical aspects, I have verified to my personal satisfaction, absolutely. And everybody else can check. You can plug the numbers in yourself. I've created a spreadsheet calculator to make it really easy for everybody. You can play around with the numbers, change the formulas, do whatever you like. Yeah.
Okay. Thank you, Gordon. Okay, so let's go to Morgan next, sir.
Okay, so just I guess a couple of comments on this. The idea that you're using this this heavy element, this 115, as I forget who had mentioned this, that if you're bombarding this thing with some proton beam or some particle beam, that whatever's supplying that particle beam is essentially the fuel. And what Bob was saying, or Bob Lazar was saying, is that it's the element 115 that's itself the fuel. And to me, that sounds almost like it's some sort of kind of like a nuclear reactor of some sort, whatever, cold fusion or something like this. But whatever process is going on, that's the thing that's generating the energy, and that's going around somewhere and powering the systems and things like that. And it seems like that power source is powering some other thing that might be generating a gravitational field or some sort of anti-gravity field, whatever, if it's this Gershenstein mechanism or some other kind of crazy thing. But it seems like that it's the actual the element that's itself. So whatever process is going on with this 7.4 hertz hitting this element, that seems to me like it's more of a power source. And then there's some other thing happening that's creating the gravitational field. I don't see how a heavy element can create a gravitation. We talk about this gravity field A as if it's somehow leaking out of the nucleus or something like this. The only thing that seems at least somewhat plausible is if it's some sort of near field effect. You get these really intense near fields in electricity and magnetism. If you have a plasmon or some particle confined to some surface, you get this exponential tail, which is really strong, which might be what's happening here. But I don't know if you can confine a particle to get a gravitational field like that. But I don't know, just a couple of comments on that. Go ahead.
According to Bob, so I'm using his own ideas. I'm just repeating them. He believes that the strong nuclear force within the nucleus of 115 actually is an isolated case of where the strong nuclear force actually, to use your words, leaks out of the nucleus to such a point where we are able to grab it and amplify it, right? The strong nuclear force. This is what Bob Lazar believes. It's not what I believe, but it's what Bob Lazar believes. So that, look, I can't speak to the point whether that's actually happening or not. All I can do is say that I've run the numbers for myself on what Bob's talked about, and it seems impossible to me that he can just guess 7.46 hertz tied to a microwave frequency range amplification system, tied to an element that requires a very specific process that can all be explained. It can all be explained by the 11.44 gigahertz frequency. So the microwave frequency range value that I've come up with, that's not a Bob Lazar value, that's my value. His value was 7.46, he came up with that. So to me, these things have convinced me that those three claims are accurate.
What was your number, the 7.43? You were doing this Fourier decomposition with this 400 and some odd harmonics. What with some gravity field? What exactly was that? Well, what was it? Your Fourier transforming something, or what is this?
Yeah. So so if you take just the number one, right, and you actually break it down using a Fourier series analysis, so you can actually break it down to a number to harmonics, right? So, well, when you sum the first 415 harmonics, when you sum all those harmonics together, and I show it on the slide, and you can see it on the ResearchGate paper as well. When you sum them all together, what you end up with is basically greater than 99.9% of the value of 1, right? That actually relates to a frequency value. So you can transform that into a frequency value of 7.43 hertz, right? So Bob said that the 3 horns under the spacecraft pulsed at a frequency of 7.43 hertz. So they would pulse at a frequency of 7.46 hertz, pardon me. They'd pulse at a frequency of 7.46 hertz. But from each one of those horns came a burst of microwave frequency range energy. And I've calculated that to be 11.44 gigahertz. So, yeah, that's basically it. I think there are some animations available at various spots around the web that can show you that. But essentially, from the moscovium element comes a signal that extends outside the nucleus. That signal is grabbed and amplified. I'm saying amplified to 11.44 gigahertz, and that's in the microwave frequency range, which is what his claim is, not the 11.44 gigahertz. That is then burst released through horns at a frequency of 7.46 hertz is his claim. And by the way, I've run a number of scenarios around element 115, whether it was element 116. So whether the number of protons, etc., change, or even the number of neutrons change very much. It doesn't. So I've experimented. I've done some what ifs, and in all situations, I've found that the frequency for amplification coming out of that is always somewhere between 10 and 12 gigahertz. So if this effect, if this phenomena that Bob describes is genuine and some of his numbers are a little bit off, right? It doesn't really matter, is what I'm saying, because it's always going to be somewhere between 10 and 12 gigahertz, something like this.
There was, I guess, just a final comment. I forget the details of this one, but someone had mentioned that about how gravity B is a strong nuclear force. There's some people have been working on these things where I guess you could, if you look at a quantum field theory of gravity, you can essentially, I don't know exactly how this works, but it can decompose into 2 copies of QCD. There's some decomposition that you can do with that, where you can, you could write a gravitational general relativity theory as 2 copies of QCD, which that might have to do something. At least in that case, you have some strong nuclear force being attached to gravity in some way. So maybe that has something to do with it as well. But, okay, yeah, cool. All right, thank you.
Yeah. Cheers.
Wonderful. Okay, so let's go to Robert next. Robert, who has been patiently waiting, sir.
Yes, I'm still trying to get my head around element 115 being stable.
Mm-hmm.
Right, these heavy elements are typically have very short half-lives. Now, does anyone know the number of neutrons that would give you the isotope of 115? That, you know, the protons plus the neutrons would be related to the atomic weight, and you could figure that out. You could measure it by putting this isotope of 115 through a mass spectrometer, so it's knowable at least.
Okay, look, that's a really good point. The answer is nobody has the answer. There is theoretically an island of stability, and I think from memory, the number of neutrons, I think it's around, from the diagram, and the diagram's actually on one of the slides that I've presented. I think it's around 180 or something like this, roughly, but no one's actually got the answer as far as to my knowledge. Yeah.
Okay.
If it's possible at all. Yeah.
Well, I mean, it should be knowable. I mean, if they did experiments on this, they should have put it through a mass spectrometer, and then they would know atomic weight.
Yeah, yeah. So the thing is, the element 115 or the moscovium that Bob claims he had, well, I mean, that's just a claim. In terms of our human discovery of 115, you know, I think 650 milliseconds, I think was its life, something like this, its half-life, something like this. So there's certainly been no chance for us to put it through a mass spectrometer. But look, yeah, you would think that someone on the Bob Lazar end would have done that, and that may very well have been done, but not information that was revealed to Bob, possibly.
I don't see how you could use it unless it's stable somehow. So you need an.
That's right.
Yeah.
Yeah, that's right. So Bob Lazar claims that the US government was supplied with about, I think, 223 kilos or something like this of element 115 by the Martians, by the space aliens, right? So this is his claim that the US government has that kind of material in reserve, and you would think that someone would have done some kind of analysis to determine the number of neutrons for the stable isotope. Someone probably has, right? It seems inconceivable that wouldn't be done, but that information probably was not provided to Bob Lazar, because why would he need to know it? Right? If you're an engineer playing around with it, right, why would you need to know that?
I don't know.
Right?
That
All
could
you'd
be
need to know
critical
is,
to why it works.
well, it could be, but if, at least to my way of thinking, if you're trying to minimize the escape of this information for whatever reason, it's look, it was not remarkable to me. I mean, the media on the internet has often made the claim, "Oh, Bob Lazar predicted, 115 before we'd actually discovered, etc." That was not an amazing claim to me at all, right? It's just obvious. It's bound to happen, right? It would seem to me that someone who's trying to keep that information from the public, right, would realise that a critical piece of information would be the number of neutrons. So you wouldn't need to pass that on, because if you know what the stable number of isotopes is, right, when we eventually discover it and we find that it's unstable the way we discover it, well, then that kind of puts a hole in Bob Lazar's claims, doesn't it? But if you release the number of neutrons, Bob can say, "Oh, well, yeah, that's obviously not, because it's, we haven't made the same stuff." So yeah. I can see reasons why it wouldn't be made known to him.
That, and the fact that, I mean, this is our government. This is the American government, right? So yeah, I will not use the word incompetent at all. I refuse to use that as a descriptive term. But well, okay. So let me go to Michael Boyd, who has something levitating, which may be element 115 right there. Michael, I've done the build up. I've done the build up. Oh yeah. Can you unmute yourself, sir?
No, you'll need to unmute.
Oh, Michael, you're still muted. Okay. There we go. Is that 115 right there?
My nuclear reactor was down, so I couldn't work on that. But I do have here. So basically, gravitomagnetism is what my background's in, and basically my thoughts on anti-gravity is that it's a combination of both gravitomagnetism and acoustic properties. And what we have here is what's called an acoustic levitator. And what that little object is there, in the middle of my neck that's spinning around, is a piece of styrofoam. And so basically it's a combination of vibrational energy, which is basically where the protons are moving, and a type of magnetism called gravitomagnetism.
But is it special styrofoam made out of element 115?
Here, it's a piece of a peanut, like you get of styrofoam that you put in your packaging.
Oh my God, the aliens use packing peanuts? I had no idea. No wonder they're trying to keep it secret. Everybody could use this.
Oh, you're gonna have to cut this from the.
I'm sorry, I'm kidding you. Well, Michael, what was your question for Ricardo?
Well, what's his thoughts about it being something a lot simpler than what Mr. Lazar is describing?
Look, I tell you what, if you can turn that horizontally, is that styrofoam going to drop to the ground?
I don't know. It's a good question. Probably.
Oh, moment of suspense.
Oh, yep, it falls out.
Okay, there you go. If you can make that stay where it was horizontally, then you've got Bob Lazar's. You've got an answer for Bob Lazar, because it's not the same thing. What you're talking about, what you've demonstrated, is absolutely not the same thing at all as what Bob Lazar was talking about. No disrespect, but it's just.
No, that's okay. I don't take any disrespect.
Michael, I will never trust styrofoam again. I feel like I've been betrayed. It seems so innocuous until you realize that it's all just a lie. So.
Well, that's the thing about Bob Lazar is, I have compassion for him, but I want evidence. I can show you evidence of styrofoam levitating. You saw it. The stuff that we're talking about with
that's not the same thing.
Lazar is what's the evidence?
Yeah, I mean, no, Ricardo, your analysis is different than, or maybe it's not. Is it different than your personal opinion, or?
No, it is. Look, so my whole point is that, and Michael's touching a really good point here, right? It's about showing me the evidence. Well, my point is, I've given you the evidence. You can check it out for yourself, right?
Well, would you be more specific, please? I don't understand. I can see the evidence. Is there a website or something like that?
Yeah, sure.
Okay, would you
look,
put it in the chat so that we could check it out?
Yeah, I think
Tim's done that.
Sorry, I do. On the conference page at the bottom of the page, I have a link to the ResearchGate paper. But
okay.
So Ricardo, if I could maybe rephrase, I guess, what you're saying, and I might be incorrect. What you're kind of saying is like, okay, if someone says, aliens told me there's a buried treasure on this island in the Pacific, right? And so you go to that island and you find the buried treasure, and maybe it's not in exactly the spot, but it's pretty darn close. Then that adds some evidence. Is that
that's
sort
right.
of kind of?
That's right. So what I'm to be very precise about it, Bob Lazar makes one very, very specific claim, right? That until now has been inexplicable, to my knowledge. If someone else can show me how a value of 7.46 or something close to it comes up in the description of gravity, I'd be happy to see it. But what I've demonstrated is that 7.46 answer is no fluke, and you can get it using basic first year engineering Fourier analysis. And that's it. And everybody can reproduce it for themselves, provided you understand a little bit about mathematics. Right? So there is no better evidence. Right? That's better than video evidence that you might see, which can all be doctored. right? Evidence that you can check for yourself, that's the only kind of evidence. So
I agree.
even if,
I'll check it out. Thanks for answering my question.
yeah, sure.
Well, and thank you as well, Michael. Let me go back to Jared. Jared, sir?
There we go. Yeah, I had a follow-up question on the 115. On the paper, it looks like you are ignoring the electrons in a lot of places.
Yeah, that's
sure,
right. Yeah.
A lot of reasons to do it. I was curious though, if you're hitting the very tip of this piece with protons and stuff, and we're dealing with, you know, resonances all over the place, wouldn't the lattice structure of the sample be important? Wouldn't the number of electrons and their binding be important for all these calculations?
Look, possibly, right? The short answer, I believe, is no, because if it were, I don't think I would get the results confirming what Lazar has claimed, or if the only claim that it may have an effect on is possibly his second claim. So I've come up with a result of 11.44 gigahertz, and I did that ignoring electrons. Absolutely, that was just to simplify it. It could make a difference, but my personal view is I can't imagine that it would make much of a difference, personally, because the effect, the anti-gravitational effect, and I hate using that word anti-gravitational, but the anti-gravitational effect is coming from the nucleus, not from the electrons. Right?
Well, especially if there's like positron decay, right? And that's definitely going to be slamming into all those balances, right? You're going to have all sorts of weird interactions going on when you're getting decay.
Possibly. Look, it seems to me impossible to do a deep and exact analysis, engineering analysis of anything, because there simply isn't enough information, right? So look, I did my best with what was available, basically. Yeah.
Excellent.
So
Thank
you
you.
could be right.
Yeah, yeah. Well, and yeah, I mean, I think, yeah, Ricardo, I don't think anyone could criticize you for, you know, incomplete information. I mean, that's something that we all work with, right? It's, you know, it's bits and pieces that we get here and there, and God knows what we're missing, and, you know, so yeah, you know, let me go to Bernie, who is, I can see the look on his face. He's eager.
So a common theme I'm noticing with the Bob Lazar topic is that he seems to come up with these over elaborate necessities and complexities to his designs. For instance, his hydrogen powered car that needs and requires a particle accelerator in his backyard to make an aspect of it. Yet it's like, I'm making this same HHO Brown's gas out of salt water and 5 volts in my backyard that anybody can turn salt water with a small amount of electricity into these gases like Stanley Meyer was, where you don't need these insane things. So it's that, sure, Bob stumbled upon what would be like the Star Trek sort of scenario where it seems like he discovered or claimed these things before they came out, but it's just an inevitability in some of these far-reached sci-fi sort of ideas it seems he's come up with, but there's zero actual evidence of anything that he's claimed come forward with showing the actual technologies.
Look, just on the point of the particle accelerator, at least to my understanding, and look, I've probably seen no more than what you have, right, on the net with regards to Bob Lazar. My interpretation was that he didn't claim that he needed a particle accelerator for anything. He just happened, he's a guy who's just got interest in physics.
Sorry to interject. It was the key part that it was to create some part of this oxidization, crystallization in the hydrogen container of the storage for it to be run on these hydrogens. maybe it was graphene or something like that had to be made in his particle accelerator to store it. Where it's like just that complexity is just so ridiculous, because literally all you need to do before your fuel injector is have that H2O with a little salt in it, get a little shock of voltage, and it will turn into those gases before combustion.
Well,
you don't need to store that hydrogen to begin with, yet alone create the graphene to have to then make it, sort of thing. And I'm just saying it seems like it's the same with this element 115 and all of that it's like just over complexity, but where's the actual evidence of it all?
Yeah, you're describing kind of a Rube Goldberg thing, right? That would be your concern. I mean, sorry, Ricardo.
Certainly to my eyes, pardon me, in the element 15 and the propulsion space, and specifically the claims that he's made, I don't see complexity at all. In fact, I see absolute simplicity. I don't think there's anything difficult at all about it or complex. It's horrendously simple if it's actually real. It's just
Ricardo,
the simplicity is.
It was Moon. He was the nuclear chemist of Americas in the 1980s. He's actually got work that does support what you're saying in regards to how you're deciphering what Bob was saying with that. And in no way am I trying to attack your work. Your work is absolutely excellent, and that there's truths in everything, and it's figuring out each piece of this scientific puzzle, and that we have to test it, come up with it, and that is the scientific method.
Yeah, well, and I look at Ricardo's work in the same spirit as Paul Potter, right? Where he's looking at it and saying, okay, how could this work, and how many pieces match up, and if there's smoke, is there fire, and I think none of us are ever going to find definitive evidence of that from the story that's been told, but it sounds like he's finding, well, there's smoke here, and so that this is probably worth more consideration.
Yeah, that's a good way to describe it, Tim. Absolutely. So look, I don't know whether Bob Lazar is telling the truth or not. I believe he is personally, right? But like everybody, I want evidence, but evidence that I can actually verify for myself, not what's told to me by someone else. And that's what I tried to do.
Yeah. Well, Ricardo, thank you so much. And we have about 4 minutes left, I think, in our Q&A session. I'm not sure if anybody.
I think Michael's got a question.
Oh, Michael does. Okay. Michael will close us out, I think. Go ahead, sir.
Cool. Yeah, I just had to jump on because it seemed people were unaware of. So it's not just isotopes. That's the thing. It's possible to have nuclear isomers. So you have a number of neutrons and protons, but you also have a nuclear excitation, which may stabilize a nucleus. So you could for example, you can have tantalum 180-M, which tantalum 180 is actually unstable on its own, but when you add a gamma ray of the proper frequency, it actually stabilizes the tantalum 180. So the isomer is stable, even though the isotope is not. So it's possible there are undiscovered nuclear isomers of element 115. I mean, probably impossibly difficult to prove, but that it's just the search space is bigger than just isotopes. Just
that's a really good point, Michael. I'm glad you brought it up. It's a really good point. I'm glad you brought it up.
Yeah, there's hafnium 178-M and 180, tantalum 188-M, and it's quite possible there are others that are yet to be discovered that are. Most nuclear isomers are less stable, but especially where there's like high nuclear spins, there's an opportunity to produce stabilization with isomers. And if I'm not mistaken, bismuth and also moscovium should have a decent amount of nuclear spin, some isotopes of them at least. So anyway, that's just a thought.
No, thanks for that, Michael. It's actually a really good point about the isomers. I'm glad you mentioned that. Well done.
Yeah, there's a lot here. Well, Ricardo, we're just about at the top of the hour. So, sir, I want to thank you personally for taking the time to present. And let me put this on speaker view, and I want to have everybody here clap and give Ricardo Storti a giant applause. Sir, thank you. That was a good depth, a good overview of the work. You've done a ton of research, and you've tried to kind of put method to madness, I think, where you've taken this story and tried to flesh it out. So thank you very much.
Yeah, that's exactly right. And I just might make a point, just in closing out, the ResearchGate article that you sent the link out. There is literally 30 years work in that. Literally 30 years. It's taken that long to produce those answers. And a lot of that journey was with Todd. So he can take credit for it as well.
Well, yeah, no, I can't, sir. I cannot thank you enough for presenting for us, and we'd love to have you back as well. But so for right now, without any further ado, it's at 3 p.m. Let me go to Todd, who I just saw. Todd, are you with us?
I'm here.
Okay, and we are about an hour ahead of schedule, but and let me see. So today, Todd is going to be discussing ideas related to lifters and ion propulsion. He is trying to verify a model that when a disk is negatively charged, it'll repel an ion cloud below it and attract an ion cloud above it. And I understand you've also been building an interesting lifter with corona wire made from super thin 40 AWG SS wire. I've actually worked with 50 gauge, so I know what you're working with. Wow. That's pretty fine gauge stuff. Yeah, it's like spider web.
Yeah.
Yeah, and you're doing some unique stuff with it, and you've also looked at doing almost like an ion diode. So, sir, let me hand things over to you.
I'll see my screen. Okay. Let me know if you can't hear me. So before I start, we got a new information from Alexei Chekurkov regarding the Graviflyer. And so he said, he told Charlie that I got the questions and basically confirmed what, I've been saying. You can't, the direction of the Tesla coil windings doesn't matter. But he made some new information. He said that the motors are run from the batteries directly, not from the ultrasonic generator. So there's no adjustment on the motor spin rate of the motors that turn the disks. There should be an independent power supply so as not to affect the operation of the circuit, because the ultrasonic oscillator circuit depends on the voltage. That's how you set the frequency. So if the fans are loading the power supply, changing the voltage, it'll change the frequency. So they are supposed to be independent. The wire from the Tesla coil is connected differently inside the coil if indoors, but if I run the device in the field and use the long wires, then I connect the wire with the end to the output of the secondary coil itself. So in the videos, we've seen Alexei just stick the wire down the Tesla coil tube, capacitively coupling it. But here he's saying that when he's outside and he's got the really long wires, he's actually physically making a connection there, which is something I've been saying for a while, that, you need power. You're not going to get that kind of power through a capacitively coupled wire through the insulation. It's just not realistic. So then he gave his procedure, which is first I turn on the high voltage unit, then I start the motors, Then the Tesla coil. I started adjusting the parameters of the torsion field. Again, that's kind of vague. Then the ultrasound. I begin to build up the electromagnetic field, driving it into resonance with the gravitational waves. That's debatable. With the right tuning, an electromagnetic cocoon is formed that deflects gravity. There is a noticeable pink glow around the Graviflyer frame that lasts for some time. And then contradictory to what we thought he said last time is I did not hear strange sounds during tuning. So last time I thought we translated it to say he, listened for a peculiar sound. Here he's saying that's not true. The distance between the disks affect the settings. The legs of the apparatus do not need to be insulated because there was some discussion, I guess Charlie asked about, when the legs touch the ground, is that going to short it out? He said, I've launched the Graviflyer in the field without insulating the legs. The graphic image shows how different types of fields are located, and perhaps this will help to understand the principle, the structure of the field of the Graviflyer. It will seem strange, but I have no other way to understand it. There are no instruments to measure the frequencies and resonance of the gravitational field, and I can only measure the field boundaries with my gravitometer, which is that invention that he came up with, which is basically an LED between two metal plates. And it seems I've answered all the questions. So this was the new information that we got from Alexei this week. This came just Wednesday. So Charlie asked me to share this, and I'm happy to. Okay, so here's what I've been working on, and this is what Tim was referring to. And this is it's one of these discs that Mark made for me. It's 9-inch diameter. And then I made this little cup washer on the top. I drilled out the holes is what I did. And it's on top of a piece of polycarbonate tube where I ran the wire, the high voltage wire, all the way up the tube to get it to come out in the middle. Just in case the thing flies, I wanted to balance, So it did not fly. But I sharpened the tip to a point, and you can barely see it in these pictures, but there's this 3 mil wire wrapped like a circus tent all the way around the top between these holes and these standoffs. The standoffs are nylon, they're insulated. And then below it, also there is the same type of 3 mil wire, just makes like a hexagon between these standoffs below it. And it's, physically closer to the disc, and these standoffs on the bottom are aluminum. So it's physically in electrical contact with the disc. So the wire on top is isolated. The disc and the wire below it are electrically the same. And then I tested this with high voltage. Now, the first time I tested it, I had used nitinol wire, which, as you're familiar, this wire, when you apply current to it, it stretches or shrinks. And that's the first arc I saw, it just melted. The first arc I saw, it just melted. So then I rewound everything using stainless steel 3 mil wire, and it didn't. It works fine. And I want you to see a few minutes of this video here, because the sound these wires make, and basically I have positive connected to the top and negative connected to the bottom. And before I move forward, the objective here is that the wire creates a very strong electric field, just like a lifter, which radiates ions from the air above it. So above it, I have a positive ion cloud created, and below it, for the same reason, I have a negative ion cloud created. And the disk being negative should repel the negative ions below and attract the positive ions above, giving the disk lift. I did not see any lift with this design, but I haven't really spent a lot of time with it yet. But just there, watch what I did. Listen. Sons of bees. 25 kilovolts.
Your wire is vibrating.
Yeah.
That's the B sound.
Yeah. It's louder as I go up in voltage.
Yeah. So if you went to 50 gauge, that vibration would go away. The noise would go away.
It's probably ultrasonic.
The other thing that's interesting is you've got
you see these little flashes on the disc? This is what I wanted to show. This is at like 30 kilovolts. These are those little dust nodules Charlie was talking about and Alexei was talking about, is that the ions are literally hitting the disc because they're attracted to it.
Yeah.
It's 30. Interesting. That's what I wanted to show there. Now here's a test. Here's another test. 1 kilovolts. 3, 2, 1. Oh, wait a minute. No, this is the same video again. There we go. Okay. So this is the next device that I came up with. And this is because I got this Tesla coil that pulses, and it has these spikes coming out the top. And when it pulses, it shoots off like 4-inch arcs. And the 4-inch arcs are laid flat because the spike in the middle is taller. And so the electric field from the one in the middle is pushing the ions outward from the middle. Very cool thing, very noisy. It's a spark gap driven Tesla coil. But that gave me the idea of, in the same principle here, I've got these 6 spikes going around and a spike in the middle with a radiator in the middle. And the whole thing is charged. And when I use this material just to add so it would hold some more charge rather than a smooth disc, which holds a minimal amount of charge. So these, like a golf ball and whatnot, it's supposed to increase the capacitance. Can't say that it did, but the idea here was that as the spikes are electrified, it ionizes the air above this disc, which then the disc being charged to the same potential repels those ions, pushing it down. So I expected it to gain weight. And it did. So all right, got a new one. Model E. Badass. I got the scope calibrated. Well, 26, 30 millivolts about. Here's 20 grams. 20 grams is definitely noticeable. Now, I expect from this design, sitting on the scale like this, single polarity, I expect weight gain because it's going to be pushing down on the scale. Let's see what we get. Oh, and I got weight gain. Look at that. haven't changed anything yet. I'm at about 21 kilovolts. I just raised it up to 25 kilovolts, and it got heavier. Should be about 28 kilovolts right now. Okay, watch where it is. I just turned it off. Okay, on. Off. Yeah, that's so you see right there, it gained weight just like I expected it to. All right, got a new one. There's a little close up. 2, 1. Ah, yeah, that looks more like it. Definitely seeing some weight loss, weight gain now. We're up over 105, 110 millivolts. Negative, huh? Negative polarity. Electrons. Shoot. So you see, twice there, I had weight gain demonstrated. I actually demonstrated it a third time. Here's the data. We're back. Okay, so this was that first one that looked really good. I checked everything. It was about 20 grams was 1.5 divisions. And so going by that as a calibration scale, I saw 33.3 grams of weight gain as it pushed down on the scale. So it was repelling the ion cloud above it, pushing down. I did try to turn it upside down on the scale and see if it would lose weight, but because it's in contact with the wood, I don't think there's no cloud underneath it. You know what I mean? There's a piece of wood underneath it. Okay, so then I tried hanging it, and this was just yesterday I did this. I set it up and I hung it. The video is posted on Warp Drive Tech. It wasn't that eventful because it killed my power supply, but the high voltage basically generates enough high voltage noise that it backfed through the isolation barrier to my 300 watt 30 volt power supply and killed it. So that was where I left off, but I did get some data hanging it like this. And so with it, the way you saw it in the image, I saw about 6 grams of weight gain, still the same scale of about 1.5 divisions is 20 grams. So, so I saw about 6 grams of weight gain, and then I turned it upside down and hung it, and this was the only shot I got before the power supply died, and it didn't look like anything happened. So upside down, I didn't see any weight loss. It is kind of close to the floor, closer than I wanted it to be for this test. And before I got a chance to make any modifications, power supply stopped working. I don't want to risk, I have another one, but I don't want to risk it because it's the only other one I have. And I have a new power supply that supposedly can go to 60 kilovolts coming today or tomorrow or Monday. It's supposedly out for delivery this morning. So when that gets here, I will continue. And that was it. So that's where we're at. Back to, I had some good data and good test. I have several of these new devices to test, and it's just a matter of I need more voltage.
Todd, thank you, sir. And I hope to have you back many more times to share updates with us. Same bat time, same bat channel. That just popped into my head, even though it's
Right. Yep.
yeah. Thank you.
Not a fan of Batman.
Okay, so let me put this on gallery view. Everyone, please give Todd a hand and our undying thanks for your many presentations. Yeah, that was, Todd, that was interesting because, as you know, I did tons and tons with lifters. It's just flashback time, Yeah. The thinner wire gauge makes less noise. I ended up going to 50 gauge. And then in my case, I went to stainless steel corona wire. It turns out, this is just something that I had seen, copper, that was easier to get when I first started, interacts with the air. There's a chemical reaction that makes a heck of a lot of noise.
Yeah.
So the
that's stainless steel wire that was singing like that.
Yeah.
But yeah, I didn't see 50 gauge, or I would have got that. 40 was the smallest I could find.
The place that I used to buy that was from Information Unlimited. That was, and they may still sell it. It was like an off, I don't know what you would call it. I would just give them a call and say, hey, do you guys have any? And they didn't always have it, so I would kind of stockpile. But
what kind of improvement did you see using that?
So basically, when you go from thicker of any type, when you go from thicker to thinner wire gauge, your noise level drops, and at 50 gauge, you can hear ions coming off it, but you can't hear the wire at all. You don't hear any kind of vibration or singing or anything like that. And so instead of, you've always got that hiss, right? Yeah. And so the wire noise goes away. You still hear the hiss. The hiss is more pronounced. I played around with a ton of stuff. So the temptation is you get a lot higher ion output with 50 gauge. So it's tempting to try and put a bunch of those wires near each other, right? To run them in parallel. Yeah, and the E field smooths out. And so I had problems with that because my first thought was, okay, I'm going to make a grid and it's going to do tons of ions, but the E field smooths out and it actually doesn't work as well. So
yeah, I tried to keep them far apart to just spread it out over more area. But yeah, I know that too. That's why I went to the spikes, because what it does with the Tesla coil, it shoots the arcs sideways because the one in the middle is repelling the ones around it. So that's why I did this design, because I want the arcs to go out sideways so that the disc has time to repel it.
Now, I did have one anecdotal story. We had a bunch of little stuff, but one that reminds me, your lifter reminds me of this. I built in my case, I tested a I don't know what you'd call it, almost like a scalar antenna. I think that was what it was. It was basically like a donut where it had two rings. So the whole thing was flat. It was actually on like a paper plate. The outside ring was, I think, my collector, and the inside was the other charge. And then they had like an inch between them. And the idea was, I thought, well, what would happen if I could make ions flow between these? What would that do? And so I didn't really see any results. So I figured, okay, well, I'll hang this thing sideways, right? And I had it hooked up to, it was on a 50,000 volt power supply. When I turned it on, it was suspended by one of the power leads, and I think the other one was just coming off as a ground. So the interesting thing was not movement. The interesting thing was this thing was suspended by one wire, and just in the breeze of the garage, it started to turn. And as it turned, I had my hand on, I had the camera and I had my hand on the power supply. And as it turned, this thing panned across my body, and like in the line of sight, right? Like it was producing a beam, and the beam went down one arm, and I could feel the hair just where this beam was hitting come up on the arm. And I was probably like 4 or 5 feet away from this thing. And then it went down to the hand that was touching the power supply. And when it hit the power supply just shorted out and went dead. So I don't know. And that's what the standard, basically just a Cockcroft-Walton, voltage multiplier.
Yeah. So Yeah, like I said, my goal in this is, and the reason I refer to it as an arrow warp spike is because in a warp drive, you think of space-time in front is contracting and space-time behind is expanding, or that the universe in front of you is pulling you forward and the universe behind of you is pushing you away. And so the objective here of having a negatively charged disk and a negative ion cloud behind it and a positive ion cloud in front of it is that same kind of principle, is that the positive ions are going to attract the disk forward while the negative ions behind it are going to push it away. So it's an air-breathing warp drive, is electromagnetic warp drive is my concept here. I don't claim it'll go faster than light. I don't even claim it's going to give me propulsion, but I'm going to try and see what it gets. You know.
Yeah, no, that's, sir. Let me take some questions here, and I better read our question and answer thing. So it is Alt Y and Option Y on Mac or Alt Y on Windows. For anyone who has questions, I know you're all dying to ask them. There's Chris. Chris, sir.
Hey, Chris.
Oh, you know what? Sorry. Now you can unmute yourself.
Hey, here we go. Cheers, Tim. Yeah, no, that was a great presentation. Thanks. I've been really interested in lifters for a while, like a long time, probably sort of 2000s. I've never actually got to get one to fly yet. I think it's probably the power supply issue, like just ramping it up as I get older and maybe less wiser. With high voltage. No, I just had a quick question about sort of the force readings you were getting, because there's obviously sort of the whole question around the electrokinetic field potentially, that was Thomas Townsend Brown was looking at, and Jeff Menko just finished his book on causality, electromagnetic induction, and gravitation. It basically says that you should get like a force transient on switching on and off. So on, which is basically like when you turn it on, it's supposed to go in the reverse of the current. So it's his sort of, it's Jeff Menko's way of explaining Lenz's law, of why when you're doing induction, the current, when it switches, it goes in the opposite direction and stuff. So I was just wondering whether you got that, because it looked like you had it hooked up to an oscilloscope, and that you would have.
Well, what I learned 4 or 5 months ago is that these digital scales and load cells have a very slow sampling time. So what I did was I took the load cell out of the scale. So it's a 5 kilogram load cell, which I've extended off the edge of the bench. And then I made a differential amplifier that's very sensitive and low noise. And I hooked it to the oscilloscope where I can sample it at 1 gigasample per second, so that I don't get any aliasing, fake false readings telling me I've lost, 3 grams when it's just bouncing around.
Like a high pass, low pass filter type situation.
So I made my own digital scale by connecting the load cell to the oscilloscope. And so what you're looking at on the oscilloscope is basically, if you watch the videos on my YouTube channel, Warp Drive Tech, you'll see me dialing in the 0, which is like the tear on the scale, just getting it's so touchy, but I get it to within a few tens of millivolts of 0. And then I put my 20 gram weight on there, and I, read what it says on the screen, and, it's about 1.5 divisions. And then that's my calibration, and it's rough. I'm not trying to measure it down to the milligram here. I just want to see the effect and know that it's either pushing down on that scale or it's lifting up from it. Here, I expected it to push down, and it did.
Did you see any sort of increase in thrust as you turned it on? Because I think you were turning it on,
Yeah.
then leaving it, and then turning it off. Did it kind of go up and then down again, or?
Yeah. In fact, yesterday before I could go back to the other video maybe, but yesterday it's before my power supply died, it was arcing inside. You could hear it. There was something breaking down inside, going click, click, click. And each time it did that on the scope, you could see the transient where it was changing the weight because it was changing the voltage rapidly as it arced over.
Oh, I can tell you. Yeah, I can tell you what that is. It's arcing inside the CW multiplier. It's arcing from one, and that's why you get the voltage drop, because it's.
I don't have a CW multiplier.
Oh, okay.
No, this is just a 30 volt DC power supply, and I'm using a 0 voltage switch board driving a flyback transformer with a sine wave.
It's arcing inside the. It's arcing inside the coil.
No, but it's not. It's arcing in the power supply. I can hear it. It's the RF or the noise. It's not RF. It's like 40 kilohertz, 30 kilohertz, something like that.
Yeah.
That it's switching. That noise and the high voltage that the flyback is generating is giving me a DC offset. In other words, I'm getting an ion cloud inside the box. All right, which is then feeding back through the because it's coupling across an isolation barrier that is, the core is completely isolated from the coil, and I have insulated wire wound on the core. It's completely isolated, but there's enough ionization in there to break over that isolation barrier and feed all the way back to my power supply, making it charged relative to Earth. And because it's got a grounded plug, it's arcing to Earth inside the power supply. And you can hear it. It's going, I keep saying it's going to blow, and it sure enough it did.
A big old party there. Sounds like a lot of fun.
Anyway.
Do you know what the ultrasound is for? Because I know that you guys were speaking a lot about
shaking ions.
Oh, is it? Oh, okay. Okay.
It's resonance. You want that thing to shake and ionize the air and give you a resonance on that disk that helps to increase the amplitude and spread more ions, like a speaker. All right.
Yeah, I guess you would have kind of cymatics. When you've got the plate with the sort of the dust on, and then you can create resonance patterns. I guess you could kind of then do maybe like an ion trap almost in the air.
I did it with salt on the disk at different frequencies, and when you hit resonance, the salt jumps like an inch off the disk. So imagine those are ions in the air bouncing off the disk. It'll help produce a bigger ion cloud. Plus, that ion cloud could be developed into standing waves, which would then concentrate the charge. And so the idea is to develop a standing wave above and below the disk, where I have a positive cloud above and a negative cloud below, where I can concentrate that charge in the air to cause lift on the center disk. So that's
cool.
That's my idea of this thing so far.
I thought the ultrasonics could be, because I know there's a relationship between velocity and the electrokinetic sort of vector field as well. So like if it's not just charge density or current, it's also velocity as well. So if you're sort of moving stuff like that, then you're potentially, that's like the same thing as sort of switching on and off quite quickly, but using the velocity aspect of it potentially as well.
Yeah, the force.
Oh, that's cool.
The force that I've come up with, the equation that I've come up with is the same as like for a lifter, and it is that the force is proportional to the current, which is proportional to the charge density times the velocity. The current density, the force density. Yeah.
Awesome. No, that's great. Cheers, man. No, thanks for answering my questions.
Well, and thank you as well, Chris.
No
okay,
worries.
so Harold, sir, let's go to you next.
Good presentation, Todd.
Hey, Harold.
Question for you is this. Recently, I saw, I think you are in the right track about the Gravifly doing with the ion. And recently in YouTube, I saw a video from a new startup in Doral, Florida, about the ionic propulsion, in which they are selling a drone that can lift 2 pounds, and it has a flight time of 55 minutes and can go several miles. And with lifting 2 pounds, I mean, I'm going for 55 minutes, flight time. I wondered, how, if you have seen it, what is your relationship with that in relation to the Graviflyer? Because it might explain why the Graviflyer flies the way it does if we're using the ionic propulsion as the main.
Yeah, it didn't. From my understanding, I saw the video and it didn't say much. I didn't read up on it or do any investigation. Mark Sokol did some, and he said that it had a blower, like a ducted fan in the middle.
I saw something like that in the middle, yes, but they claim that it's all 100% ionic defined technologies, and I was wondering,
I think my understanding, or what Mark said, was that the ducted fan is what's keeping it up, and they're using the ionic propulsion to steer.
Okay. And because I saw it recently, and I wondered, that might, that might explain, why the Graviflyer is floating without the fan. Maybe, the spinning disc or something like that. Or what is the contribution of the spinning disc?
It's my theory right now regarding the Graviflyer is partly what I'm just investigating now, because as you're aware, my objective is I've taken the Graviflyer apart into pieces. I think we just lost Harold.
No, I'm here.
Okay, I've taken it apart into each constructive element and testing it separately, right? So as a combination in the Graviflyer, you've got this what I'm talking about of creating the standing waves and a positive charge cloud above it and a negative charge cloud below it, and then it has a lift between them because the middle disk is charged. But in addition, the spinning magnets generate a magnetic field. The way Alexei draws it, it's like a big donut, Torus, and as the ions get flung outward by the spinning disks, just like in the Aurora Borealis, those ions spiral and follow the magnetic field lines, creating a electromagnetic Kawanda effect. All right, so it generates the disks blow the air outward, but then the magnetic field grabs those ions and pulls them downward, pushing it up.
Well, that's a good metaphor to explain the whole thing. So you're still looking.
We'll see. I don't know. I haven't made one fly yet.
Sounds like a good metaphor for that to explain the whole thing. But I look like you're still looking for the synergy of everything to see what is it exactly.
Yeah, well, I haven't gotten any lift out of the magnets yet. Spinning magnets, charged or uncharged, hasn't given me anything. But so far, this test that I showed today with the spiky one is the first time I've seen really any significant amount of weight gain or weight of any kind. So that right now I haven't seen anything on the Graviflyer give me any kind of lift. But I'm not done testing. I got a lot of work to do, and I have a day job. I sell solar power.
Okay. Well, that's good. You're making progress. And you keeping it. It's interesting what you're doing. I thank you for the explanation.
You're welcome.
And good luck.
Thank you.
Okay, let me see. Riccardo, sir.
Yeah. G'day, Todd. I've got a question for you. Let's assume that let's assume that you get your apparatus to work. So it's flying, it's working. Now let's also assume an application as a drone, as a military drone, right? So you've got it working, it's a military drone. My question is, in such an application, would it produce detectable RF of any description? So could it be targeted?
Oh yeah.
Yeah, right, okay. Right.
Oh yeah.
Right,
It's got to, because it's got to ionize the air. It's going to have a huge fingerprint.
That's what I was thinking. Yeah, that's what I was thinking. Yeah.
But it could be made very quiet, but not electromagnetically quiet. Yeah.
Okay, let me see. Do we have any more questions for Todd? There's Jared. Jared, sir?
Hey, just to follow up on that last part about if they'd be visible, it looks like because of the Tesla coil, it emits a fair amount of microwave RF. So, I mean, you'd be able to see it with radar pretty easily.
Yeah, absolutely.
Yeah, it's basically like a giant flashlight in the EM spectrum. I mean, you know, you could probably see that flyback coming a mile away.
Well, what I'm supposed to get today or tomorrow or Monday is still the same kind of design, but it's a specially made flyback transformer that's rated to 60 kilovolts, not this TV monster. You know, it doesn't have all the extra pins sticking out that cause arcs. So we'll see. I can't wait to get it. I've been waiting a month.
Yeah. Let me see. So do we have more questions? Yeah, well, I think we're doing pretty good. So let me do this then. Let me put this on gallery view, and everyone please give Todd an applause again. A giant applause, sir.
Thank you.
Thank you for the update. Thank you for coming back. I love it when you present.
I'll let you know when I got more to present. This one was a little tough to squeeze in because I went 2 weeks ago and I was pretty much said everything I had up to that. So I just covered what I've done in the last 2 weeks. So
well, so now let me go to Mark Sokol and see if Mark has any lab updates.
All right. Bye, guys.
Thanks again, Todd. If Mark is with us. Okay, so I think Mark has stepped away. Do you guys want to do open discussion for a few minutes?
Yep. Look, I've got.
Oh, actually, is Mark back? Mark. Let me see if Mark is back, and let's do an update now.
Oh, sorry guys, we're just setting up an experiment here.
Oh yeah, Mark. I'm actually we're ahead of schedule. I'm ready for you if you want to present.
Oh yes. Okay. So my apologies. Last week I was presenting, trying to show you guys some videos, and instead of showing you the videos, you guys are all watching my OBS video program setup. So we're just going to go over those videos again. And there is one new one as well. Just bear with me a moment while I pull them up. Okay. Test data. Okay, so hold on a second. Resize that. Share screen. Okay, now can you see this this experimental setup? Tim, can you see it? Is it good?
Yes. Sorry about that. I had you on mute. Yeah. No, it looks great.
Oh, okay. So this was one of the first experiments we ran. And instead of using the large electromagnet, we wanted a gradient magnetic field. So that's a stack of 2 neodymium magnets. And on top of it was the millisaucer with bismuth in it, which is, we call it a millisaucer because it's a millimeter-sized saucer shape. And it has bismuth in the center of it, basically making like a 30-gram sample. The horn antenna dispersed the field a bit, so it was not getting a full 200 watts output, probably getting closer like 1 or 2 watts. And the scale measurement was being read via a mechanical scale over here. And I'm just going to run through it pretty fast. Zooming in on the scale, this is over the course of an hour. We're changing different frequencies. Didn't see any movement in it. The scale remained rock solid. And this is when I was going in there just to readjust something. So this setup didn't produce much of a result. The next experiment was using a piece of smelted aluminum that had a little bit of iron in it. So this was the ultra pure aluminum sample that we had. Smelted it, added a little bit of iron, and ended up with a little puck. Same setup. There's a larger magnet this time. Scrolling through it over here, we're not seeing any change on the scale. We're rolling through the frequencies. We're rolling through the magnetic field strength, confirming that the RF was going in. Again, this magnetic field was getting just probably less than 1% of all the RF radiation that was coming out of there, and the skin effect wouldn't have penetrated the sample. So we didn't really see anything happen with this experiment either. Now this is a close-up experiment. This is a millisaucer. Millisaucer is like 30 millimeters across or something like that. It's shaped like a saucer. This one doesn't have anything in it, so it's extremely lightweight. As I recall, the scale was having trouble measuring something so light, and the diamagnetic effects of aluminum started to become very apparent with this setup. And it became hard to get the sample to stick within its comparable magnetic field for EPR to take effect. EPR happens at 28.025 gigahertz per Tesla. So we need a correlation between magnetic field strength and RF frequency in order for that to happen. And it was a very small window when you're using a single magnet like this because of the gradient, of course. So here we're starting it. Again, you see, we did see movement over here, but this is, it just dropped in a second, and then it flew up. So it was basically giving us a hard time, standing in that center area. Again, this sample is very lightweight. We're talking probably like 2 grams total. So then we zeroed it out so that it's very, very lightly touching this surface. But, if it would lift off the surface, we would see that. And with this setup, we didn't see any weight loss. Remove the, let me see, actually, I do see some movement there. Yeah, there is a little movement there. It didn't lose weight, but it did move. It's always fun looking at these movies afterward, because that's when you actually notice what happened. You don't see this while the experiment's actually taking place. So it did move along the surface there. So there was stiction of it sitting on a surface, lightly supported by the string above it. You can see the string even has a kink in it. That's how lightly it was supported, right? And it actually did move along the surface. That's very interesting. Did not notice that before. And then we removed the plastic, the PVC, and it just fell down again. bottomed out. So you can't really get great results in that setup. But this is something that I just noticed right now. Look at it slide across the it's sliding across the base over there. That's pretty interesting. Okay. We'll have to redo that experiment in the near future. This next experiment is let me get the name of it again. Niobium. So this one was kind of cool. We used I think it was sample 24 or something like that. Stuck it inside the chamber, turned everything on. Niobium magnesium powder inside of an epoxy. And guess what? It lost weight, but not for any good reason. So we started turning on the RF, and here's what happened. Then this happens pretty quickly. This is a spy camera, by the way. Up on the top left, we're looking through a fiber scope straight into the chamber. And there's a little bit of light in there as well. You're going to see exactly what happens to the sample. And don't forget, it had magnesium powder in there, which is highly flammable. So there, rubber bands popped, scale bottomed out, chamber filled with smoke. Sample basically caught fire, quickly shut off the experiment. It bottomed out because the sample fell out of the sample holder, destroyed the sample holder in the process as well. So at this point, we decided we need to put a thermal temperature sensor device inside these chambers, because we're pumping them with so much energy that you know, we can cause things to go on fire. This next experiment was thick aluminum plate. It was inside a rail system so that it couldn't move from left to right, could only move up and down, and it couldn't wobble. There was a lot of stiction in this setup. And as you can see, that there was a tiny bit of movement there, but you know, there's a tiny bit of movement in that scale, but not much. That I think was from going inside, and we went inside to check some things, so that wasn't the weight loss. Okay, next experiment was, again, we're doing the business millisaucer, but this time we're doing it with the large electromagnet over here. So this is a homogeneous magnetic field in the bismuth, with the bismuth millisaucer setup. That weighs about an ounce, and it's really, really tiny. I have it right over here. This box somewhere in here. This is that thick aluminum plate that I was talking about a second ago. Here is our temperature sensor that we installed in the chamber. We had to CNC put a special window, a germanium window, to allow for the thermal imaging to come through. That was quite a process. You know, we had to take the entire thing apart and rebuild it. So at this point is when we really get the experiment started. Here you can see the RF is in running mode, and that scale is not moving. Moved a little bit, but yeah, it's not really moving. Just a tiny bit. Sample did warm up as well. We didn't see 80% weight loss, as Al-Zafan said. That's for sure. This is sample number 3. We were a little excited that night. Had a couple friends over on Zoom, and we were doing anti-gravity experiments with aluminum powder inside of epoxy. Now in this setup, you can see the temperature reading over there. Those are in degrees centigrade. So we were monitoring temperature as we're going through these experiments. We had to shut down the experiment every once in a while because the temperature, as soon as it got near boiling, I started, you know, getting concerned that we would again melt the plastic sample holder or the string that was holding it. So we had to take breaks through this experiment process. It was about an hour long. there was a little weight loss there. I guess we're again a little bit more, and we set up a that was the radio that we set up for listening to the static. But we're concentrating on that scale on the bottom left. There is a couple bumps over there in the beginning, but so there might have been a little bit of weight loss, but in terms of actual usability in a craft, the sample, at least this setup, it was warming up so quickly, really became very useless as a propulsion system, at least in that iteration. The force meter, it should be ignored. That is not part of the experiment. The potential shows, I think, there's a shunt on the electromagnet, and that's the voltage across the shunt. So for monitoring the magnetic field strength. But we've since shifted to a new system where we put a Gauss meter directly on the electromagnet. So we read that to get our electromagnet readings. Actually, Tom, we got to set that up. Can you grab a piece of copper tape? Got to set that up for our live experiment. Okay, so this is an experiment that we actually saw something very interesting happen. This is osmium, a little piece of pellet of osmium that was wrapped in an aluminum foil mylar blanket, which is extremely thin aluminum. Now, the sample in this did lose weight over time of significance. See that? There was also a movement in that string as well that did coincide with it, so that may have caused an error in the reading. But I did notice in this experiment, I think it was around 23 minutes in or something like that, there was a movement in the sample right when the frequency of the magnetic field matched up, right when resonance should have been happening. And the sample twisted a little bit, and that we saw that on the spy cam, which is on the top left of the screen. That was pretty interesting. We're going to try replicating this experiment today, and we're going to do it using a instead of a chamber, we're going to have it in open air with a waveguide pumping the RF into the entire Faraday cage behind me. So it's another variation of that experiment. And that is one of the last experiments we did. There's one more experiment, but it's in a different folder. Let me pull it out. So we also ran one on just the other day. Okay, there we go. Yeah. So this is a sample of ruby. Now, why are we using ruby? Ruby is aluminum, silicon, and oxygen as well. And so it's basically aluminum, which is one of the stronger participants in dynamic nuclear orientation. It's a compound of it. This is also what George Hathaway used in his experiment. Now, in this setup, we did away with the scale, with the mechanical scale, because we managed to get a very sensitive digital scale that is outside of the Faraday cage. So it's literally on top of the Faraday cage. There's a hole through the Faraday cage, string drop down from the bottom of the scale. I first ran a null test with nothing on the scale just to make sure that it wasn't getting interference from RF. No interference. So we're finally able to use this mechanical scale over here, this digital scale, I mean. Here we're getting live feeds from the scale on the right. It does have a bit of a drift depending on temperature. So when the heat turns on in the room, you could see turns on or off. You can see a slight drift over there. Yeah, I think that's what we were looking at with these numbers. Although I did notice that there was spikes in weight loss. Not in this setup, actually, would be the next experiment that happened. So the numbers are pretty, they're just changing with the temperature in the room. I guess that changes some of the electronics on board. And that's just the nature of these scales. Okay, so in this setup, we covered it with that same aluminum mylar sheet, which is like an emergency blanket that the Red Cross will get out. So upon powering it up initially, you can see it sort of gets crushed over there. That's from the RF was too powerful. We had to tone down the RF quite a bit. You see, I see negative 26 decibels. I think I dropped it to like negative 50 or negative 40 decibels. So in this setup, there was much more drastic changes. You see here changes of like 5 micrograms, or those would be 50 micrograms at a time. And it was going up and down in all directions. We did notice a correlation between the pulse lengths that we put in and sudden weight losses. It was going in all directions with the weight loss. Again, the sample is not in a perfectly homogeneous field because we couldn't get it to line up horizontally. We'd always want to go in the path of the magnetic field. But you can see here that there were much more drastic changes than what temperature itself can create with our scale system. Of course, a future step would be to isolate the scale thermally in a small chamber, but you know, that's for a later date. Then we'll have rock solid numbers. When I pumped up the power pretty powerfully toward the end, we saw the most dramatic weight losses. And that's when I took the sample off. We did see much more dramatic weight losses when I pumped the power up to full. And this was with ruby and covered in aluminum. Okay, any questions yet?
Yeah, I have one.
Yeah,
sure. Go ahead, Ricardo.
Yeah. So look, first of all, absolutely excellent the work that you're doing, and I've got to say, I feel like someone that's coming in cold to this conference series. I feel like I'm watching history being made. So yeah, really well done on what you have been doing and what you've just done now. So that's the first thing I just wanted to say. Second, my actual question is, looking at what you're doing, and I know what Todd's doing, and I've sort of already floated this question to everybody there, but I'm going to put it to you now. Would a discussion around the history of the cosmos, and there have been instances that I believe I can demonstrate where the environment for faster than light travel has occurred naturally, right? Would a discussion in that space assist you in any way, do you think, in helping you to design experiments or things that you might need to consider? Would you welcome some kind of discussion on that point?
On the origin of the cosmos?
Well, no. So let's, I'll just simplify it. So you've got the Big Bang, you've got now. Between the Big Bang and now, right? And an example is cosmological inflation, where the cosmos inflated in the first, 10 to the minus 23 seconds, and you had an environment where space-time was literally traveling much faster than light. And if you map the history of the cosmos in terms of cosmological constant and stuff like this, you can see in the history of the cosmos that there have been instances where the speed of light has been c. It's not actually c now. It was more c. It was faster than c in the past. Would a discussion covering that and looking at the conditions, like what the temperature was, etc., all these kinds of stuff. Would a discussion in that space assist you in any way, do you think, in helping you designing experiments that you're doing now? Is it going to assist you? Is it going to give you any ideas, any clues?
I don't know.
What do you think?
I'm not really sure how the two are related.
Well, I mean, I know in Todd's case, for example, he's looking at modifying the space-time manifold through an analysis of, harmonic oscillators, and much of what he's doing now is aimed towards demonstrating how space-time can be the manifold can actually be manipulated. So I'm wondering whether the work that you're doing might get some kind of insightful advantage, give you some ideas, some that you might not necessarily have thought to go in the past.
I mean, you're asking me if it's going to tell me something that I didn't know, which I can't know. That's an unknowable that I can't know until we've had those conversations and we know.
Yeah, fair enough. Okay, all right. Look, I was just like I said, I was impressed by what you've done.
Thank you.
I was just wondering, whether a discussion in that area might give you some more ideas around different experiments and et cetera, et cetera.
I mean, we have ideas for lots of experiments. We have lots of experiments that are half finished too. The issue is that ideas are a lot cheaper than action by many orders of magnitude. There's probably, for every 1,000 ideas, there's one person who actually does anything. And that person who does something has ideas of his own. So there's a lot more ideas running
fair
around.
enough, okay.
There's a lot more ideas running around than there are people who are doing anything with it. And we're trying to fill that gap with more people that are doing stuff about it. So these experiments surround EPR, electron paramagnetic resonance, which is the Alzaphan experiment. Basically, we're trying to orient the subatomic particle spins in the core of an atom using the valence electron's spin, energizing the spin using EPR. Basically, get magnetic field, which makes the electrons process in a more coherent way. Depending on the strength of the magnetic field, they process faster. So there's correlation between magnetic field strength and frequency of the electron's precession. And we know what that ratio is. It's 28.025 gigahertz per Tesla. And by hitting the electrons at that frequency with that correct magnetic field, you're able to pulse it and that then transfers its orientation as extra energy to the core of the atom, and the core then becomes more coherent. And we believe that when you have this coherent matter state, it will no longer connect to incoherent matter such as the Earth and the cosmos, and it will be free from the restraints of inertia and gravity, but only along its plane of axes and its plane of spin and its axes, which explains why flying saucers cannot do a barrel roll, because they're just flying along a flat plane. They can do a 90-degree turn at 10,000 miles an hour, but they can't go like that. So this experiment we have set up right over here that you see surrounding me is the osmium with the with the aluminum on it, and we're going to power this up in a moment and see what it does. So first, I need to get the Gauss meter installed. So just give us about 2 minutes. We'll get that done, and I'll be right back. Okay.
Good.
Okay. So we're waiting for Mark here. We could do open discussion. Okay.
Yeah. So look, just on the point I just put forward, how would people feel about a discussion in that space? Because it seems to me that any kind of propulsion system has to interact in some way with the background field, right? It has to, right? So even in Newtonian systems, the background field is the air, right? So even with what Mark's doing, trying to change the weight of something, that's changing the weight, which is interacting with the background field. We call it gravitational acceleration. So it seems to me, the idea, it seems to me that relevant that if the history of that background field has changed, are there any clues in that history that might help with ideas, experiments, etc., etc.? That's the question, and I just want to get what people might think about that.
What do you mean by change?
Well, for example, would you agree that the universe is different today, assuming the Big Bang model is correct, right? Would you assume?
I wouldn't assume that.
Well, let's just
it was invented by a Catholic priest. Why would you believe it?
In order to answer your question, in order to answer your opening question, right? What I'm saying is, make the assumption, because you said, is it different, right? Well, the assumption is, let's start with the Big Bang. The initial state was, let's say, some dot, which is the accepted theory in physics, standard model of cosmology. And now we don't have a dot. Now we've got a much bigger dot, right? So everything has changed, right? So what I'm suggesting is that if we understand more about that change, the question is, might that be advantageous to, physical experiments?
It wouldn't be advantageous. I think it would have the opposite effect. If you assume that it's constant, it's not changing, then that's a variable you don't have to worry about. If you have some change, unless you know the rate and you know all the properties of that change, you're just creating too many variables for you to solve it. Is the problem. If you assume it's constant.
See, I disagree with that respectfully, and I disagree with that because the rates of change and all that kind of stuff is actually knowable, and it is knowable. I've calculated it, and it agrees with experiment.
Say again, it's
so
knowable.
The information, yeah. So all that rates of change, that cosmological history that I'm talking about, is knowable, and I've mapped it, and it exactly matches physical observation. So I think the idea of a static universe just does not fit the data at all. And it goes against the standard model of cosmology, which the vast majority of physics agrees with.
Do you believe in offset spatial divergence? Do you know what I mean?
I have no idea what it is. No.
Okay, offset, that's like if you're on Earth and you travel at 10% the speed of light for a year, and then you turn around and you come back, then the people that you knew when you were alive, they're all dead and gone. Because your time, because of offset spatial divergence. So depends on your frame of reference, whether you're moving or accelerating or not. Wouldn't you agree?
Well, yes, but isn't that just time dilation? So
time
isn't
dilation,
that just a classical?
And it can either dilate, it can go both ways. It depends. Depends on whether you're accelerating or you're not.
I agree with you, but I've never heard, I haven't heard it expressed with those words, offset time, what do you call it? Offset
spatial divergence.
Yeah.
To travel,
so
to simply put it, to travel in space is to travel in time.
I agree with you. What I'm communicating is that I've never heard it actually labeled as offset spatial divergence. I've not heard it called that. I agree with what you're saying, but I've
well, I appreciate it. It's a new concept. I appreciate it. It's hard to wrap your mind around it because you just assume everything is constant, even though, but when you're moving, it's not. Things are changed. You're relative. If you move in space, you move in time, and vice versa.
So I don't understand what you're what you're trying to communicate, because
Well,
what you
space-time
said
depends on your frame of reference. So, like for example, if you're on the sun or near the surface of the sun, your time goes a lot slower because of frame dragging, gravitational frame dragging. Kind of like
so
when
that's
your cell phone, when you're using your GPS satellite, the GPS satellite's time is faster than our time here on Earth because we're in a gravitational well. So
yeah, and that's just standard. That's standard GR.
So, but then you take that and you do special relativity, which is what I was talking about, where if you accelerate towards the speed of light, it changes the properties of time.
Yes, again, to my knowledge, that's not new information. It's not discovering America. What do you suggest?
You don't need a big bang for that. That's my
no,
point.
no, but right, okay, all right. So what I'm saying is that if the space-time manifold has evolved over time, can we learn? And if we want to develop craft that can travel through space, and one concept is faster than light travel, right? So my question is, can we learn anything from looking at the history of the cosmos where faster than light speeds have occurred organically, naturally? And it has, right? And the simplest example of that in the standard model of cosmology is inflation, cosmological inflation, which occurred in the very first moments of the universe. And cosmological inflation was inserted into the Big Bang model to make it work, right? Now, if faster than light conditions, faster than light kinematics has occurred naturally in the history of our cosmos, if it's a natural occurrence, that means it can in fact be reproduced, right? So what I'm suggesting is, is there any advantage to understanding, to discuss the conditions that occurred naturally? Will that, observing nature, is that going to help us invent machines? That's what I'm suggesting.
Well, that's what we're doing when we're looking in a telescope, is we're looking into the past.
Yeah,
because light travels at a constant. So if we look at Alpha Centauri, which is what, 2.5 light years or something away, and then it took 2.5 years for that light to get to us. So we're looking at the past 2.5 years ago. And if we look at like light from a galaxy that's a million light years away, it's 1 million years old.
Yeah. Anyway, look, I hear what you're saying. My point stands. You know, is there any advantage? That's the question I'm asking the community. Is there any advantage to discussing the changes of the past to help us build machines of today? That's the question.
Well, it'd be an interesting presentation.
Hey, Ricardo and Michael, if I could just interject real quick, there is one scientist from UC Berkeley, Medina, Raymond Chow, and he was showing that tunneling, which totally natural thing, electron tunneling occurs somewhere around 1.6 C.
Yeah, it's faster. Definitely, quantum tunneling is faster than the speed of light, but not by a lot.
But what I was going to say was the only way that you would ever be able to see this on the cosmological side of things would be with black holes. If somehow you managed to be able to measure, which I have no idea how we would because it's so small. But if you were to measure this tunneling from one side of a black hole to another, coming through it or whatever, I don't know how you'd be able to see it. That would be the only cosmological way that I could think that we'd be able to see it, because if the wavelength of the electron is stretched across the entire event horizon, right? You see it pop in one side, pop out the other side, and you know the width of that thing, it goes across it faster. But like I said, unless you have a stream of electrons, it's pretty darn big.
A good example of that is a coronal mass ejection. What happens in a coronal mass ejection is that So like a solar flare, that precedes the CME. It has it takes about 7 minutes to reach the Earth. And if we're like we're right in the eye of the X-ray blast, it wouldn't harm us because of the atmosphere. But now a coronal mass ejection, it takes 2 to 3 days to reach the Earth because it's like a big wave of proton flux heading towards the Earth because part of the corona is thrown into space. And then that takes 3 days. But they discovered that on the opposite side of the Earth from where the sun is, a day and a half before, the decay rate of certain radioactive isotopes changes a day and a half before the coronal mass ejection occurs. So essentially there was some kind of signal coming from the sun that was preceded by the actual event a day and a half before it actually occurred. So that's an example where you don't need a black hole. It's just a natural thing that happens.
All right. So anyway, back to what I was proposing. Would the audience, generally the discussion around the history of the cosmos and the potential for faster than light conditions be of interest to the collective? That's what I'm asking.
I believe that's what we're about, actually. So, like I said, I think it would be great if you would do a presentation or something. I think we're always open to new info.
Well, if I could jump in really quick, I just want to let you guys know that Mark is still working on things. He said that his sample is still swinging.
Yeah, it's dancing around over here. If you guys look on the side, we're just going to wait for it to calm down a bit. The RF is ready, but we're just waiting for the sample to calm down. So you guys continue open discussion for the 5 minutes.
Okay.
And I just found here's one example of it. Let me see. New system could predict solar flares, give advanced warning. I'm going to paste this into chat. Oh, and they're predicting that it may be neutrinos that do it. That's what the sum of the article. That's the.
Yeah. So the article says Fishbeck and Jared Jenkins, a nuclear engineer and director of radiation laboratory in the School of Nuclear Engineering, are leading a research study to the phenomenon and possibly develop a new warning system. Jenkins monitoring a detector in his lab in 2006 discovered that the decay rate of the radioactive samples changed slightly 39 hours before a large solar flare. Since then, researchers at Purdue have seen similar variations in decay rates before solar flares. Phenomena represents a possible way to predict solar flares, allowing satellites and power grid operators to take steps to minimize impacts and astronauts to take cover from potentially lethal charged particles emitted during a solar storm. Large solar flares may produce a coronal mass ejection, of highly energetic particles which can interact with the Earth's magnetosphere, triggering geomagnetic storms that sometimes knock out power. Solar activity is expected to peak over the next year. And so as part of an 11-year cycle, that could bring strong solar storms. Let's see what the date is. Oh, that's 2012.
I think John's got a question for someone.
John, go for it, sir. We're keeping open discussion, so you don't need to raise your hand, but go for it.
Hey guys, on the topics at hand of observations of faster than light phenomena, I would throw in that there have been some successful experiments with what are called optical and sonic black holes. Now, they're not to the point of wormholing across it, I would say, but basically, loosely interpreted, these results show kind of a wormhole across horizons. The neat thing about these phenomena is they're not gravitational black holes. So you look into this, it's pretty far out there sounding, but if I remember, these guys pulled this off where they detected Hawking radiation from what they call optical and also audio or phonic. There's some word for it.
Acoustic.
Black holes of sound and light. Right? Have you guys heard about?
Yeah, it's
I think it's acoustic black holes is the expression.
Acoustic black holes. That's the sound version. Yeah, and
it's called acoustic levitation.
Yeah,
that's what I showed earlier. That's what that little device was I had with the styrofoam. That's an acoustic levitator.
That might be a
It's a
little
combination
different
of both.
I'm talking about Hawking radiation, basically from a band-stop filter. If you have a filter that's clean enough in the noise spectrum, you can detect the production of particles corresponding to Hawking radiation of that that situation that you're creating by stopping the wave phenomenon. So it applies not just to light in the optical black hole situation, which is more familiar, more like what Hawking talked about in the chapter "Black Holes Ain't So Black" in A Brief History of Time and in the technical publications that led up to that. But it right with the wave particle duality, it turns out that they calculated this should work with sound as well, and I believe that was an Italian experimenter. But I don't know what we can do with it. It's like it's easier to tunnel across a barrier at this point than to build a tunnel through ordinary space. And of course, these are across microscopic degrees of freedom. There's really no hope of opening up these tunnels for a spacecraft or something, especially in the case of a man-made optical black hole. But
unless we can shrink them.
Unless we can shrink them a whole lot. Well, that's what's interesting. I was hearing about NASA's plan of these solar sailed craft with the laser booster, basically, and the things about the size of the sail's huge, but the thing getting pulled by the sail is like the size of a microchip. And they're talking about 20% of light speed, and this is an official project they're trying to get funding for already.
Yeah, I had heard something about that.
Yeah, just kind of establishment or mainstream approaches are getting into some pretty interesting results. As far as observing the basically cosmological constant at work and seeing the universe expand at faster than light speeds with reference to remote locations to that which is traveling. I think this kind of paid off in the Alcubierre metric and its successors. I think there's a new version of the Alcubierre metric that does not require a negative energy condition.
Yeah,
Now,
correct.
of course, these are still just monster energy fantasies where we're going to be able to basically detonate a whole star at one instant and travel apparently to reach the energy costs. But I have heard there are researchers trying to rein that stuff in too. But just a couple of thoughts on stuff that people are working on along the lines of what I'm hearing. But I think on one hand, in the 20th century, say in the bomb era, people thought the faster than light was going to take maybe a couple thousand years to figure out. I think we could be on track to see it within a couple hundred or less. I don't know. So maybe somebody in here like say the this like I don't know. I don't want to say what do we call it? Inertial drives. And some of these experiments, and there's not a great explanation for them, but we see maybe some weight reduction or something. Some of us might tend to be a little bit uncharitable in our assessment, but I was looking into kind of related phenomena in the mainstream, let's say, and in general relativity, there's this notion of swimming. This was big. They even got an article in Science Journal, right? The biggest overarching journal in the, all the big wig academics. And there's this notion of swimming. And if you kind of move something around in a sophisticated way, in the presence of a strong gravitational field with gradients far steeper than the Earth's, it's thought now to be possible to kind of move strategically, to move the mass within, say, a vehicle strategically to greatly ease travel, even through a strong gravitational field. You guys might be interested if you haven't heard about that. I know we were talking about gravito-electromagnetism earlier, and kind of we lump in there, I think a lot of us lump in there kind of E&M versus gravity as well. And there's actually some good stuff on this. This physics professor, I guess his name's like Jim Ranchler or something like that. I think he's at a university somewhere in the US. He's got this podcast, Physics Frontiers, and then there they got a great in their episode on electromagnetic propulsion and gravitomagnetism. They've got a wealth of resources of references, on the subject. And this goes back to some of the earliest pioneers in applied relativity. And apparently they calculated there's a power law relationship between regular electromagnetism and gravity that can be exploited at short distances. It's just that no one has a physical material that can actually have the density of the magnetic flux required to see a huge kind of amount of power come out of it. But it turns out that plasmas can be magnetized. And this is what I would recommend people to look at, because it turns out that quite a strong density can be held in a plasma. It's kind of the inverse of the thinking of the tokamak reactor.
Just on a sort of taking it a different direction for a moment, I'm just wondering what you guys or what the community might think about, do they know of any Chinese efforts in this space of electromagnetic propulsion and stuff like that? Because I noticed on the page on ResearchGate, I noticed the link to my work regarding Bob Lazar. It's called Analysis for Claims Regarding EM Propulsion Systems. I noticed that there's been a big jump in a Chinese audience accessing that information. So I was just wondering whether you guys have heard of how seriously the Chinese Communist Party is taking this kind of thing. Anybody know?
I don't think it's a communist party per se. I think there's Chinese scientists that are working on it. I have some friends that are this device I got is from China. They have their own. They're working on it. Is the short answer. Yeah. But is it a government funded program? I suspect it's like our government's funding. We're here, we're doing it. I mean, there's been a lot of, there's like the Pius, Salvador Pius patents and stuff like that. The government definitely has funded certain individuals that they have some level of confidence in doing the research, but there hasn't been any like Manhattan Project type budget behind any of it. It's all small scale stuff as far as I can tell. So
I was just wondering, I was just trying to relate it to, you would have heard claims by various presidents in the past of stealing intellectual property and stuff like that on a large scale by the Chinese Communist Party across whole different areas. I was just wondering whether this.
Can I throw in on the China connection, Ricardo? The Chinese government invested in a paramagnetism-based, what they're calling an anti-gravity chamber. It is, if I remember, it's too small for a human to get into, but it's much larger than the floating frog experiment with paramagnetism. And they claim this gives them a tunable gravity environment where they can simulate partial Earth gravity, like they can actually tune the paramagnetism, they claim, which if you think about that, it seems like a bigger claim than just canceling the Earth's gravity with paramagnetism. But
just want to give you guys an update. The sample is still shaking, as you can see in the video. I have a call at 7:45 until 8 o'clock, so I think we'll just hold off on this, let it settle down until 8, and hopefully it'll be calm enough by then so we'll be able to get some accurate readings. So just keep the open discussion going.
Okay.
I saw Bernie has his hand up. Bernie, are you there? All I see is the top of your head.
Hello. Sorry about that. Trying to find some YouTube links to my buddy at Faraday Research's latest videos in the meantime until he joins in. But he's got some interesting
Faraday Research is here, and that's Alex Frolov, right?
No, Mike from Faraday Research. He's from Toronto.
Ah.
Oh, there he is. There's Mike. Mike, you can unmute yourself and give a better description of who you are.
Yeah, I kind of feel out of my comfort zone here. Everybody's talking about anti-gravity. I'm more into the energy stuff. But I do think the energy and the gravity have a very important correlation with each other. I have some theories on anti-gravity. And I was listening to a lecture by Eric Dollard. I don't know if you guys know who he is. He's been pretty much studying electricity his entire life, worked for RCA, worked in Bolinas. He's got a very huge background in electrical engineering. And he had this theory that kind of goes back to Tesla, what he was talking about. If you're able to find the universal grounding point of the universe, everything like inertia, all that kind of stuff would basically go to zero. So, you could stop on a dime basically, and how can I put it in proper sense? It cancels everything out. If you're able to ground yourself to the universal grounding point, because us, like, we're on Earth right now, we're traveling through space at a huge rate of speed, and we're also in a spinning motion. So if you're able to find the universal grounding point of space-time and stop yourself in that universal space-time to zero, everything else out, all the forces of gravity, inertia, all that kind of stuff basically stops, because you are in the universal grounding point. I don't know if that resonates with anybody. I'm more of the energy field, so.
Would you know if the grounding point is actually a point or is it a state?
I think it's a state.
Yeah, like an inertial state almost, hey?
Right.
Mike?
Yeah, it's a
Relevant.
cancellation. Yeah, because the Earth, everybody in it, we're going through space at a huge rate of speed. All
And then
right.
we've gone around
So
the sun, and and the sun's going around the Milky Way.
that's right.
And the Milky Way's going in the universe, and so it's like everything's in constant motion.
That's right.
So what
That's
you're
right.
suggesting is if we could find the quote ground state of the spin of the universe of
The 0
space.
point of it, which would essentially be also your singularity to start from a neutral in a wormhole or portal, I guess, is also what Mike is essentially describing.
Well, it's kind of like it's a type of fractal. It's
Mhm.
kind of like you think about the atom, and you look at it, and it looks just like a galaxy. Okay, so it's like real tiny, and then something the same thing repeats over and over again.
Right.
So it's a
And, yeah, as far as I know, there was some writings that Tesla was doing, talking about this universal grounding point, because all the electrons, say you're traveling through space, any matter that is in space, like the ether, it's rubbing off you. It's like you driving in the car and you slam on the brakes and you got that screeching noise of your brakes. That's the electrons in any matter that's in ether affecting your body, but also leaving your body behind, leaving a trail. So Tesla was talking about, if you could find this universal grounding point, it cancels everything out. Gravity, inertia.
Yeah, and then you could teleport to wherever you want to go.
Yeah,
and then
so
time
now
travel would be possible too, because it's all part of that.
yeah, it's all related. I think we're getting into the quantum part. It's not
Yeah,
just
exactly.
gravity.
It's something real tiny. It's not
Yeah.
something real big.
Yeah.
It sounds to
Can I-
me like that.
Go ahead, hop in.
Can I suggest that at this point, probably the closest in our solar system that we can find to this will be your stable Lagrange points. I can talk about the difference between the unstable ones also being attractors in a local gravitational field, but they're a repelling type attractor, and they don't have this property in the exact same way. In some ways, it's probably heightened as far as their attempt to show quantum gravitational effects. Now, I can't promise teleportation or something. I would suspect those type of experiments would be easier to be more successful with less gravitational input in the local field. But my thinking is the only thing I've predicted so far about Lagrange points, I think that in a quantum field, a quantum theory of gravity, Lagrange points should have their own Lagrange points. So if you look at the equation for finding Lagrange points, you have this like radical in the denominator, you have this absolute value in the numerator. And this is like kind of a nested radical kind of system. If you iterate that again, you get another whole set of solutions of, I guess it goes like cubics, and then there's like 25th order or 10th order. I haven't looked at it in detail. I'm still trying to hash this out. But
So gravity is a parabolic force. So that means that if you factor it, it has two real factors, right? Anti-gravity, on the other hand, is a hyperbolic force. So that means it's distance cubed over time cubed dependent. So it has three factors, one real and two imaginary. But we know it's real. We know both of them are real effects. So there's part of the universe of space-time is in an imaginary realm, and part of it's in a real realm.
I'm glad you mentioned basically the complex plane. So we're
Also,
looking at
that's other term for like the multiverse, but also quantum realm. Is that correct, Boyd?
Yep. So there's a multiverse of different. It's like there's a little tiny universe, and then there's a bigger universe, and so on and so on. It's like a fractal. Starts out with something and it repeats over and over again. And that's what we call expansion.
if we look at the Lagrange system as a template for this fractal and its branching, it has what's called a forbidden symmetry. For organized matter, you're allowed kind of crystalline symmetries which have 4-fold, 6-fold, certain even-fold symmetries are allowed, not the 5-fold that you get with the 5 Lagrange points. This suggests that in a proper coordinate frame, that the universe could be shown to have a quasi-crystal structure, kind of a like a fractal state of matter, where that state of matter is inherent at a transition point.
Yeah, so John, kind of what I'm getting you picking up on is that there's multiple states of dimensional matter, like both higher and lower. Essentially, like crystals could maybe even be like a 6-dimensional state of solid matter, where plasma is our 4th state of matter, solid being the 3rd, and there might be an etherical that is the 5th that folds back into itself between the plasma and the crystalline or the higher dimensionals within this matrix.
So this is what makes life possible. How can you continue to have something continue to exist unless it's it's got to be better than unity to be able to grow, doesn't it?
Michael, that's a really great insight, and I'll say even further, the definition, going to the definition of life. I got the honor of teaching life science this time around. I said, wait, I'm a mathematician, maybe a mathematical physicist. My principal's like, you're gonna teach life science. I go, awesome, okay. So I'm studying the basics. What the hell is life? And stripping aside all the stuff we all know, that they reproduce, they eat, this stuff, you get to 2 main properties, and it's really interesting what they are. The first one is that it exhibits some kind of local order. The second one is that it exhibits a sensitivity to initial and boundary conditions. And you go, wait a minute, that second one, has no one noticed this? That is excuse my French, that is the definition of mathematical chaos. So on one hand you have order, and on the other hand you have chaos, and the marriage of those two are to me the 2 salient defining characteristics of life. But guess what? Those are the defining characteristics of the whole universe itself. So some of us might not have that kind of animist philosophy of the universe, and it's great if this doesn't resonate with you and you can't use it. But for me, this suggests that observership, while it looks like it was written out of the quantum axioms, watch out, maybe it'll make a return, and we do need mind to suffuse the universe for it all to work. This seems to be in line with.
Wouldn't that suggest that we're all the same life?
That's right. That's what that would suggest, right?
Tim, Ricardo, we're all the same life, and we're looking at ourselves subjectively when we're awake.
We are individual fractals of a higher fractal dimensional consciousness.
I like your idea, Mike. So who can I send my bills to?
Who do you send your bill to?
That's right, yeah.
Prime Minister Justin Trudeau, I do believe.
The Grand Poobah.
Vladimir Putin.
You could say that the fractal circles are just nested vortices of time, spatial dimensions of different realities that branch off into different possibilities.
Vortices are a type of fractal. So
yeah. There is a guy named Anirban, I can't remember his last name, but he had made something on the nano brain he's currently working on. You've heard of the time crystals that they supposedly had came out since I think it was Google or whoever was working on these crystals that had different effects at past the virtual photon level or something, where they're supposed to go inverse time. But in the like little space, you have your two barriers, and then in that space properties act differently. So, but this guy, he's made this weird organoid type of it's not even silicon he's using, I can't remember, but he made some type of organoid type of jelly, like little brain.
Organoid. Or
Yeah,
that's like that's the metal in embedded in some kind of what is it, polycarbonate or something like that.
yeah, some type of construction, like it's biomechanical, or it's really bio, but it's like not got any synthetic parts as far as like circuit boards or silicon or carbon. It's like what kind of like what we're made out of, stuff.
Kind of a filter, isn't it?
Yeah, but he made
to clean your. It's like for EMF control or something like that, isn't it?
Well, it's made of like what DNA is kind of made out of, but he made this like little, like he programmed the biomatter. My mind is like can't remember brain farts. Like programmable, biomatter, like they say our DNA carries information, it can be reprogrammed. So it's basically he's using that concept, and he actually made this genetic nanocomputer basically, and it can calculate differently like DNA could, with information. And I have his whole book, tells you how to construct the thing and everything. Wasn't cheap, it was like $200, but he tells you how you can make it and what
do you have a link to it that you could put on the chat?
Yeah.
Well, when we're off.
Oh yeah, definitely.
Please, would you please post it on the chat so that we can all look at it?
Yeah. But you would have to. Yeah, definitely. But his fun thing was, it's like he decided to, like, if a Fourier analysis could not measure, all the signal vibration, fluctuations exactly. So he proposed using fractal math to measure the fluctuations instead, and using prime numbers as the basis for it. So to let the prime numbers map out all the fluctuations. I don't know how that works, but he called it phase prime metrics. And then something about, he said that there are no parameters.
Yeah.
But anyways.
Ciao, guys. Sorry, I've got to get going. It's been really great listening to everybody. Really appreciate. Got some great ideas here. Anyway, just wanted to say that. Sorry to cut you off. I didn't mean to. So yeah, see you guys soon, I'm sure. Cheers.
Thanks.
Thanks again. Have a great, and Riccardo, thank you again. I would love to have you present again for us, sir, in the future.
Yeah, sure. No worries. All right. Thanks a lot, guys. Ciao.
What do you got there, Bernie?
So this is some monoatomic, and can you see that there's a little bit of video wave interference coming up on my camera around this?
Oh yeah, a little bit.
Yeah, I've recorded this on all of these plasmoid monoatomic structured elements.
So it's oscillating?
It will have that, yes, exactly. Depending on the light that you have around it and the video equipment, it will range in wave or strength of interference. But this is a combination of monoatomic zinc, silver, and copper. I've made together there. It's the pure white fluffy stuff. I've been talking with Jeremiah as well as Esoteric Gold here in the past couple of days in regards to how they've made their monoatomic metals through the chemical treatment way of it. And then mine is completely different, where I'm only using a small voltage of electricity in salt water, and then the pure elements themselves as cathodes and anodes to then make and turn into this pure white single atom plasma state, and I essentially predict that it's the quantum matter because it is this single atom plasma state matter that we are making. And it's that I learned from Isaac Newton's alchemy writings that he states that all elements can be broken down into this single white fluffy monoatomic, what he calls mercurial white state of metals. And I've turned.
So when you say mercurial, it's liquid?
He says mercurial. I believe it's molecular. It's just old English, like language differential.
Mercurial.
Yeah.
Mercurial. That means metal that's liquid. It's a liquid metal. That's what he's talking about.
Yeah, but he's saying it's in this single white state that they come down to.
Yeah, it's white because
it's this single atom, right?
Metals are shiny because they have free electrons. That's what makes them shine.
So the thing that makes this stuff so special,
it's not free. It's in a plasma. Right?
So this stuff I've been able to turn copper, aluminum, iron, nickel, gold, silver, bismuth, and I believe a couple more, all into this single white particle stuff through the electrolysis process. And that as soon as they turn blue or green, that's when it's oxidizing and it's particulating and it's forming that bond with another atom, thus no longer that single monoatomic plasma state. And it's that this ionized gas, right? Your noble gases in their plasma state, it's a single atom, but it's super charged, right? It's ionized. So that's what essentially these monoatomics are, is it's the noble metal elements in their single plasma atom state. And with Keshe's research, when they rotate these metals at 4,000 or higher RPM, it starts emitting measurable and usable plasma fields that you can read and register throughout the air with the electromagnetic fields they create.
Yeah, it'd be cool to X-ray that, see what the atomic structure looks like.
Yeah, so I have lots of these different samples and I can make them out of specific metals where I'm using 24 karat gold, both anode, cathode, same like 99.9 silver when making them, so that I would love to produce controlled specimens to send to the proper lab. Does Mark, do you have the equipment there to test it? Or what would I be using? Because it is this monoatomic state the David Hudson stuff talks about essentially.
We do not have a mass spectrometer, and that's the equipment I would suggest using.
I was talking to John Hutchinson about it last night, and he was saying it was some sort of microscope something.
I can help you out with that, Bernard. You can use your cell phone as a mass spectrometer if you do right like adjustments to like let's see, dang it, the accelerometer or accelerometer. I can't remember the name of it, but
accelerometer. That's
thank
like
you.
measures motion.
Yeah. Like if you can train that to detect the motion within the air as the vibration, pressure mediations, and I guess hold the phone close to the monoatomics, whatever, you can detect the different rate changes and all that. Maybe just going off by that, you can see if the, anything has been, detected and all that. So like you would have to cross, reference things of how mass spectrometry is, measure stuff with, the accelerometer, rate changes and how that correlates. But I'm just throwing that out there. That's what I've been experimenting with right now and reading. So how to use, novel devices and not needing, better methods for bigger equipment. Sorry, just want to throw that out there.
I'm just pinging Mark in the other line here. I want to see if Mark is almost ready for his experiment. Looks like his thing has quit swinging.
Sorry, I was muted there. But what I'm showing is the pure gold layer, and it's a crystallized, I believe, single atom, but nano layer of crystal gold that forms in part of this electrolysis process. And it falls off as straight sheets of this single layered gold flake. And that this would be the sort of things that you'd want to layer your whatever Charlie's working on, and that was just talked about, presented on the spinning discs there, is that you'd be wanting to put these nano layers covering of the different discs, and then some of these monoatomic metals either layering them or in the center of them rotating.
So I found a lab that could do that, what you're looking for, Bertie.
Awesome. If you post the link in the chat, I will copy.
Yeah,
and
it's the National Institute of Standards and Technologies. That's where you send your samples to get them. If you're gonna, like, they'll sell you standards for like your atomic force microscope or your electron microscope. You know what I mean? By a standard.
Gotcha. And is that applicable for me in Canada, or is that just an American thing?
It's it depends on what kind of money you have. I think you need US dollars for this.
Alrighty, so
the government respects money.
I'd probably go back to my local university first and approach them and see if I could use their equipment, I'm guessing then.
Well, no, what you do is you find out what their equipment is from NIST, and then you find someone in Canada that can do it for less. So I posted the link here in the chat.
There's Mark. Mark!
No.
Sorry, Mike, do you want to go into more if it's still open discussion, like talking about how you've done your M machine build, your Don Smith spark gap generators, your pulse mode?
Bernie, we have like two or 3 minutes until it warms up, so go ahead.
Okay, so Mark, when you take over to your presentation, can I make you the host for open discussion after that? Okay.
Yeah, sure.
Oh, shit!
Okay.
I put it. I didn't put it to everyone. The link. Sorry, Bertie.
No worries. And Mike,
Okay, there it is. Now it's there.
What was that, Bernie?
Oh, I was sharing a link. He was looking for
I'm forgetting the metals test, but Mike, if you want to talk a bit about how you're connecting your Don Smith generator into the different transistors and then into the pulse motor, and then you're making a flywheel build as well into it.
I don't know. I'm confused. That's not my project that I'm aware
No,
of.
that's Faraday.
Well,
I think he's muted.
Yeah. No, I'm here. Yeah, I did an interesting experiment about a year ago. I made a miniature version of the end machine, and if anybody knows how it works, I took two, those fishing magnets, really powerful N52 magnets, 3-inch diameter, and I spun them at about 4,000 RPM, and I noticed an interesting anomaly when I hit the shaft of the end machine with high voltage. The machine started to trail across the table. And I thought at first it was the vibration from the end machine itself, because of, it's not properly balanced. But it didn't do that as soon as I shut it off. The second I hit it with the high voltage, I was hitting it with about 6 kVA at about 42 kilohertz. it started to trail across the table. It started to vibrate, and then it started to trail across the table.
Is it jumping?
That's what I thought at first, but the second I stopped putting the voltage on it, it stopped. It just basically sat there and spun. So the second I put the high voltage to it, it started to trail across the table. I actually had to hold it back.
So if you
So-
kept it at a high voltage and you adjusted the frequency, did that change anything?
Well, I didn't actually have a frequency control with the high voltage modulator that I had. So that would be an interesting experiment to actually, if I was able to actually
You
tune
could
the
tune it
frequency.
in and then it goes flying across the table.
Well, I literally had to hold it. It was trailing across the table. I had to hold it. And the second I shut the power off on it, it settled down and it rested firmly on the table. Now this apparatus weighed about 20 pounds.
Was the whole apparatus vibrating?
I had everything. I had the power unit. I had everything on basically not a masonite board, MDF fiber board, and I had the whole apparatus fixed to that apparatus, to the board. And then as soon as I flipped the high voltage on, the whole thing just started
The
trailing across the
board
table.
that it was sitting on moved too?
Yes.
So the whole thing, the whole assembly was vibrating at the
Yeah.
same frequency, correct?
Yeah. Yes.
And so what was it, and you couldn't adjust that vibrational frequency?
No, because that high voltage generator I had was a fixed frequency. I wasn't able to vary. The only way I could vary the frequency is if I start playing with the voltage input and output. That was the only way I could maybe alterate it. But the higher the voltage went, the faster it wanted to push across the table.
Huh.
Now, originally I thought it was vibration.
5 kV, you say?
6 kVA.
Because if you had a bipolar amplifier, you could do it.
Yeah, if I could.
You know what I mean? You could pulse it. You could pulse it and then create a on-off state at a fixed frequency.
Yeah, I just never really pursued it because I was more into the energy stuff. But
Yeah, but you
know,
said it
was,
stopped when you turned the power off, right?
That's right. Yeah.
So what I'm saying is you turn it on and then you turn it off, and you have a duty cycle essentially. Create a duty cycle on off, and then you increase the duty cycle until you get a 50% duty cycle. Then it's a perfect square wave, right?
Right.
And then you can basically you can adjust the frequency.
Right. See, originally this is not what I was looking for. This was just an anomaly that popped up that I found kind of weird because, you know, like I said,
Well, don't stick on DC. AC is where your money is. Look at that's what Tesla did.
Right. Well, exactly. You know, it's pulsating at 43 kilohertz, so it is technically like a pulse DC, right? So, I can't explain it. It was very strange. I wasn't originally looking for that anomaly, but it just happened, you know, basically by accident. So.
Serendipity. I think we're all familiar with that person. Serendipity.
But, see, it kind of it was
Guys,
weird.
we're just about ready here.
I'll just
Okay, we're just going to start by turning on the magnetic field.
Do we got Mark getting ready to fire this puppy up?
Yep, it looks like he is just about there.
Oh, I got a quick question that you guys brought up. What do you guys know about plasma rectifiers from old world, like 1900 technology that they used for switching DC to AC or AC to DC in the old system?
Are you talking like tubes?
Yeah, it was plasma.
That's thermionic emission. Yeah.
Yeah, but it was just, they were everywhere. You can look at these old pictures of the electric cars from 100 years ago, and there's these giant glass tubes with these plasma mercury at the bottom, and they're called mercury rectifiers, and they state that it was used for transferring DC to AC.
Probably just outmoded by.
They used them in
but they would never burn out.
Old black and
because it
white
would
TV.
replenish itself as the mercury was in it, creating
old black and white TVs. That's where they use that kind of stuff. The old black and white TVs had that kind of fly back.
Okay, guys, we're rock solid with the measurement here at 32.0231 grams. So the magnetic field is turned on. Haven't seen any change in weight. We're going to turn the RF on. 3, 2, 1. I'll change the frequency a little bit so I get less reflected power. Checking it over pulse. Not seeing any change in weight there, which is slowly shift through the magnetic field, raise the power a little bit.
You're getting change there. Increase, increase. Oh, big, it just jumped.
Oh, there was a bit of a decrease. Oh, look at that.
Yeah, you just lost like 8 microgram.
No, it's dropping. It's dropping more.
Yeah.
Oh, now it's coming back. Maybe a truck drove by. No, I don't think a truck drove by.
I can see it moving a little bit.
Okay, we're at 9.2326 gigahertz right now. That would be a one more frequency of calculator real fast. That's 9.2326 divided by 28.025. So the one more frequency for that would be 3294.4 Gauss. So we're a little bit too strong on the Gauss right now. Magnetic field is too strong for this. I have to drop it. Somewhere around here it should happen. Sometimes these experiments can be as exciting as watching grass grow. Slowly going through the range of frequent of magnetic field strengths. Just call out when there's a big change. Yeah. Definitely reduce the noise by waiting that half hour. I'm slowly shifting the strength of the magnetic field 0.1 Gauss at a time.
Okay. How are you doing, Mark? It looks like it's still decreasing.
Oh, there was a big drop there. Oh my God, yeah, it's dropping now. Go back up a bit. Yeah.
So, and you've explained in detail what you're doing, right?
I think I have. I mean, I explained it quite a few times on the conference.
I was going to say, well, now that you have the results running, I mean, it's probably worth running through it again, you know, because it looks like you're having some kind of a breakthrough here, man.
I don't know. These are numbers in grams, so you're looking at 4 points past the decimal point on a gram. That's a 10,000th of a gram.
Yeah, but it's still a positive result. I mean,
That's definitely moving. Yep. We had it rock solid before. We waited half an hour. It was rock solid when it started. I want to find that sweet spot where we'll lose a full gram. Then we'll get excited. Mom, can you call out the negative, positive? It's just slowly going
okay.
down.
Well, Mark, I'd like to make you the host of the conference if you're open to it, or do you want me to wait for a couple of minutes?
Why don't you wait for a couple of minutes because I'm not next to the computer.
Okay, yeah, that's what I was waiting for.
Slowly going down. Oh no, that was significant. 84 to 77. Or more significant.
I'm not really hearing any audio, Mark.
Could
Oh,
be,
okay. You're just being quiet, that's all.
yeah, be quiet, and the hum of the equipment is probably drowned out or cut off by the Zoom. Just turn off the magnetic field altogether. If that does anything. Magnetic field is pretty much gone right now. RF off. RF field is off. I don't think we're seeing much this time around. We got the RF off right now, magnetic field off. We have to pump up the power a little bit. Kind of a little higher power level.
This is much better than grass growing. This is rivals up there on the level of like watching paint dry.
Yeah, pretty much what it is. Much easier to watch it when it's in fast forward.
Oh, absolutely. So yeah.
Sometimes you see stuff that you don't see in the live stream when you're doing it in fast forward too. Sometimes
That's true. Yeah.
I'm going to spotlight Mark because that way you guys can talk and it won't disappear.
Oh yeah, I actually have two windows open right now, one on each screen. I just put everybody in the gallery on one window and then have him focused on the other one so I can really zoom in and see what's going on. It's too bad he doesn't have more gauging that he could basically throw up on the screen too, so you can see what else is changing while these slight fluctuations in the gram rate weighting is changing. Like any frequency changes, any fluctuations in like the amount of power going in and whatnot.
Change the pulse frequency. So we have several things going on here. We have the RF, which is the pulse. The signal generator here for pulses is on a sweep mode between 80 and 160 hertz. Actually, between 60 and 160 hertz. It's sweeping every 2 minutes. We're right about where our more precession should be happening. I notice that when I'm off the frequency band, the weight is pretty steady. When you start getting close to that or more precession, that's when the weight, we're seeing the larger fluctuations in weight. But these are 10,000ths of a gram. They're not major.
See if I can pull this, give you guys a better view of what's going on here.
It looks like you're graduated all the way down to 10,000ths of a gram. So 2-digit movements is 1,000th of a gram.
Yeah, so this is that's a signal spectrum analyzer over there showing us the pulsing RF frequency. Those blue lights over there, that's the forward and reverse power. So we basically our SWR meter. Tells us how much reflected energy we have coming in. Radiation detector, RF spectrum strength detector. This is a signal generator, RF amplifier, and this is a signal generator that is low frequency that's controlling the pulses of this signal generator. It's at 9.24 gigahertz. Down there is the magnetic, the electromagnet power supply. We hooked up 3 extra pots. I think they're 10-turn pots to control the current. And on the wall in the back over there is a Gauss meter connected directly to the electromagnet. Right now it's at 3271.3 Gauss. So it should be right around the magnetic field strength necessary for a little more precision.
So I think I recognize that signal generator. Pretty sure I got one on my shelf in the back there.
Have the same model?
Oh, let me look and see, man. Yeah, looks like it's probably on the back side of it. Got it buried underneath 2 oscilloscopes, so. I guess I don't have a model number on this thing anywhere. It just says 200 ms a dash or // 12 bit. There was the one I've got is something cheap, marked as a K-Moon brand. I tested it on the good oscilloscope though, and it's pretty accurate on its frequency output whenever you adjust it. So.
What was that for? 1014. Oh, okay. Well, we shut everything down pretty much. You guys got a little view of what it's like to run these experiments. We normally run them for about an hour, shifting all of the parameters and all different variations. It's about as exciting as watching grass grow.
Do you have an XRF there?
That's Expand RF, yeah.
No, I mean, do you have an XRF like spectrometer for, poking at things to see, it basically gives you readouts of what material you've got. So if you have a table, you're not sure what all might be laying on it, you hit it with that and it would be able to tell you what, not only what's on there, but what percentages of it, like uranium and gold and all kinds of stuff like that. And if you're working with the material, you know what it is and be able to poke at it while you're basically attacking it. You may see some potentials for using for transmutation for materials that we do need, that this would maybe open a window to. I know they're expensive. That's why I was thinking we need to see if we can't get you guys one.
That would be a great piece of equipment to have, because we need to look at this from a lot of perspectives. I also want to get some maybe slightly radioactive materials, see if we can use this technology to lower radiation levels.
It'd be pretty ridiculous if you were doing something trying to develop anti-gravity and stumbled upon the secret to really making cold fusion work.
Well,
I heard.
So Mark, I want to make you the host now, if you're okay with that.
Go for it.
Okay, good deal.
Can't wait to bounce, huh?
No, I gotta make dinner for the gang. So.
Uh-oh.
Yeah. Okay. So let me find. Yeah, I will be back probably about an hour or so.
Yeah, don't want to, next time we see you see chunks missing from you because the zombie horde attacked you instead of the food you made.
Okay. Mark, I heard Shugnite, I think the mineral, SHUGNITE. Like
Jeremy, can you turn on your camera? I'm just asking everyone who speaks to turn on the camera.
Oh, okay. Well, no one mentioned anything, so you.
Yep, we can see your hands.
Okay. Yeah, but I heard Shugnite mineral supposedly like reduces like excess radiation.
I think he can turn off his camera.
Well, I mean, right now I'm in a dark room because like it's easier on my eyes. So, you know.
No, I can't.
No, we can't see you either way, but
That's cool.
Shugnite, not familiar with that material.
Better to just give us a proton count on whatever it is this element is the elements it's supposed to be composed of.
So we got over here. This was based off of Aidan Schaefer's recommendation. He said I should get some magnesium orthosilicate, which is otherwise known as ferresterite, powdered. So I got some of these magnesium orthosilicate samples. They came from Afghanistan or Pakistan, whatever. And I took one, we crushed it up, ran it through the mill, and we ended up with this powder over here, magnesium orthosilicate. Of course, this is like this is a compound similar to ruby that's made out of aluminum. This is made out of magnesium, which is also a good retainer of dynamic nuclear orientation. So we were going to try some experiments using the magnesium orthosilicate powder as well. And this is also used in cosmetics. Me and Tom got some really nasty headaches when we were making it. So I don't know. I don't know if it was from the powder or from something else.
I got a question for you.
Yeah.
Going back to something you were talking about earlier. You said you were seeing a diamagnetic response from that aluminum, but you quoted it as being the property of aluminum. Are you saying that it changed this property? Because aluminum is marked as being paramagnetic at room temperature under normal circumstances.
I may have misspoke. What I was referring to is the aluminum.
No, it's the monoatomic aluminum.
Aluminum's capacity to retain dynamic nuclear orientation for an extended period of time. And by extended period of time, we're talking milliseconds at room temperature.
Right. Yeah. On that scale, that would be basically a pretty decent amount of time compared to what we think of whenever humans.
Aluminum and magnesium are supposedly from the best materials for retaining dynamic nuclear orientation at room temperature.
And
as they got colder, they work better.
Right? Sorry, I just had to ask. Shugnite, not Death Row Records.
Well, I say you were using something that was within a magnetic field, so diamagnetic and paramagnetic would matter, since diamagnetic is a reflexive or a mirror-like effect of a magnetic field, whereas paramagnetic is more like a lens, a focusing agent. Doesn't create any of its own magnetic field, but it can focus one being affected onto it, unlike ferromagnetic material that can be oriented to generate its own magnetic field. So
basically trapping the waves so that there's no loss in signal gain, right? So you using different
Thomas Anderson, I may say I believe aluminum is both diamagnetic and paramagnetic, although the paramagnetism is much more powerful than the diamagnetism in it.
Well, it seems like almost all materials can exhibit any magnetic property. It's dependent on different functions like temperature range. If you raise the temperature of a neodymium magnet, it'll exhibit like a loss of its ferromagnetic properties. Then you end up losing it. So yeah,
that's called the Curie.
And that's right. And that's just one property to change. I mean, if you're changing properties using microwaves and whatnot, you may see something change from paramagnetic to diamagnetic that normally requires negative sub 100 degrees below zero temperatures happening in room temperature. So
also if you make materials bring them up to a high enough positive charge where you strip their electrons from them, you can have copper that is as resistant as Niconol wire, where it just becomes a resistor because it's got no electrons left. Wow. So positively charged. It's possible.
So basically turning copper into plasma.
Well, plasma is actually very conductive, but you're
right. And plasma though is when you've separated all the electrons away and pushed them to a different region, so you have a bunch of cores.
Well, in plasma, the electrons aren't necessarily gone, but they're not bound to any one atom. So,
right. Well, that's what I'm saying. Yeah, you push them further away from the core than would normally be able to maintain
Right.
an
So
orbital
many plasmas actually are very near superconducting.
Right. That's why I was thinking that you can get like hundreds of thousands of watts worth of power through a tiny thin little wire by simply running it through it, like say 40,000 volts, because you're running next to no amperage, but you're still transmitting the work potential from one end to the other. Whereas you lose all that energy if you run at a much lower voltage, trying to jam all those amps through. I'm wondering if that isn't because the higher voltage is causing an orientation where all the atoms are lining up. So therefore, when you jam electricity in on one end, it's popping out the other end instantly instead of some of the energy being lost to, disoriented atoms, the electron fields on the atoms. So
I always thought the amperage was the resistance. Is that correct? I'm kind of a
no, the
novice
amperage is the quantity of electrons being jammed through, and the voltage, from what I understand, is the speed and pressure at which you're jamming those electrons through.
Okay,
So,
okay. So voltage is the signal gain, right? Like that's the safe part you can touch. Kind of like
Right.
so it's like cold plasma is the
Oh.
voltage, right?
cold plasma is just basically atoms that have been cooled down after you strip their electrons free.
Okay, and that would be in the electrons.
They
free would
still have a very, well, I was gonna say they still have a very high affinity to stripping electrons off of anything they come into contact with, so you can use them for like basically cold burning through material, like a plasma cutter that doesn't produce much heat, but it can still rip the atoms off of whatever it is you're blasting it with, because they're sharing electrons with the the atoms that you're slamming into, since they don't have any and they need them to finish balancing back out. So
Yeah, I mean, because I've heard when I was reading about, I thought only like X-rays and gamma rays were strong enough to bump off electrons off like DNA to cause cancer, and they said that anything else would just be a heating up, anything below that. But it's not true. Like certain lower frequencies can be strong enough in energy to bump off electrons. So, right? If that's my assumption's correct, right?
I'm not sure. I know there's probably a lot of confusion too when people are talking about cancer and plasma, because you've got plasma state of a matter, and then you've got plasma as in like the material that blood cells are carried through. So if someone makes this simple confusion of those two while they're trying to explain something, somebody else could end up with completely the wrong idea of what they're trying to say.
Yes. Well, I study bio stuff, so like I'm getting to where I can like learn how to use a cell phone to like monitor all the body's vital signals. And I mean, I got several experiments I'm running, but I'm getting a lot of data material from like PubMed and it's NHBI or NHBL.com, whatever, .gov or whatever it is, just like, and just trying to figure out like how I can use this the signal analysis where like the oscilloscope waves are, where it's going up and down, and then like it would have all the other frequencies like overlap the one of the signals, because you got like your waveguides when you have like Berlin cells that would monitor the spherical model of reflections, but I don't know if that's very accurate or exact enough to like measure as much as the one with where it's just like an oscilloscope type layout, where the signals overlap. Like that one's more accurate than I'm talking about math now, but all I'm saying is that I'm trying to use the cell phone to do that, as regular signals analysis, because I found articles that they just now recently said that they're experimenting with stuff that's beyond the bandwidth limit of the device or whatever, like they're trying to predict how they can get all the information of signals, past that, and like predict, correctly if they got it exact or not. Like the applications of that would be just phenomenal. Like it sounds like they're doing it right. And like there's a guy that the Raymond Royal Rife scope, he supposedly had grinded the crystals to certain length to where he would say like he'd take the reference beam and the evidence beam that hits the object, and then he would cross phase those, and the exact, like, I guess, opposite phase of the evidence beam, which is the reference beam, and they would even out, any loss in the wave interference, correctly, and then he would extend the resolution past the bandwidth limit, that he sent the evidence signal to go any further, so that's why he was able to, like, scan the actual living plasma from, we're talking bioplasma or whatever, like, the glowing part of the cell or whatever, instead of it just being dead material, when he was using, like regular electron microscopes do, so they only see like dead material or material that's, like looking at a rock. But with his method, he was able to see stuff that was glowing. So, I'm just giving like a layman terminology. So, but that's what I'm kind of theoretically trying to do with like the cell phone, or other novel methods, without using like big atomic interferometers or mass spectrometry equipment and stuff. So just cost effective. And some people have been experimenting with the cell phone, as a measuring device for stuff like this. There's articles I managed to get. So, but I'm not trying to hog the thing or anything. I'm just letting you know all the projects I've been working on. So
hey, Jeremy, there's an app that you can download to make your cell phone into a radiation detector.
Oh, that's cool. Like a Geiger counter?
Like, well, it's like a Geiger counter, but it's not a Geiger counter. And then
did it measure the thermal radiation that gives off, like the temperature, wavelengths?
No,
I think he's talking about EMF radiation.
No, I'm talking about betas. It basically, it just not betas, it's gammas and beta.
Gamma and beta decay, right? Like a pressure mediation.
Well, like if you had an old CRT TV, you could put your cell phone with this app up to it and measure beta radiation.
That's pretty cool. I'm thinking that's the Raman spectra, but like
now most of the radiation that you would be detecting will be the gamma sort, which is photons. They're just
now that's cool. That would go hand in hand with my experiment. I've been working with the mandalas.
So now the other thing I was going to tell you is Android operating systems, unlike Apple. Apple, if you want to do an app, you got to pay $100 to get a license. But for the like Android or Samsung type stuff, it's all open source, so you can write your own apps, and there's a lot of software tools on there that are real easy. They're like visual, and so I did an app. I took a class at Cabrillo College, and I used to write software at the beginning of time. Key punch cards. That's what I learned on. But
that's where it's at, man. Like I still think that that's viable today because of the. We'll get back on topic though, but I think.
Yeah, but what I'm saying though is that you can do your own apps, and it's not that hard. I did one where I took my actual Geiger counter, and it has a audio jack to listen for the click clicks. And I plugged it into the audio jack for my cell phone and wrote a little FFT function that like counted up all the counts. And I ate that class because I was the only one in the class that could interface my cell phone to some other measurement device. Because that's how I learned to do it. It was like taking my old 286 computer and hooking it up to my oscilloscope, that kind of stuff. So, but you can do all that, and there's a lot of stuff online. Just look for the apps.
Michael, that's very fascinating and relevant info, actually, and you're reminding me kind of what Hutchinson was talking about a couple weeks back, and how they were measuring atoms' sound frequencies through reverse engineering to speakers, and what you're talking, connecting it through that app, I'm thinking would exponentially give their results and their method way more efficiency and resonant frequency measuring of atomic masses and resonant frequencies through sound frequency.
Yeah,
Sound is what I mean, when you tap on the table, it's creating sound. It's like light, but it behaves differently.
you're trying to like scale the curve gradient that's evenly through all the wave interferences that are going basically, and, so it doesn't jam. But it's like, trying to fit a large wave through the small wave, and that's kind of problematic. That's how I visualize it.
Well, that's what you're doing when you're creating a harmonic, is you're fitting the small wave in the large wave.
Yeah. My experiment, well, not my experiment, but this person, like I said, Nikki Saraswati, Saraswati, that person was experimenting with mandalas to see that it had made chemical changes by the photoelectric effect on objects as far as like ethanol or crystals, like quartz, and as far as like other objects is, I guess, metals that change in oxides and stuff, and then as well as what was another one that the person did? Crap, my mind goes blank. But beverages like coffee and stuff, see if it changed. But the person was using a chromatography to see the rate and change of syllables. So, and I was looking up chromatography, what it was, because this is something new I'm just looking into. And apparently you have like your stationary phase and your mobile phase, and your mobile phase detects the rates of change in the solubility, of the solvents, of the whatever your object you're using. So, but they detected ethanol changes in the percentage. I forget how they did it, but they were the mass. They measured the mass of it, and like it decreased by like 2.88%. And apparently that the mandala picture did affect it. So, and they're claiming that they took the oscilloscope and they were detecting gamma radiation coming off of this mandala picture. So,
that's interesting.
Yeah, I got the book, but it's in French. But I'm gonna start testing it. And they said that the person took I think it was a blue topaz crystal, and they left it on one of the mandalas. Supposedly it changed color in the next hour or so to white topaz.
Wow.
So I'm gonna check out, see further about that. The person did not supposedly want to give the information out to mainstream because of whatever deals, but I'm gonna experiment with this myself. They say that these mandala pictures at the Temple of Borobudur in India have some significance with some of the structures, because they said that these things would supposedly resonate with other parts of the buildings, and all those buildings in the cells do kind of have a resonant quality to them. So there might be something to it. I know that's very out there, but
Oh, you got to experiment. Failure's not an option. It's a learning experience.
Oh yeah, definitely. And this.
Oh, hey Bernie, I sent you that email that I asked you for your email. I sent you an email. Pardon me.
Thank you, my friend. Appreciate it.
Yeah. Oh, go ahead.
No, you go ahead.
Yeah, the Shugnite. I got that from Dan Winter. So like, I'm a big.
Oh, I know Dan Winter.
Yeah, Dan Winter. It's exactly what he's explaining is what everyone's looking for. As far as the wave interferometer.
Here's some
Perfect
good
resonance.
info with the monoatomics and plasmoids and stuff.
Yeah, he knows all about that. He's a good source for that. I agree.
And his fractal geometry is another really, really good one with the phi ratio and whatnot.
Yeah, I was trying to see if there's much relevance to it. I mean, it's buying me into it, but I want to test it. You know,
that's it. Test it. If you can't reproduce it regularly, nobody's gonna give it much credence.
No.
That the Shung, I think it's Shungite from Shunga in Russia, or Shunga, or whatever you say.
Shungite,
Yeah, that's how I learned it in my geology class. That's why I was laughing. I was like,
he said it.
Oh my goodness, LA.
It negated radiation of some sort.
Yeah, it's supposed to filter out EMF. For a while, they were selling little tiny things that you would like put in your wallet and stuff. I remember this is like way back. This is like in the 80s.
Oh yeah. Yeah, definitely. I mean, shoot. But
it was
that's
like
interesting.
EMF stuff, and there is a real problem with electromagnetic fields. We have what's called electrosmog. If you live in cities where there's all these Wi-Fi, you go to hook up to Wi-Fi and there's 20,000 Wi-Fis.
Yeah, I know.
That's what they call electrosmog. It's a type of smog.
And it's regulating your DNA and everything.
It's bad for cells. I mean, it's like your microwave oven is what, 2.6 gigahertz. It cooks water fine.
Yeah, definitely.
So long-term exposure to low levels of this kind of radiation is harmful to biological systems.
Oh,
and there's
definitely.
some people that are very sensitive to it that get sick.
Yeah.
And they have to go live where the radio telescopes are, because that's the only place that's safe for them to live, because where the radio telescopes are, they can't have any EMF.
Yeah, it's like a calm for them, where everywhere else, it's like the static is like screaming noise to them.
Oh yeah, they
crushing migraines, all sorts of stuff.
Harmful to them. I know people that have actually died from this shit. So.
Oh yeah. Hey, well, I got something that I could share with you, Bernard. I'm trying to look it up. This guy, he made gold darn it, copper turned to silver and silver turned to gold, like the nanoparticle.
Oh yeah, that's Bernie. He's the alchemist.
I believe that I've actually produced some of those results myself, but they transmuted back in after about 3 months of being sealed within the reactions, and that through Isaac Newton's writings and my own upcoming theory that I will release of how to do it on a more stable level, but it's cold fusion through electrolysis and merging of ancient alchemy, and it's very advanced. Isaac Newton's descriptions, I highly recommend people give them a reading, because it's the missing connection of his light, color, sound, relativity to the other aspects of it, and that this electrolysis, alchemy, electric chemistry is this missing cold fusion of nature sort of energy and technology.
There's this guy that was rubbing the silver onto the I think it was silver onto object, but he used to experiment with photon resonance, and he said that he made the nano particulates of the silver turn to gold. I have this PDF. It actually explains like all the hertz, / centimeters.
Oh, definitely, if you can post the PDF in the chat right now.
Yeah, you might want to check that out. I got a YouTube channel of his. I'm trying to figure this out. Hold on a second.
For sure.
I think it's kind of cool that Newton, this guy who he basically came up with calculus, which I hated.
Well,
And he was an alchemist, you know?
yeah. Well, I'm
It's
against
like,
that.
who would ever have thought that this is like the founder of modern science?
Right? These million words of writing and his science work just weren't released to anybody or the public for how many hundreds of years to his death, and they only came public 2 or 3 years ago where they started getting the translations finally.
Yeah, I actually have access to that. I don't remember where it's unpublished, stuff, but I think everybody can get it. Trying to figure out how to post a PDF in this.
Just in the chat on the side there. I'm just gonna give you guys a quick little brief nonsense demo. See where like this one where it's got the gold nanoplated on the side, or where the gold is turned can't really see it, but it's a purple in this one.
There we go.
Or more also gold on top and then a little purple on the bottom.
Yeah, okay, I can see that.
And then so this one where it's the blue or the green where it's oxidized. What the red, which could be a mercury oxide, but that'd be mass transmutation if this is mercury, because it was made, this one specifically, out of copper. But it's that when any of these monoatomics go from the pure white single atom, when it's in that plasma state, that is where you're able to get the health effects from it or the superconductive effects of it. But as soon as you just add that one oxygen to it, where it's now bonded with another particle, that's where you're instantly going to start accumulating your heavy metal toxic poisoning. And it's because it's not a single little plasma element that can go through and resonate with your cells. Instead, it's now this particle solid that's tearing into, getting stuck, and then damaging.
So I got a question for you, Bernie. Does that mean that this is a process that you could use to, say, decontaminate sites? For example, like where there's heavy metal
100%, Boyd. I don't know if you've looked into Keshe Foundation's work, but over the last 10 years, they've done, and they were doing some research in Japan and had some success with Fukushima directly, where there's an offshoot company created.
They're taking radioisotopes and decontaminating them, right?
Yeah. And then I believe Hutchinson was also mentioning something.
Oh yeah, that's right. He did talk about that.
Yeah.
That's a good point. Yeah, that's really cool. That's really cool.
So, but yeah, the main points though being, it's like, even if it's just like the solid, like single atom, but it's gold, you don't want any material matter whatsoever that is other than the straight white, because as soon as you get it oxidized or any other particle, that's where you instantly start getting negative effects instead of the positive health effects, and will very quickly, very shortly, even absorb these oxide, so the copper oxide dust or the gold oxide dust or whatnot, that's like the blue-green out of it, that's then going into your body and then accumulating in mass on that heavy metal poisoning side of it, as opposed to if it's just a
how do you oxidize gold, Bernie?
It adds up to it.
How do you oxidize gold?
So all of these elements, and I'll show you one jar where it is just gold on gold, but it's that I'm using in the electrolysis both the same metals on the cathode and the anodes when I'm making the specific pure monoatomics of those elements, and that if you create it in a stable amount, it will always forever stay in this white pure. Or if for any reason you change like a frequency of electric or just
a contaminant will cause it to change.
Anything, then it starts to oxidize on its own, turn to the green, blue, or it'll start turning to the red.
Do you have any any of your samples with oxidation for gold?
Yeah, yes, I do. I've got several where the gold's directly gone from the white to the blue gold.
Wow. Wow, that's cool stuff.
Actually,
Thanks for sharing.
Yeah, no worries, my friend.
Bernie, on theory in transmutation, could quantum tunneling be a factor in how this works? Because if so, say in the electrolysis experiments, this would seem to be a case of a unified field theory, right? Where because quantum tunneling is about the gravitational kind of architecture of space-time, even on a small scale, versus the electromagnetic theory of electrolysis. Do you see this in your analysis?
Yeah,
Or
what
how do
you're
we get
saying definitely would make sense in like a major part of connecting it on the higher dimensional dynamic bridge of the interworkings of it and connecting it to the multiverse for sure. It is the gap that you get that resonant frequency of that element down to that vibrational or resonating harmonic just energy or frequency. Then you're able from that point to do exactly what you just said, and it takes just the smallest amount of energy to shift a whole bunch of that matter. Then, for instance, when I have some of the stuff that is like in the pure monoatomic, and I'll cut off the anode side of it and cut off the red wire going into it, simultaneously all of the white monoatomic instantly turns yellow into what the alchemists say is their sulfur oxide or something like that. But it's that it's resonating on that all that plasma matter or whatnot that would be neutral simultaneously with just the smallest little tiniest change of energy can have that huge effect of it. And that would be some sort of quantum tunneling like you're talking about for sure.
It's almost like a chain reaction. You know what I mean?
Absolutely. And it's that what's fascinated me is how many different times and how many different types of reactions have happened with no chemical reaction change at all. And it'll just be like the slightest either temperature or just voltage or reversal of the electrical feed or something like that, that will then have these mass effects on the overall dynamic system. I've got lots of pictures of it, but I'll put together, maybe Micah, if we could talk sometime and you could help me go through lots of my photographic evidence of my experiments, help me put together a presentation for it.
That would be cool.
One of my other experiments I'm going to try is with using my cell phone. I found a video how to turn my camera sensor into a nano measurement size detector that can detect like brain oscillation or fluctuations, like as far as like the neurosynapse firings and stuff. And I forget the name of it, but it was like optogenetic modulation or photobiomodulation. But I can use the camera sensor to actually modulate the brain frequencies without needing an EEG cap or any connector source, and it will even despite the temperature.
How does that do that with the RF radiation?
Yes, but like it could even detect more than just the RF radiation. Like it would detect like the light, like fiber optic cables, how the light transfers, through at that I guess at the nano measurement. So, photonics, goes at the nanometer, right? So, or close to it.
Protons are a million times smaller than a nanometer.
Oh, okay.
They're femtometers. Femtos 10 to the minus 15.
Attoseconds to femtos.
Nano is 10 to the minus 9.
Okay.
So you could fit
it
a
said that-
whole lot of protons in a nanometer.
Okay. Well, they said that this camera sensor, that the way they did it in this video, you can use to detect all the oscillations and all the, like it could do what an EEG cap can do and an MRI and everything can do, but better with just using your cell phone sensor. And he showed the lady showed it. It's like it was a new thing they did last year. I have the video. I have to
I
look
hope it
for
wasn't that lady that got busted for fraud. You probably read about that,
Making Anna on Netflix.
I probably don't know what you're referring to.
I hope you didn't invest in it, sir.
No. This
Theranos, right? The scheme to diagnose most diseases from just one small blood sample.
Yeah, that's the one.
Now this would be a dream come true for technology, and the promise may have been deliverable on the genetic analysis front. If you think about it, you could amplify a small sample of blood, but the pathogens present in the
John,
blood.
you're so onto it, and that's actually a next level aspect that I'll be showing in my presentation, and it's that when you add a small amount of your own plasma into these electrolysis reactions when making the monoatomic gold and silver, that it simultaneously starts reproducing your own amino acids on the anode side, bubbling up. No matter where you put your hair, your skin, your blood, your mucus into the reaction, it simultaneously puts up this huge amount of bubbling up of your own amino acids DNA that it's reproducing.
But what if I don't want your DNA?
But you only want it on your own, right? And then that's exactly it. Is it's giving you these single atoms or these single nanoparticles that are your specific RNA or RNA, DNA.
I could think of a way you could make a cryptocurrency.
But that is your nanoparticle. That is your plasma resonant frequency on a single atom scale. That if you're then able to tie into these plasma metals that are then vibrating on your atomic level, that then that energy should be able to be transferred over to your cells in your body, and theoretically how this colloidal silver, colloidal gold, monoatomic gold would work in the body's system.
Goldfinger.
But there's a thing here I'm sharing now with proof of my light photomodulation thing you could do with your cell phone or even a laser. I have this document that says you can use a laser to modulate like glutamate tissue in your brain to be fired upon, and it would release it and allow like excitation of frequency to perform better in those areas in the brain. And you can just use a pin laser, if you modulate the frequency with whatever mathematical modulation scheme that would do that. That was like using a 3D hologram type stuff. Like I said, I have the articles on it, so I'm just barely learning all this. But I'm sharing this right now. Using light to transform species, Dr. Dezang Kang, again, if I said that right, repeated passages of polarized light with high frequency electromagnetic generator passed through a donor chamber with a duck to acceptor chamber with pregnant mother hen. It said the result was a hybrid chick duck with flat beaks, longer neck, webbing between toes, and large internal organs. And it said a repeat of experiment with 500 eggs, 480 chicks hatched. And it said 80% had flat bills, 90% had eyes moved to a position similar to ducks. 25%.
Sorry, just what's the relevance of this duck breeding? I'm only interrupting because my buddy Mike with Faraday is back, and I think he's got a demo he wants to show of one of his motors.
Oh, sure. Yeah, I want. Basically, it's basically light energy be used to affect information DNA that is transmitted to future generations. So they used a green laser through salamander eggs and then redirected into frog eggs, and the result was salamanders hatched from the frog eggs. So it was using light to transform species. So and this is by Dr. Peter Gararev. So it's like photomodulation can use the DNA's encoded information, like, you know, and you can actually literally change another entity or whatever, you know, in real time, probably transform it depending on the delay time and, you know, the phase shift. So it kind of goes back to the Montauk project and the Philadelphia experiment. So this is kind of like a proof of it, but with tissue.
Maybe that's what happened to me.
No, but this is
There
proof
may
of
be
it. I
some
mean,
fairly serious bioethics issues there with animal experimentation of a relatively drastic sort. I'm not sure what theoretical analysis they had done ahead of time for the safety of these animal experiments, but right, it might not. Some of this stuff might be a little bit questionable on an ethical front.
oh yeah, definitely. But this proves that everything has its information hologram code, which is, you know, the wave interactions modeled, you know, wave interference nodes, and, you know, that makes the hologram, and that's your information code, and you can use that to add something to else to change it to, you know, similar stuff. So this is like just a proof of it, and these are the two scientists that did it. So I'm sharing it on the thing.
Reminds
So.
me of reminiscent of Rupert Sheldrake's work.
Oh yeah, the morphogenic field, yeah. Oh. But I want to be quiet now because you said that Mark Faraday had something to, you know, so.
Yeah, so I was talking earlier about the end machine. Here it is. So I 3D printed everything. I use a high definition 3D printer. I'm using ceramic seated bearings. The only thing that's conductive are the two neodymium magnets inside the shaft, and then I got the two pickup brushes on the ends here. That's where you would pick up your amperage. So when I hook up a DC motor to it and I spin it at about 4,000 RPM, I get about 25 to 30 amps. Now, the original end machine by Bruce De Palma basically was a very large version of this. This is a miniature version of what he did. So the neodymium magnets, north poles are facing out, negative to the center. So when I did the
what's the input power?
Input power is just a regular DC motor that can do about 4,000 RPM.
And what's that motor power? How much power does it take to turn the motor?
To run it at 4,000 RPMs, it'd be about 10 watts.
So
give or take.
It's 120 volts. So I guess what I'm asking is, how much power are you getting out compared to how much power are you getting in?
Well, that's the thing. That's where Bruce De Palma kind of failed to prove the over unity of this machine, because you're getting a huge amount of current coming out of this, but very, very small voltage. Okay. So his machine was, I believe, about 800 pounds. So he
No,
was
I'm
getting
asking
about,
you about yours because see, this is with all these lightweight components. You've solved a problem that he didn't have a way to solve. You've got
well, see,
a
the biggest
lighter motor, right?
yeah, it's a
So
lot
I'm
more.
asking, in this case, this experiment you're doing, just guesstimate how much power are you putting into what you're getting out?
Well,
I mean, you
it's
could figure
under-
it out. It's a 120 volt motor, right?
Well, I'm using a DC motor.
Oh,
12 volt
DC, what is,
yeah.
how many volts?
12 volts at, I believe it was about 1 amp. So about 12 watts, say.
So 12 watts in, and you got.
Right. Now, this is where the problem is. Okay. You can get a huge amount of amperage out, but when it comes to the voltage potential, it's in the microvolts. That's the same problem that Bruce De Palma had. Okay. So he built a very, very large version of this where he was able to get 80 volts DC at 2,500 amps. Okay. So you would have
get up hook it up to a little power amplifier that you can buy at the heart.
Well, see, this is what I believe Peter Linderman was working on this years ago, back in the early 80s, when he was with Borderland Sciences. So what they did was they actually sectioned off the magnets. So it wouldn't be like a solid magnet all the way around. It would be sectionals, like almost like pie shape.
And would
all
they
the
go
way
the
around.
opposite? Would they?
No, it was the same poles all the way around, but what they did was they turned it basically into an oscillating current, put that through a step-up transformer, and then the results changed. That was the only way they were able to get the voltage where, they had all the amps in the world to work with, but no voltage. So
They had to modulate the amperage somehow.
That's right. They had to make that magnetic field into an AC oscillating current in order to get the voltage out.
Well, it's electromagnetic field you're talking about.
Right.
It's not the magnets. It's not a permanent magnet.
That's why they had to do each magnet in a pie shape.
So couldn't you make that with like permanent magnets?
Yeah, you could do it. You'd have to get the magnet specially cut to do what I want to do. It can be done. There's a company actually not too far from me that could probably do
Because
it.
maybe that's the problem. You're trying to use an electromagnet and you need a permanent magnet.
Well, these are permanent magnets, which I have in here now. They're those giant fishing magnets.
Right, but they're all the same direction.
That's right.
But you could get that cut up, couldn't you?
Yeah, I could probably go to that company and they could probably do a special order for me, and I would have to give them a schematic what I need.
Back together.
But what I was talking about earlier in the show was the fact that when I hit this thing with high voltage on the shaft, on the shaft, I hit it with 6 kVA. The things start to run across the table.
Oh, I see. Which direction?
Let's see. Look at it this way. It always went to the left for some reason. Always to the left. So that would be.
The drive. Which side had the drive motor on it?
Drive motors here.
Okay, and so when you put, and then on the other side, when you put a high voltage on the other side here.
Right.
You put 5 kV or something. Is that what you said?
5 to 6 kVA. Yep.
Okay. On that question. Then it started to move in the direction of the point where you were applying the high voltage, correct?
Correct.
Well,
So
more importantly, you said it kept going the same direction.
Yes.
Can you get a level and like something that can really tell minute differences in angle and check the table it's sitting on, make sure one side is not just slightly lower than the other? Because if you vibrate something and there's any kind of gradation, even if you can't see it, it'll slowly go and work its way down. It's what I noticed about the EM drive. They had it on a spindle,
right?
And they have this AC transformer built into the whole thing, right? Well, the AC transformer, if you've ever stood near one, they make a zzz.
Yeah, they buzz.
They're vibrating. And have you ever seen a pager that's kind of bubbled because the battery got damaged, and it swells up to make the bottom kind of rounded, and when it vibrates, it'll go and keep spinning around in a circle?
Right.
No wonder they were getting rotational energy, because they were vibrating the whole thing. And it was just because of the angle of whatever it was that was tilted, causing it to rotate in that angle.
Right. See, with my device, I did 2 tests. One with the voltage. It would vibrate a little bit, but not very much, because I got this thing pretty balanced. I've engineered it really, really good, to the point I had very, very little vibration even from the motor. But the second I added the voltage, that's where the anomaly happened.
Right.
So,
and I was going to say, that means that basically the waveform that you're putting in that, you said KVA, right?
Yes, 5 to 6,000 volts. Yeah.
So, but this is AC voltage you're pulsing into it, or pulsed DC?
It's a pulse DC.
Okay, pulses though, which means that you're generating vibration.
Now,
because you're shifting all of the electrons in the atoms on a regular time scale back forward, then letting them relax, then forward, then letting them relax, then
Right.
forward, then letting them relax.
And
That
it's got a
creates the whole
hysteresis,
thing.
so it's gonna take a while. It's
That's
gonna have a
true.
built natural.
That depends on how much time delay between each pulse there is. Because if
Yeah,
there's not
see-
enough and it retains that, then it's going to reduce the amount, but you're still always going to have a diminishment on the hysteresis. Hysteresis is not 100%.
Right.
Like it won't
Yeah,
hold 100%.
yeah.
It immediately starts losing. So you're
Right.
just looking at like smaller and smaller hills, the
like
more
this.
See,
hysteresis there is.
yeah, the frequency is about 43 kilocycles.
Okay. So that,
So
that's
it's
still a frequency. And here's the thing. Your vibration rate is still higher than the diameter of your individual atoms, meaning there's more than enough energy to cause it to lift off, then drop on the next and roll down over. And if you look at atomic structures on that level, you're literally looking at millions of little tiny ball bearings jammed together. So any
Right.
vibration is going to cause it to go just slide right down that thing.
Yeah, I just thought it was kind of odd.
So you measured that the platform that your apparatus was totally level?
Yeah, oh yeah, it was a level table, yeah. And it was a solid pine, so.
Even when was it level even when you were applying that high voltage and
Yeah,
and had
same.
everything up?
Yep, all the whole setup was exactly the same. Yeah.
Would you put a force gauge on the opposite side of the table to measure how much pull it had on it?
Honestly, at that time, I'm working on energy devices. I wasn't working on any, gravitic devices at all.
Well, work is energy.
Know what I mean? Yeah. No,
That's
it's
what
true.
you're doing. You're doing work. So if you're doing work, you got energy. So can't have work without energy.
That's right.
You're working with
It's true.
electromagnetic alternative energy, I'm assuming, using
Yeah.
like magnetic structures and electrical generation and
Yeah,
electrical
that's
generation to
more
create
of,
magnetic fields to try to create this. I already have a design for a magnet to magnet, like permanent magnet system that you can either use if it's designed for a generator. It doesn't matter how much power you're pulling out of it because it doesn't create drag the way the cogging effect does whenever you hook your wires up and your magnets are trying to go by, because the magnet and the coil are stationary.
Right.
You're only shutting the magnetic field off and then releasing that magnetic field, and the flow past the magnet is not being interfered because there's just as much attraction when it's allowed to pass through to the plate that's passing over as there is when it's blocking the field. Right.
Right. See, like
The other well, now hold on. The other aspect is that if it's built in the motor configuration, it'll generate torque, but it'll never give you any electricity. So you build two of these and tie them together, you can have continuous power that's coming from literally thermal energy is where it's coming from. The thermal energy causing the minute vibrations in the material that the magnets are made out of are causing electron exchange through a crystalline structure that keeps generating an electromagnetic response on an atomic level.
Right.
So if you look at a neodymium magnet, right, on the atomic scale, every single chunk that is a magnetic field is literally 7 iron atoms in a ferromagnetic state on either side of a boron atom that creates a diamagnetic reflection into the iron to increase its magnetic field. Like you're literally taking all of its energy and forcing it back into it and back out the other ends, and then it's capped off on the ends by 2 paramagnetic magnetic lenses of 2 neodymium atoms. And then you start stacking those together. As long as the electrons can be shared through the crystal structure, you get this massive amount of power. The second you break that crystalline electromagnetic or the electron exchange, like say a nickel plating or coating it with like epoxy or something like that, now you start getting a diminishing return because you've only got a little bit of the energy plus the energy in the next magnet that you can increase that amount of magnetic energy. You remove that material between the two and jam the two together. Now you massively increase the magnetic output of the whole thing because you're allowing those electrons to travel all the way through the entirety of the material from one side to the other.
Right. And basically from the axle out. So all the magnetic flux is being forced to the leading edge, and that's where I pick up the amps off the leading edge of the magnet. So
well, have you used magnetic structure, permanent magnetic structure isolation and made the mistake of looking at it like you're redirecting the magnetic field, or are you aware that it's actually absorption and either focus or diminishment spread out in order to limit the magnetic field and then increase the magnetic field? Because that's the one thing I see everybody makes. They think if you put a shield around it and you have the north facing this way or that way, and then you rotate it, that it changes the angle that it's at, and it's not. It's just diminishing the amount of the bubble that's sticking out of your magnetic shielding. Because a magnetic shield wrapped around a magnet is about like putting a corset around like a balloon and squeezing it. It causes it to pop out the ends. So you're rolling across that bubble constantly. You can reduce the amount of bubble by rotating it, but it's still a bubble. So that means you still got as much rise as you got fall. So you're not gaining any ground, right? But when you have a magnetic field entering into what's considered a magnetic shield that's very small and long, it will poke out the other end of the shield, right? So kind of like when you take a magnet and you stick it to like a paper clip and then use that paper clip to pick up another paper clip.
Right.
But if you have a flat plate with layers that create a reversal on each other, you can take that magnetic field that's hitting that plate and have it soak into
you're
flat
bang
plane.
on, Thomas, and it has to. That's like the nano layers of these monoatomics when they crystalline, and then it's these single layered.
Well, you're talking about materials though that are hard to make. It's real easy.
I'm proving
Listen,
really
for
easy to
magnetic
make.
structure, it's really easy to just take some steel sheet and some solid bismuth and some rosin flux and just pin the surface of it and then stack those up.
Yeah, exactly.
Anybody
and
can do
what
that.
I'm saying is through this electrolysis process that I'm finding is that it's actually a very cheap and easy way to make these layers to start being able to then do exactly what you're talking about and applying.
The thing you're deep into, I wonder if you could do some digging and try to come up with an effective way to electroplate bismuth.
Yeah, I've got a few experiments I've done with bismuth, and it's.
I'll say everything I've done, puts like a black powder coating on anything. And all the research I've done, you have to work with bismuth chloride, which is really hard to maintain.
I
Because
don't
the second it comes into contact with
chemicals.
water, it turns straight into bismuth oxychloride, which is
Hey guys,
like a mother of pearl look.
I'm going to sign off. It's been fun.
For sure, yeah. It's about time to get ending here. I'm gonna have to with Mike. Boyd, we'll talk here in the next few days, but get Faraday, Mike, and myself to do a presentation with Tim here, where we can actually do some scheduled, organized revelations of what we're working with and discovering here.
Right.
Okay, thanks.
Yeah, I was gonna say the reason I backed out of the magnetic stuff was because I found a much more effective means of that thermal harvesting through airflow static. Air is always moving at 700 miles per hour, all the gas particles. So if you have two layers of material that can collect electrons or give away electrons to air that's bouncing back and forth between them, you can have as much energy as you want. And this is the thing, it's strictly thermal energy. And we're not talking about thermal flow, we're talking about the thermal mass that's within a volume. Even if it's completely evenly thermally mated, those gas particles have to be moving at 700 miles per hour in order to create that 1 ton per square meter of pressure that you get out of a gas particle. Otherwise, it becomes a liquid. So anything that stays in that gas particle state, man, you got tons of energy that can even be pulled out of just minute amounts of thermal energy.
Yeah, could I just add something? I did the experiment. I used to test a plasma ball, and I get these plates on either side of the plasma ball, and I tap off it, and I can light up, regular light bulbs with the plasma. So I'm creating that flux field, and I'm finding the plates itself are acting like not a dielectric, but as a capacitor. And that flux field is immersing itself into that metal, and I'm able to extract that. Now, here's the beauty part. I could put 15 of those plates and extract it 15 times and get the same power with the same power input.
Have you thought about changing the shape in order to basically concentrate it?
Yeah.
Because the metal you're working with that the magnetic field is hitting,
yeah,
the structure shape difference doesn't look the same, or the shape doesn't look the same as it does with a lensing system for lighting, but you can get metal to focus a magnetic field or to diffuse it.
Yeah, so when I was actually, I have an idea that I was going to make a miniature version of a Dyson sphere using the plasma ball in the middle.
Is Mark around? I'm trying to actually share, but it won't let me right now. Your one of your videos, Mike, of exactly what you're trying to describe that you have up on your channel.
Yeah, so what I was thinking is setting up a rig that would kind of emulate what a Dyson sphere would be. The plasma ball be in the middle, and then I would create this fake globe around it and put the plates in strategic areas all around the plasma ball and extract all the power from there. So there would be like maybe a 1/4 inch gap between the plasma ball glass and the actual outside cage, I guess you could say I would be building on the outside. But like I said, the more plates you add to it, you're
You need to talk to
multiplying the
Shaziz.
power.
I really need to put you in contact with Shaziz. He's been working with plasma-based technology for quite a while for alternative energy purposes.
Yeah, plasma. I'm finding
work
more
well
and
together.
more. Yeah, I'm finding plasma is a really interesting field to be in because the fact that I could light up stuff from several feet away with such little power.
I'm still waiting for somebody to figure out that you can use.
There it is, Bernie.
What is it?
Yeah,
Shape. Use the same effect with magnetic fields that you get for like the nuclear explosion. They had to use shaped charges in order to create a concave pressure rather than a convex pressure, because the convex pressure created weak points in the wall pressing in that all of the pressure would escape through before they could hit critical mass. But the concave based explosions inward, there was no weak point around the edges before it hit critical mass. And if you could do the same thing with magnetic fields, you could probably hit that critical mass for fusion that you're needing to maintain that plasma.
Yeah, I find the bigger. Yeah, I'm finding the bigger the plates are too, more of that magnetic flux adheres to the plate and actually acts as essentially like a capacitor. A high voltage capacitor.
I would say I think the secret to the magnetically shaped charge is in what Michael was talking about with the hysteresis, using different hysteresis rate materials in your system.
Right. So like say like even like a graphene type shielded like a spray on the metal plate itself would actually turn that plate into like a capacitor, right? And store that power, not only collect the power, but it actually stores it at the same time.
Graphene is definitely something that we need to get a lock on an easier method to manufacture, because I believe that is going to be the secret to fully unlocking the potential of the electrostatic from atmospheric momentum.
Electricity. Yeah.
Because
there's
this is the thing. If you work with two disparate materials like urethane, which has a high positive polaric state when it comes to triboelectric generation, and then Teflon, which has an extremely high negative triboelectric state, you don't want to modify that triboelectric state with something you're covering to collect your electricity, and all metals will. But carbon is completely neutral. So if you put a fine layer of conductive carbon over the surface of that, the gas particles striking the carbon of that graphene will transfer or pick up their electrostatic energy from material that the carbon is coating, because it'll be like if you've got it coating.
It's like a dielectric.
Teflon. Well, no, if you
sorry guys, just to interject quickly, I kept trying to load your video there, Mike, but because I'm running StreamYard and Zoom simultaneously, screwing me over. Can somebody else I posted the link of Mike's work there, specifically what you guys are talking about in the chat. If someone else can just open it on YouTube and then share it, it should work properly.
Yeah, I think the significant part of the actual experiment is the fact that you can add as many plates as you want in that field, and you can multiply the power without any extra power input. I think that's the significance of that experiment. So you could put 15, 20, 30 plates, as long as it's picking up that field, that static field that the plasma ball's emitting, you can just keep adding light bulbs and keep adding them because you don't have to add any extra power to the system.
That's the signal gain, right? When the amplitudes are evenly constructively on each other, right?
Yeah, well, each plate is isolated from each other. All right.
Okay.
Now, if you ground that plate, it kills it. So it's got to be basically totally isolated, one wire coming off. So I've been actually able to light light bulbs with one wire. I don't need a ground. But as soon as I introduce a ground to the circuit, the amount of amperage increases quite a bit. So it's actually taking a lot of the power from the ground as well. But I can light light bulbs with one wire.
Okay, pretty cool. Now I was just trying to figure out, like, 'cause like I said, I'm in the signal analysis, so I'm just basically going off like a Fourier series type thing, like that one guy was saying. Can't remember his name. He mentioned it earlier.
Bruce De Palma or
shoot. I don't remember. He was like it could be Bruce De Palma, but
oh,
remind
Adam
me-
Tremblay was doing it as well.
Yeah, I think
he
he was talking about it. Yeah,
Yeah, Adam Tremblay. Yeah, he was working on it. He was actually stopped by the U.S. government, and he was suppressed pretty badly. So he kind of dropped off.
Hey everybody, welcome back to
No,
Faraday
that's not it,
Research.
Bernie.
It's
That's
Thursday
not it,
night,
Bernie.
or actually Wednesday night, sorry. Yeah,
That's
if you
not it, Bernie.
haven't subscribed to my channel, bottom right-hand corner, all the links are in the description for my Patreon and also
I
my
don't know. I'm
PayPal.
trying.
You
So,
can
Mike,
donate
if you
there.
can find the right
Thank
one
you
to
to
play, it would be
Yeah, it's
all
not
those
it.
people that donated to my channel.
Yeah, you'll see the plasma ball on the screen. You had it earlier, but you didn't bring it up.
Well, Bernie's dad made a plasma ball. I remember that circuit board thing he constructed. It had like a purple gas like emitting from on the top, and it played the FM radio, whichever.
Oh, right,
side
yeah.
was charged it. That was cool. I always and
I
that
didn't-
solves the UFO thing where they create those plasma balls. Supposedly, you hear rumors of these like purple energy spheres where they start hearing like different sounds and transmission. Like that's probably how they do it. So.
Well, I think a plasma is definitely something that they're using in their craft. I
Well,
could be
but-
wrong, but
No. Well, these are pure energy, that they're
Mhm.
using to even broadcast, sounds through. It's not even a craft. It's like like a hologram based thing, but it's not a hologram. It's made of pure, plasmatic electricity, bunched together or whatever.
right.
So, yeah.
Hold on, I just want to show. This is one of the transformers I'm
Moby's
working
cool.
with right now. This one's a beast. This thing weighs like 25 pounds. It's like unbelievably heavy. So this one here, I was able to patch in on this wire here, and I had 3 outputs. But the thing is, I had 37 watts going out, but I only had 12 watts going in. So I didn't have to pull any more power, and I'm getting 3 times more output with this toroid. That's with the Don Smith generator.
So that's
So-
essentially through magnetic induction of the transformer that you're able to get that.
Well, it's holding the flux inside the transformer. So when I actually disconnected the power source and I started fiddling with a couple of the other wires, I got shocked. So it's holding a capacitance within the core. Now, because it's a toroidal, there's no beginning, no end. So that magnetic flux, the field of the magnetic field is trapped, not like an open-end coil where it could go out and disappear, where in the toroid, there's no beginning, there's no end, it's trapped within itself. So that field takes longer to collapse. But that would explain why, when the power was already off, I still got shocked, because that field was still trapped in the core. Enough to give me a good lifter, but nothing lethal. But yeah, that's just some of the stuff I'm working on right now. This thing's a beast, absolute beast. It's 6-inch diameter, and it's about 1.5 inches thick.
You have something to say, or you're muted there, brother? I saw your lips mute, or are you talking to your YouTube channel?
You talking to me, Bernie, or
The alien scientist there.
oh,
There.
oh, Jeremy?
There you are, brother. How you doing, my friend?
How's it going? Sorry, I didn't hear the question. I'm doing a bunch of other stuff. I had the volume turned down, so I'm just I got a couple of things I'm working on.
Yeah, did you see the end machine I was working on?
Yeah, I saw you holding that. That's an interesting
Yeah, so
experiment.
ceramic bearings. The only thing that's conductive on it are the two neodymium magnets, the shaft, and then the pickup brushes on the ends. And yeah, I was getting about 25 amps coming off this thing, but very, very little voltage, in the microvolts. But Bruce De Palma's machine was about 800 pounds, so he was getting a lot more on the output too. Plus, he was using his contacts were mercury, so he was using some toxic material to actually make like a frictionless type brush.
So since we're in open discussion now, I had a couple things I wanted to bring up earlier, but I was busy putting my kid to bed, so I wasn't available. But you guys can see my screen. Mike McCulloch, he's as you know, he's got a couple DARPA contracts going on over there in the UK, and he posted this on Twitter recently. He said, "I cannot say why here, but I'm in a happy haze period. Bad news travels fast. Good news has NDAs." Smiley face. So I thought that was super interesting, because that's one of the groups that has DARPA contracts for, what we call anti-gravity research, or, alternative propulsion research. And, he's definitely one of the people we watch. So when he said that, March 10th, a couple days ago, 3 days ago now, 2 days ago now, I took notice. I took a screenshot of it, and I just wanted to show it here, so we have it on record here in channel 2.
So we have people watching.
I have a question about that. The one-dimensional of the nanomaterials, is that one-dimensional like even lower than, like, I guess you could say your computer screen is like the interface with the is like considered the two-dimensional? Just out of
Screen is
curiosity.
your 1D level, and then you're adding hyperdimensional fractals into displaying multiple dimensions onto that 1D.
Okay, so the computer your computer interface would be 2D or 1D, and neat. I have an article that's experimenting with like 2D dimensional stuff that's a little out there, but the guy says that he getting energy harmonics like at the gold frequency and crap. He said something ultraviolet. So I might post it in a second. I'm looking for it. So I'm muting right now. Hold on.
Yeah, it's like I kind of sitting on the sidelines because everybody's talking about the anti-gravity stuff. I'm more into the energy stuff, but there is correlation. There is kind of this mesh together with energy and anti-gravity, and so yeah, there is a relationship. I'm just kind of focused on the other end.
Right. Yeah. So as far as the energy goes, there's a couple people we should maybe look into getting on here to talk about some of that stuff.
Yeah,
of course.
I'm actually sorry to cut you off. Yeah, I'm working on another project right now where I'm working on a special battery that basically never runs out of power. So I'm sourcing out the materials for this battery, and I'll be making that soon. A few people out there have made it and have had great success with this
Is that in
battery.
regards to Hutchinson's crystal battery, and then
This one's
something a
slightly
little
different. This one's slightly different. It more stems towards Stubblefield's Earth battery.
Okay.
And yeah, so I've been studying Stubblefield for the last couple of weeks now, and I'm finding some interesting information that actually Tesla was witness to back in the 1800s. He actually went to Stubblefield's farm and witnessed his basically first wireless telephone. So I don't think Tesla was the first. I think Stubblefield was before Tesla, which I didn't know.
Tesla didn't design a lot of the things that people keep attributing to him. He recognized the capability of interfacing these things and bringing them together that the individuals who created them did not.
Right.
So
Right.
he could bring
That's-
several minds. He was basically bringing several minds together to create something phenomenally beyond what either one of those minds could produce on their own.
Right, that's why he called it radiant energy. He just took what Stubblefield had and repackaged it and gave it a new name.
Well, he had an ability that a lot of those people didn't have, where he would build something in his head and let it run through a full destructive process real time in his head, and then come back and tear it apart to see what went wrong, what effects it had, how useful it was in different ways and whatnot. But these other people, they could see, a one-dimensional aspect of something they were working at, whereas he's working in full 3D simulation,
You're right.
and
Right.
running it along the four-dimensional, time strain that as he lived throughout his life.
Yeah.
So
Yeah. So
that collaboration, I think, is important. That's why I said a research facility where energy, manufacture technology, and the travel technology, I'll call it that, because it could be any number of things, would really be useful to put a facility like that together where all three are working together to come to a single conclusion. So
Yeah, because,
meaning, pushing all this stuff forward, get
That's
it
right.
more advanced.
Yeah, because the anti-gravity needs power, right? And then, it just goes hand in hand together. I think they're one and the same.
Well, like I said,
realize
you're
it.
going to find a lot of evidence in things that you're working on something completely different, that somebody else may go, hey, wait a minute, I've been trying to create that effect there. The one that you're complaining about that's causing you a problem, I know how to use that. And if we learn how to use it, I might be able to figure out how to negate it from what you're doing so that you can get the effect that you're trying to get.
Right.
Pieces of the puzzle fitting together, basically. So.
Yep.
I still think, though, that it needs to be designed entirely like the interior of some sort of starship or a starbase, and then broadcast it constantly and monetize it. That way, it can basically pay for its own advancement from the sheer entertainment factor that people get on getting to peer into things and see what's going on, and they become witnesses
or giving
without
people
having
the
without
to
straining to do
reduce their
so.
energy bills with this.
Like I said, if you got all these people watching out of entertainment, they're all witnesses now. You can't silence a million witnesses, So.
It's that if once we are able to figure out even just like some sort of electromagnetic, possibly plasma interaction, electric component, essentially what these free energy devices seem to have the potential of, but just like if it's reducing people's electrical load off of their house by 30% or 40% in this day and time, that's a lot of both green energy that is not going to be taken out of the ground in oil or disasters, anything like that. And
Hey, you should get a little more simple. They're not concerned about taking oil out of the ground.
No,
You know
no,
what the real
that's what I'm
concern.
talking about. I'm
Anybody
just talking
who's
about
serious
there's
about that,
gonna be
their concern is the heat.
that you plug into your
Right,
home,
but their concern is the heat.
reduces by 30% your electrical load that you're using each month. Then it's
Right.
going to take 1/3 of your power bill each month. That's huge to a lot of people in this day and
Oh
age.
yeah.
Insane
Well,
market.
imagine going a step further and reducing it by 100%.
Yeah, but one step at a time, right? It's even if you get something that we can make.
Hey, I'm a 2 steps type of person, man. When I'm going up the stairs, I usually take 2 to 3 steps at a time when I'm in a hurry. And that's why I said though, green energy is not green energy. They have a small section that's concerned about the toxicity, but the majority of those people are concerned about the gases that are pumped into the air that are helping trap solar energy so that it cannot escape fast enough, causing the entire planet to raise temperature. No. Listen, this is important. If we find a way to turn static thermal energy into electricity, you're lowering that temperature ratio and you're producing all the power you need. You're totally killing 2 birds with 1 stone.
And that's what we're kind of like working on with the Don Smith aspect, the double spark gap, where it's using radiant energy through the plasma of the spark gap arcs. That
You're
is
talking about using that to basically crack water to make oxyhydro power.
Yeah, you can do that too. Actually, you don't even have to do that anymore. It's what's his name? Walt Jenkins came up with a new way of coming up with the nanocrystal plasmoids that Kenneth Shoulders was working on in a device that didn't even involve electrolysis at all. As he used these, the machines that you would see that would create like the mist, those mister things, ultrasonic misters.
ionized foggers, yeah, exactly.
Yeah, the foggers. So he would take that and he would
mist of actual water. That's the key. Is the gas plasmoid is still in its water state. It's not a hydrogen state. It's not an oxygen state.
Right.
The supposed brown gases.
That sounds like something that would benefit from using tuned lasers to basically blast the mist after it comes off of that.
Yeah,
where you're using
that,
two frequencies of laser. One targets the oxygen, the other one targets the hydrogen, making it
Well,
very easy to just pull those 2 apart.
Well, see, his experiment, he was creating this fog, putting it through a chamber where it gets hit by high voltage. And the high voltage is what was creating the nanocluster plasmoids. And that is the gas that all these guys that are doing those hydrogen generators in their car right now, they're thinking that they're using hydrogen. Well, the real power was actually getting fused in the water. It wasn't actually getting out. So if you cavitate the water, or based on certain aspects of the design of your electrolyzer, you can get those nano clusters out and into the engine. That's where the real power is. It's not the hydrogen. So Walt Jenkins came up with a device that eliminated the electrolysis process completely. It's gone. You don't need it. He created the fog. He hit the fog with the high voltage electricity. That's what went into the engine. So he eliminated, that aspect of.
I'll say I have equipment for lipus experiments. You familiar with that?
No.
It's an acronym for low intensity pulsed ultrasound.
Okay, so basically these things kind of
Regrow
work on
teeth.
this.
Like you get a
Oh,
tooth,
really?
it'll activate the stem cells to go, hey, there's a tooth supposed to be here. It's not here, so we're going to turn into dentine cells, and now you have a new tooth.
Well, I got a tooth missing here. Maybe you could help me.
I have a few. That's part of what got me started. But then I realized that this technology could probably be used if it could be introduced deep enough into the body.
Right.
Because what you're doing when you convert a stem cell into any other type of cell is you're starting with that baby age.
Right.
Telomeres and all the other components. So it basically has the 80-year lifespan within that cell, starting at ground zero. So if you're at 60 and you replace even 2% of all of your cells with stem cells, they will eventually replicate and replace all the ones as they age out. And you're now at maybe a 20 or 30-year-old age overall physically. Now, if you can get the stem cells to replicate themselves so that you've got baby stem cells always on tap, you're looking at like almost permanent life extension right there. And at that point, then you just be a little more careful, because you might actually, if you don't, screw up and get into an accident that kills you, you could live to 10, 15,000 years. And imagine the accomplishment you could have, not only reaching that age, but also always having that plasticity of mind, where you can always, work on new ideas and invest in the new
you know what?
concepts. So
even extending your life, say, like 50 years. You know what
Well,
I
that's
mean?
just it. If you extend your lifespan by 50 years, within 50 years, how many life extension techniques will come up?
Exactly.
If you're not dead yet, you could very well be in that ground zero of never dying of old age.
Yeah,
Pure
immortality.
old age.
Immortal.
So not immortal. Immortal means you can't die. Just age is a
Greatly
disease.
extend it.
Well, no, age is a disease. We cure that disease, which is much. You look at every disease we've got on the planet. The most deadly disease on planet Earth is age, because if you avoid all the other diseases, you're lucky enough to avoid all those, you're guaranteed to get hit by old age.
Right.
You know, so let's cure that one too. That way, basically, we would make it basically one of those things where you, due to lack of aging, will now have to worry about cancer, because eventually you will have to deal with it. So now we've got to focus on solving the cancer problem too, so that way we don't have that coming along and knocking us out, because, you know, we just don't have the aging process to age us out before we can get hit by that statistical anomaly.
Well, they did research with biophotons to where if more photons accumulate in like the tubulin of DNA, that the rest of it will cause like a chain effect to fix whatever else is needed that's missing, and basically reversing age. So that you should probably, there's tons of research documents on coherent biophotons curing all types of things, including cancer and stuff.
I'm assuming they're looking at a macroorganism scale when they're talking about reversing age, which means it may not be reversing cellular age, it's reversing the organism's age by activating something that is a younger state and bringing in new fresh cells to replace old dead cells. That's
Well,
what the
no,
likeness is doing.
it's
So
even more than that. It's like it creates the components that are not even present that are needed in the body, that from it generates it on its own from previous combinations to make what is next needed down the line from outside, you know, regardless of any external source going in. You know, like any chemical needed, like it produces it on its own, like a self-organizing resonance.
well, that's what the likeness is doing. You're taking something that's already in your body that has been shut down,
Yeah.
so that it can't do the job that it was supposed to do, and busting that halting mechanism off of the genetic code, so that it can now do what it's supposed to do. And as soon as it's activated, it goes, "What's missing that I need to now become?" So
Yeah, so basically a frequency resonance is what you're doing, right? You're just trying to find the right modulation.
right frequency to affect the right chemical that's affixed.
Yeah, that's like
so
the
that it's not interfering with it anymore.
yeah, that's like the using a laser with the right frequency information to say speed up brain frequency to cause excitation in some neurons, like they do with the glutamate blasting. And it doesn't require much. I'm sharing an article here that is similar to that frequency type thing, where they're talking about information batteries, where they changed like the time duty cycles of the computation itself in like circuit boards and regular computers, you know, just by the software and not even the hardware board itself. And they actually managed to decrease actual power needed by 30% to do these mathematical computations in the circuit board. They actually reduced excess heat or power required. So it's like the frequency itself is like the energy source equivalent to like biological. So what I'm trying to say is like it's like they've got I guess these information batteries are like the one-dimensional span. If you know what I'm saying, like it. I guess if you fix the modulation phases, you get more efficiency and power. So this article right here is just proving like concept of what I've been talking about. So anyways, go ahead. I'm just.
Yeah, guys, I'm gonna have to head out here. It was great to talk to all of you, and I'll pop on again soon.
Awesome. Thanks, Alex. Is that your name, Alex?
No, Mike.
Mike, sorry.
Yeah.
I'm going to be going to bed here soon, too, and I'm about to shut the stream down. We're at 7 hours going strong,
Take care, guys.
and I'm getting tired. My kid went to bed like 2 hours ago, so he's going to be up at like 5 a.m. and I need to get that sleep in. So cheers all, and great discussion. Awesome time. Lots of cool stuff. I didn't expect that from Ricardo Storti at all with the Bob Lazar thing, and I'm gonna have to get a hold of that and repost that tomorrow for people who missed that on my little glitch that I had. So I'm gonna try and get that up for you guys as soon as possible. But yeah, thank you all and have a good night, and I'll do an update tomorrow on some stuff too.
Sounds good. Much love, brothers. Thank you. And yeah, hopefully we can do a multi-stream together here sometime in the next week or so.
Definitely. All right. Thank you all and have a good night. Peace out.